Hello, my dear JEE warriors. Finally, the countdown has begun and there is no time to waste. But we have to focus only on those things which are necessary so that you do not regret the last few days of your preparation and you are benefited the most with those important sessions. And this is one such important session, which are basically the most repeated models of questions from physics, maths and chemistry. Over the last 5 years, we have done the analysis and we have jotted down certain models and patterns which you should do. See, there are always some questions which might not be repeated. Those things are just to be solved spontaneously. But those things which get repeated, you must be fully aware of it and you should be, so spontaneous. The moment you see the question, you should be able to solve it. That's how you save time and do those remaining questions as well. So let's begin with physics, then we'll go to maths and then we'll go to chemistry. Hello Navadeep, hello Ramcha, good afternoon PJ, Chatra, Roshni, Unknown, Vanilla. Nice to see all of you over here, and this is my small introduction slide. Make sure that you have smashed the like button for this video, because that's the way YouTube understands that yes, this student is serious about JEE and it will keep all the distractions away. So it will suggest you only videos related to JEE. And if you're new to the channel, do me one favor. First of all, subscribe to the channel, because the paper discussions are going to happen on this channel. So you don't want to miss any one of them. Hello Abu, hello Mahesh, hello Naga. So I hope you guys are all ready to start the problem solving of the most repeated patterns. This is going to be the most important session. And let me also remind you, as you are going to pass out, there is a huge responsibility on all of you, and that is to guide your juniors, to help your friends in your society, in your school, in your coaching, who probably might be clueless or who might not be getting the best of the best training. So the responsibility lies on your shoulders as you pass out, and you are going to go to a good college for sure this year. So you need to tell them about the Vedantu Learning Center, which has the best of the best facilities. Be it your dedicated academic mentors, which are special people who have been trained to handle students' queries, their doubts, their problems, right? This is very, very rare to find, and Vedantu gives it at all our offline centers, along with the digital classrooms and the smart clickers like Kaun Banega Crorepati, where you can choose your options as the quizzes go on in the class. And of course, doubt solving in a 3-way doubt support in the class, after the class at the center, and even after going home. So all 3 modes of doubt helping, including your in-class quizzes, your PDFs which are available after the class. Even if you miss the class, you can download them. The class recording of an offline institute is available. Just imagine your entire class gets recorded. So even if you want to do a recap, revision, all those facilities are there with you. So Vedantu Learning Centers are there at many places. Make sure you visit them, or if you are going to pass out, then obviously you need to tell about these centers to your juniors as well. Just have a visit and see how these classrooms are. Experience it for yourself. I wouldn't say more, right? So that is your responsibility, my dear students, to ensure that maximum students get benefited from the Vedantu Learning Center. So let's go with the first question coming up on your screen, which says the velocity of a body is related to the displacement x by v's root 5000 plus 24x meters per second. Then what do you think is the acceleration of the body? I feel that after looking at the question, I can solve this very quickly. But are you able to see that idea in this problem? Are you able to see the trick in this problem is the real question. Good afternoon, everyone. Good afternoon. Come on, think about it. Is there a trick? Is there a trick which you are able to see? I feel the trick lies over here. Look at this. Velocity is nothing but root of 500 plus 24x. Square it, it will become v square is 500 plus 24 times x. Now, why not write it as v square is equal to root of 500 square plus 2 into 12 into x. Why did I write it like that? This reminds me of the equation v square is u square plus 2 into a into s. Compare both of them. Quickly you will realize that acceleration is nothing but going to be 12. So you don't have to use any derivatives or integration. The answer is found out within 3 steps. Isn't this a fascinating problem? Did you love this? Yes, it is. Oh, it is 5000. Sorry. Okay, it is 5000. So put one more 0, doesn't matter in this case. So root of 5000 square. So that would be your u square, but we were concentrating over here on the acceleration. So acceleration is going to be 12. No need of derivatives and integration. Moving on to the next question. If the percentage error in measuring the length and the diameter of a wire are 0.1% each, what is the percentage error in its resistance? Whenever you get errors problem, always try to remember a formula or make a formula from whatever laws or other things that you know. So we all know resistance is resistivity into length divided by area. Length is given, diameter is given. So convert area into diameter like this. Rho L into pi times the diameter square by 4. So it will become 4 rho by pi, length raised to 1, diameter raised to -2. 4 rho and pi are constants. Resistance is dependent on length as well as diameter. So the relative error in resistance according to the error formula is take the relative error in length, take the relative error in diameter, multiply it with the modulus of the powers. Length's power is 1, so modulus of 1 is 1 only. Modulus of -2 is 2, so 2 into this. That's it. And let's say we express all of this in percentage, so the final answer will also be in percentage. The error in length is basically 0.1%. And the error in diameter is also 0.1%. So this will become basically 0.3% is the percentage error in the resistance, which is D for Delhi. See if you guys got it. Very good Kamini, very good Shivani, very good Kishore, excellent Nikhil, Sumati, Hasini. Wow, you guys are quick and I'm really proud of all of you. Yeah, awesome. So Navdeep, I would suggest you one thing. If you want a specific video on a specific topic, can you do one thing on this particular channel only, right? As you're watching this video, let's say you want electrostatics, just search for electrostatics. Okay, example. So you will find detailed classes of those particular topics. Let's say you want to find more about, resistance, how to find equivalent resistance. So there was a special lecture just for finding equivalent resistance or even capacitance. Just say search and you will see current, electricity, power, series and parallel resistance, right? All these special classes I have taken on this channel. So you can directly search for it. So your doubts will be cleared. Because if there is a small thing which you are not clear of, I feel it is the best to spend that quality 1 hour or 1.5 hours of time even at the last moment and get your doubts clear. Okay, so that in the exam you have no questions or no doubts in your mind. Okay, a block is moving horizontally on a smooth surface with a speed of 40, splits into 2 parts in the mass ratio 1:2. The smaller part is moving continuously in the same direction even after the split, but the fractional change in the kinetic energy is what is asked. So read the question again. What will be the first step in doing these questions? It would be obviously drawing the diagram, because diagram is not given. So just imagine a mass of 3m. Why 3m? Because the ratio in which it splits is 1:2. 1 plus 2 is 3. So make it as 3m. And it is going with a speed of basically 40 meters per second. After the explosion or whatever, the smaller part is moving at 60 meters per second. So let's say this is smaller part. It is moving at slightly higher speed, 60 meters per second. That is the smaller mass. The bigger mass, 2m, I do not know what the speed is. I will just assume it as v. Conserve momentum and see what do you get. Conserve momentum. Initial momentum is mass into velocity. Final momentum is nothing but 2m into v plus m into 60. You can clearly see m gets cancelled, right? So 3 into 4 is 12. So 120 over here is equal to 2 times V plus 60. Divided by 2, you will get 60 is equal to V plus 30. So therefore, V is equal to 60 minus 30, which is just 30 meters per second. Is this point clear? The first thing that we did is finding the velocity. Everybody clear till this point? But that is not the question. The question is the fractional change of the kinetic energy they have asked. So fractional change of the kinetic energy. Fractional change of kinetic energy. The fractional change of kinetic energy is the change of the kinetic energy of the system upon the initial kinetic energy. So final kinetic energy will be half mass into this speed square, okay, 60 square, plus half 2m, the 2m mass got 30 speeds, so 2m into 30 square minus the original energy half 3m 40 square, which is half 3m 40 square. I'll put modulus because I don't know who is big, so I'll just put modulus over here, divided by initial, which is half into 3m into 40 square. Half m everywhere will get cancelled, and you will be left with 60 square plus 30 square minus 3 multiplied by 40 square, the whole thing divided by 3 multiplied by 40 square. If you want, you can cancel the zeros also. So it will become 6 square plus 3 square minus 3 multiplied by 4 square, the whole thing divided by 3 multiplied by 4 square over here. Just do the math and tell me what is it that you are getting. Kishore is saying 1 by 4. Just check it out once again. Are you getting it as 1 by 4 or something else? See if you are getting it as 1 by 8. This is what, you know, the solution is also saying. You should get this as 1 by 8. See if you have done any silly mistake right over here. See if you have done any silly mistake right over here. Just think about it. This was 2 also. Yes, I should also put 2 over here. Just 1 second. So this would be also 2 into 30 square. This is plus 2 into 3 square. I think I forgot that 2 over here. Yeah, now it is fine. Yes, just check it out if you are getting it as 1 by 8. Yes. Very good. Victory is getting it as 1 by 8. Siva Prasad also getting it as 1 by 8. Excelente. Yes, Shiny, I put it up. All right. Great. Very good. So this is how this problem had to be done. Usually these collision problems will involve momentum conservation. In this problem, restitution was not involved. So here you will say energy question or energy equation was needed. Some problems need restitution. Some problems might need energy. So depends from problem to problem. All right. So these are again commonly repeated questions on collisions. Two blocks of certain masses are on a straight line with some coordinates. The block of 10 kg is moved on the same line through a distance of 6 towards the other block. The distance through which the other block must be moved to keep the center of mass unchanged is. So imagine this was your 10 kg mass and imagine this was your 30 kg mass, and then what happens is the 10 kg mass is moved by how much? 6 centimeters towards the other block. Obviously 30 will also have to be moved here by some centimeters so that their center of mass which is there, the center of mass will be at basically rest. So the equation for that is, for the center of mass to be at rest, m1s1 plus m2s2 is 0. m1 is 10, s1 is 6, m2 is 30, s2 I do not know. So 0 0 cancels, so 6 plus 3 s2 is equal to 0. So s2 is equal to minus 6 by 3, which is basically, yeah, correct? Yes, perfect. So it will be basically minus 2 centimeters. Now this minus means you have to go towards the left side. So 2 centimeters away or 2 centimeters towards. Obviously 2 centimeters towards, because this minus sign says you have to go towards the left side. So 2 centimeters towards the 10 kg block. That is the answer. Yep, option C, very good, Nikhil. Very nice. No, Roshni, it is not B. No, Siva, it is not B. Be little careful. It is not away, it is towards, because if 10 kg goes here, how can 30 kg go there? Center of mass will move. So if you want to keep the center of mass as it is, both have to come towards each other or away from each other. Both towards or away. If both go away, center of mass will also move. Okay? Clear? Right. Moving on to the next one. The particle's mass is given with some speed. Angle is also given. The magnitude of the angular momentum of the projectile from the point of projection when the particle is at the maximum height. This question on maximum height, range, angular momentum, this is very common. You check any paper, any shift, most of the times this particular model was repeated. So probably you might even remember this from your January 1st attempt. So guys, what you need to do in this is simple. First, visualize this entire problem. So this is the base, this is the particle which is being thrown with speed u, this is 30 degree. So as and when it reaches the top, the speed will be u cos 30, which is u root 3 divided by 2. And you have to measure the angular momentum about this particular point from the point of projection. So what you need to do is just extend this line and just drop a perpendicular. This is your r perpendicular. This r perpendicular will be exactly equal to the height of the projectile, maximum height of the projectile. So when I calculate the angular momentum, which has the formula m r perpendicular into v, this m is m only, r perpendicular will be h, velocity will be u root 3 by 2. Now maximum height is nothing but u square sine square theta, theta is 30, divided by 2 into g. So this into u root 3 divided by 2. So m is there, u square into u is u cube, then g is also there. Sine 30 is half, square of it is 1 by 4. This 2 will come as it is. This root 3 by 2 is also there. 4 into 2, 8, 8 into 2 is 16. So it will become mu cube root 3 divided by 16 times of g. Is that there somewhere? Yes, it is. Option number D for Delhi. Option number D for Delhi. Very good. Nikhil, Neha, Harini, Hasini, Kishore, very good. Kamai, awesome. Subbu. Very good, Shiva. Very good, Yashwant. Very good, Rajesh. Yes, option number 4, Sumati. Very good. Matthias, very good. Awesome. Proud of all of you. Looks like you're going to nail these models of questions. Most repeated models if you're getting, you can ensure bare minimum score, at least that confidence is there. Okay, at least I will be able to score this much. After this, yes, I know I will be able to think about it. Once you have that confidence, moving over that confidence is easier than having no confidence at all and then struggling to solve the entire paper. A wire of certain length and radius is clamped rigidly at one end. When the other end of the wire is pulled by force F, it increases by some length L. Okay. Then another wire of the same material of length 2L and radius 2R is pulled by a force of 2F. Then the increase in its length will be how much? That's the question. Okay. So see guys, Young's modulus is stress by strain. Stress was force by area. Strain is nothing but change in length upon the original length. I think the radius is mentioned, so convert area into radius. So force into original length, area will become pi into r square, and this is your extension. So now L small, which is the extension, will become capital F original length pi into y into r square. Now this was the extension for this force, for this length, for this radius. So let's say I call this the initial or for the first situation. Can you similarly guess for the other wire? For the other wire, how will this look like? I will call this L prime is equal to F prime, capital L prime, pi, modulus is same, and r prime square. This is what it will look like. But wait a minute, I think we can find this out. L prime will be F prime, the new force. The new force is clearly given to be 2F. So 2F. New length, the new, same material and length 2L. So this is 2L. Whole thing divided by pi. Young's modulus is same because same material is clearly mentioned over here. And R1 is basically given to be 2R. So this is 2 times of R whole square. The best part, it will become F, L, pi, Y, R square. Here it will become 2 into 2 divided by 2 square. What is this particular quantity over here? This is small l. That's it. This is nothing but small l. And this is nothing but 1. So L into 1. So L prime is L into 1 means L only. So option B for Bombay is correct. Option B for Bombay is correct. That means it did not change. And I can see a lot of students who are going to go to IIT Bombay. Proud of all of you. I hope you remember this channel. And I hope you will also tell your juniors when you will be giving your speech, or when you will be called in a function, or when you meet some relative or friend of yours. Hey, listen, this is that student who passed IIT and he is now studying in IIT Chennai, IIT Madras, or IIT Bombay, or IIT Delhi. You know, this time, go ask him some doubt, go ask him some suggestion, go ask him how he prepared. And then you will be like, yes, you know what, I did this, and I also prepared from this YouTube channel which is called as VEDANTU JEE English. That will be the day you will feel very different on top of the world, isn't it? Next, coming up on your screen, consider two containers A and B containing monoatomic gases at the same pressure, volume and temperature. Gas A is compressed isothermal, B is compressed adiabatic. Ratio of the final pressure of B to A is how much? Thank you, Krishna, for all the Warrior Pandu WP trending. Thank you. So in this particular question, what you need to do is, by the way, adiabatic isothermal questions are very, very common in JEE. You can check out any paper. First is isothermal. Temperature is constant. So P1 V1 is equal to P2 V2. Since it is clearly mentioned, I can also put it as P0 V0. That will be better. So let's say P0 V0 is equal to P1 V1. Since it is clearly mentioned that the volume has been made 1/8, so this will become V0 by 8. V0 cancels. V0 cancels. So what will P1 become? 8 times of P0. 8 times of P0. That is the first thing that you will get. Everybody with me? Very good. Now let's do it for the second process. For the second process, when it is done adiabatically, Q is basically 0. So P0 V0 raised to gamma is the gas type given containing monoatomic gas. Now when monoatomic is mentioned, gamma will be 5 by 3. Gamma will be 5 by 3. So V0 raised to 5 by 3 will be equal to P1, or rather I would say P2, into V0 has been made, or the volume has been made, original volume's 8th times, or 1 by 8th times. So V0 by 8 into basically 5 by 3. PV raised to gamma is constant. So P0 V0 raised to gamma is equal to P2 V2 raised to gamma. V2 is V0 by 8. V0 V0 will cancel. V0 V0 will cancel. So P0 will be equal to P2 divided by 8 raised to 5 by 3. First take the cube root of 8. Which is basically 2. So 2 raised to 5. So therefore P0 will be equal to P2 divided by, what is 2 raised to 5? 2 raised to 4 is 16. 2 raised to 5 is 32. So therefore P2 will be 32 times of P0. 32 times of P0. Question is the ratio of final pressure of gas B to that of gas A. So basically what they have asked is P2 by P1, gas B by gas A. It will be 32 P0 by 8 P0, which is basically 4. Option C, yes, it is correct. C for Captain Shreyas. Yes, Krishna, C for Captain Shreyas. Very good. Keep it up, my dear warriors. Amazing. Moving on to the next question coming up on your screen now. This is also a very common question where they involve resistors, Kirchhoff's laws, sometimes capacitors, Kirchhoff's laws, finding the new charges, finding the currents. Commonly asked questions, series, parallel, or maybe a combination, or where you can't convert it into series parallel, but you have to solve it like this. Question is the potential at A, B and C are 30, 12 and 2. So first of all, they are not in parallel. That is what you should understand clearly, because point A's potential is clearly mentioned as 30 volts. This is 30 volts. Point B's voltage is clearly mentioned as 12 volts. Point C's potential is mentioned as 2 volts. This point I don't know. I can call it as X volts. It is some X volts which I do not know. This current which will go in here will get distributed obviously. So let's say the current which is entering here is I. The current which is going over here is I1, and the one which is going here is basically I2. That is how it will get distributed. I think I can use Ohm's law, or it's at the end already Kirchhoff's law only. For each of these things, I can see there are multiple unknowns, I, I1, I2 and X. 4 unknowns, so I might need 4 equations. One though is very, very clear. For this resistor, if I have to write the equation, current is going from high voltage to low voltage. So directly using Ohm's law, I can also think of Kirchhoff's law, it's one and the same thing. Voltage difference, which is 30 minus X, is IR. I is I only, resistance is basically 10. So basically it will be nothing but 10 times of I for this resistance. Similarly for this, X minus B's voltage is 12. Voltage difference is IR. I is basically I1. R is basically 20. So 20 I1. For this resistance, I can say X minus 2. X voltage minus 2. Voltage difference is current into resistance. Resistance is 30. So 30 times of I2. I hope this is clear. From this, you will get I as 30 minus X divided by 10. From this you will get I1 as X minus 12 divided by 20, and from here I2 you will get it as X minus 2 divided by 30. Why did I do it? Is because I know if I add I1 plus I2, what I will get is I. By Kirchhoff's current law. By Kirchhoff's current law, I1 plus I2 is basically I. So I1 is basically X minus 12 divided by 20. I2 is basically X minus 2 divided by 30 is equal to I, which is 30 minus X divided by 10. You can cancel few things like this 0, which I would not need, and you can multiply the entire thing by 6 so that you can find the value of X. Multiply entire thing by 6. So this will become 3 times of X minus 12 plus 2 times of X minus 2 is equal to 6 times of 30 minus X. That is what you are going to get. Tell me what is the value of X that you are getting. Tell me what is the value of X that you are getting. Come on quickly, my dear students. Always online GMS, I'm always there for you. Nikhil already saying the answer is B, sir. Okay, fine. We'll get to the answer, but can you first tell me what is quickly the value of X that you are getting, my dear warriors? Yep. What is the value of X that you are getting? Nikhil saying 20. Very good. Okay, interesting. Hello, Mandala. Yes, your captain is here. I hope you guys are doing great. Yeah. So what about others? Are you getting it as 20 like Nikhil? Shiny also saying 20. ABCD also saying 20. Okay, so once you get 20 volts, once you get X as 20 volts, what is the next solution that you will do? Question is find the current through the 20 ohm. That means you have to find I1. So you just have to find I1. So I1 is nothing but from here X, which is 20, minus 12. Okay, I'm using this equation, divided by 20, which is 8 by 20, which is nothing but your divided by 4, it will become 2, divided by 4, it will become 5, 2 by 5, which is 0.4 of an ampere. Yes, you should get 2 by 5, which is 0.4 of an ampere. Awesome. Got it? How to do these questions? These questions are procedural, meaning it takes time, but surely you will get the answer. Simple law, Ohm's law, Kirchhoff's current law, such simple things will give the answer. It is just time taking. It will take you 2 to 3 minutes. But like I said, some questions will always take time. Some questions will be taking you less amount of time. And I don't know how many of you have watched this particular video which I uploaded it yesterday. If you have not watched it yet, please do it. Please save your second attempt. The reason why I'm telling you to watch this video is because in this I have given a proper strategy. Even over here I have given you a proper strategy of time. How much time you should spend per question, how much when should you be guessing the answers, when you should not be guessing the answers, right? When you should attempt what are the different strategies per for every student, what might be suitable, what might not be suitable, everything has been mentioned. So do check this out. It will definitely be a game changer for all of you. Okay, so it is there in the videos part. It's a recorded video. It's hardly going to take you 10 minutes. Moving on to the next one on your screen. This one, what does it say? Mass and the diameter of a planet are 3 times the respective values for Earth. The period of oscillation of a pendulum is this on Earth, then the period of oscillation on the planet will be. Combination of 2 chapters, oscillations and gravity. 2 chapters are combined. Yeah, 2 chapters are combined. Nandini, yes, I will be sharing the PDF, my dear student, but after the session is over, okay? But for now, concentrate. You have to see somebody solve. See, there are thousands of PDFs which are available on the internet, but you don't bother about it. Why? You always need that live class. You need that interaction. You need somebody, or else I would be jobless. I would be sitting nicely at home. I wouldn't have to come over here, right? You need that teacher. So that's the reason why I'm coming over here, making sure you see how we solve the problems. All right. First of all, time period of a pendulum is 2 pi root of L by G. Mainly G will change, I believe. G will change. So that's what you need to focus on. Mass and the diameter are made 3 times of the respective values. Gravitational acceleration is G capital M divided by R square. So you can also write it as G capital M. Radius is diameter by 2. So D square by 4. So 4 will go on the top. Now think about it. If the mass has been made how many times? 3 times. And the diameter has been made 3 times. So diameter is square. So 3 square times. So basically it will become, what will it become? Into 3 in the numerator and into 9 in the denominator. Basically it will become how many times, my dear students? Basically it will become how many times? 1 by 3 times. It will become 1 by 3 times. So the new gravity is 1/3. So I would say G prime is old gravity by 3. G prime is G by 3. So what will be the new time period? Think about it. Because from here I can clearly see time is inversely proportional to root of G. So therefore I can say T prime by T will be G prime below, G on the top, but I know G prime is nothing but G by 3. So this will become root 3 divided by 1. This time I already know is 2 seconds. Take 2 on the top. So T prime will be taking 2 on the top, multiplying it by root 3. So 2 root 3 seconds, which is D for Delhi. Very good. Some of you gave the wrong answer and said option C, but no, my dear warriors, C is not correct. Option D is correct. Option D for Delhi. Yes, Amuta. Yes, Sinan. Yes, Yashwant. Yes, glad you guys got it. Cool. Shall we go to the next one? Here it is. A steel wire of a certain mass per unit length is under tension of 70 Newton. The speed of the transverse wave. Speed of a wave. So many times, guys, you will be surprised to see such simple questions. Speed of a sound, speed of a wave on a string, speed of light. Basically, in general, speed question. Equation is given. Speed of the wave is how much? Which direction it is moving? Commonly asked questions. Please do it. You will see it in almost every shift. So, what is the speed of the transverse wave? Is root tension by mu. The value of the tension is 70. Mu is 7 into 10 to the power minus 3. 7 cancels. It will become 10 into 10 to the power 3, which is 10 to the power 4. Root is 10 to the power 2, which is 100 meters per second. Wow, where is it? 100 meters per second is option C for Captain Shreyas. Yes, Siva Prasad. Finally, you guys learned how to say C. C for Captain Shreyas, D for IIT Delhi, B for IIT Bombay. You can also say C for IIT Chennai also. Yep. a special connection with Chennai because I was born very close to Chennai in Salem. So how many of you are from Salem and were born there? You are like my, younger brothers and sisters from the same birthplace. The mass of the moon is 1 by 44 times the mass of a planet, and the diameter is 1/16th time of the diameter of it. Okay. Escape speed question with ratio is always the most common type of question that you will see in JEE Mains. So, first of all, the formula for escape velocity is root of 2 times gm divided by r. That's what the formula is. Oh, you are near to Salem, Kamini. Wow, Akhil is from Salem. Magesh is from Tamil Nadu. Awesome. Wow, so cool. Nice to see. Daydreamer is from Chennai. Oh, very nice. Okay, so mass is 1 by 144 times of the planet, and diameter is 1 by 16. See, if diameter is 1 by 16, even the radius will be 1 by 16. But if you still are not convinced, no problem. Write radius as diameter by 2. 2 2s are 4. So 2 times of gm by this. Now, what I will do is V2 by V1 will be root of M2 by M1 and D1 by D2. It is inversely proportional to root of D. So I'll get velocity 2 divided by velocity 1 is basically V is root of mass 2 is 1 by 44 times. So M2 is less. So this will be 1 by 144. That is M2 by M1. Mass 1 is more. Mass 2 is 1/44th of M1. Diameter is 1/16th of the diameter of the planet. So D2 is 1/16. So this is 16 by 1. So root 16 is 4, root 144 is 12. So this will just become 1 by 3. So V2 will become V by 3. Is D for Delhi? Yes, IIT Delhi. Very good. Very good. Victories from Jammu. Wow, the other side of the country. Beautiful place. Beautiful place. Very good. Very good. Awesome. Thank you, Spurti. Means a lot. D for daddy. Who is your daddy now? I am not the daddy. NTA is the daddy. NTA is the daddy. Big daddy. Okay? Big daddy. Yes. So remember that. Yeah. 2 identical tennis balls, each having mass m, charge q, suspended from a fixed point, thread L. What is the equilibrium separation each thread makes? A small angle theta with the vertical. This question, or basically there is a charge sheet and it is connected to a pendulum, the charge deflects and makes an angle, or a string is connected to another string and what angle does it make, or the angles are given, mass is suspended, what is the tension, or let's say a thread is rotated like a conical pendulum, what angle does it make? Common questions, guys. These 3-4 models must do. Okay. Well, tension is at an angle, or an accelerated cart, because of the pseudo force it goes behind, what is the angle, or the angle is given, what is the acceleration? All these patterns. So what do you do in this particular question is, so I'll just probably take another slide because I think I will need a little bit space. So this is one charge, this is another charge Q and Q, this is length L, this is length L, and something is given. Where is it? X. What is X? X is the suspended. Okay. What is the equilibrium separation when each thread makes an angle theta with the vertical? Okay. So basically, I think I created one extra slide by mistake. Okay. Yeah. So basically, this separation is what is given to be as X, and question is what is that X in this particular scenario? Okay. What is that X in that particular scenario? Angle made by the thread is basically theta with the vertical. So basically this is theta, even this is theta. Naturally this base will be x by 2, this will also be x by 2, this will also be x by 2. So what you should do is realize that on this particular charge there will be multiple forces. One will be the force of repulsion. If you take this, there will be the force of electric force of repulsion, which is K Q1 Q2 divided by distance. Distance is x, so x square. Apart from that, there would be tension over here and there would be mg over here. Obviously, it is clearly mentioned the angle with the vertical is theta. So if this is theta, obviously even this is theta, because these two dotted lines are parallel lines. This is an intercept. So this angle will be equal to this angle. This angle will be equal to this angle. So that is basically theta. So now you split it into x and y components. So let's say you go with x component first and then go with the y component. So you will clearly see the tensions. X component will be t sine theta. So t sine theta, tensions sine theta will be this. It will be k q square by x square. The vertical component is t cos. So t cos theta will be balanced by mg. Obviously, what is the next step that you are going to do? Divide these two equations. So divide x by y and see what you get. Divide the x component by the y component. T cancels. You will get sine theta by cos theta is equal to k q square by x square, and here you will get mg. Sine by cos is basically tan theta is nothing but k q square by x square into mg. But theta is given to be small angle, and whenever theta is such a small angle, tan theta will be sine theta. So instead of tan theta, I can roughly write it as sine theta, and sine theta is opposite side, which is x by 2 by your hypotenuse, which is basically L. So it is x by basically 2L. So substitute x by 2L over here. Substitute x by 2L over here and see what is the magic that you get. You will get this as k q square by x cube mg. X square mg. Take x square over here, it will become x cube. Take 2L over there, it will become 2kl q square, and this divided by mg. So x will be cube root of this. X will be cube root of this. Got it, everyone? So I think there is a cube root wala answer. Yes, q square L and all these things are there. So you can also substitute k as 1 by 4 pi epsilon naught if you need to do that. Okay, so you can always substitute the value of k as 1 by 4 pi epsilon naught. So you will have ql square, that 4 and 2 will cancel. You will get 2 pi epsilon naught and mg below. Yes, that is the correct answer. So always this splitting up of vectors, resolving the forces, drawing the free body diagram, using some trigonometry maybe at times, and then doing basic algebra is what will be needed in these type of questions. So be used to it is what I would say. Okay, so just be used to it. Cool? Yep. How do you resolve the component Yashwal and Tech? See this. Can you see this line is parallel to this line? These two lines, this vertical line and this line. Okay, so this is an intercept. So if this is theta, naturally this is theta. Parallel lines concept this is. So this will be also theta. So this mass will get one tension over here, will experience a repulsive force and gravity here. Now this tension will have two components. This tension will obviously have two components. One component here and the other component over here. The one which is close C, close word starts with C is always cos. So that is why this is t cos theta. One which is not close, you are committing a sin. So not close to theta. So it will be t sine of theta. Is that clear? I hope now it is absolutely understood. T sine theta balance this. T cos theta balance this. And tt, I don't need tt. So sine by cos is tan, and tan is sine for small angles. Cool? Okay, why instead of tan we wrote as sine? See, I can write over here tan theta, but tan theta will be this by adjacent side. Do you see this small triangle? Do you see that triangle? Then you will understand it. Why I have written tan theta as sine theta? Because the base is x by 2, this hypotenuse is L. I do not know this height, and this was your theta. This was basically your theta. So that's the reason why I've written sine theta, so that I write it as opposite by hypotenuse. Okay, because I did not know the height. But yes, you can also write height is almost equal to L. That way also you will get it. Understood? Clear? How do you assume tan theta is sin theta? Because of this small angle approximation, guys. I think you forgot it from maths. Small angle approximation. So when theta is in radian, tan theta approximately equals sin theta approximately equals theta, and cos theta approximately equals 1. This is all theta in radian. Theta in radian. Remember this? This is your first chapter probably of physics, or maybe somewhere in trigonometry you learn this. Okay? Is that understood? Clearo, Dev and others? Awesome. Yeah. Sir, this sign and close for splitting the components apply for all the problems? Yes, Akhil. Every problem you can use this technique. Every single problem. So every time you see a vector and let's say this is theta, this is close to theta, so this will be v cos theta. This is far to theta, so this will be v sin theta. Any problem you take, let's say it is some third class diagram like this and you are splitting it like this. This was your v. Let's say this is theta. This component is close to theta, so this will be v cos theta. This is far, so this will be v sin theta. Every time you can use this. Okay, this is my trick which I am telling you. Next one. Two capacitors have same capacitance. One of them is charged to potential V, other to 2V. The negative ends are connected together. When the positive ends are also joined together, the decrease in the energy of the combined system is asked. Let's see if you guys can figure this out. Let's see if you guys can figure this out. Okay, come on guys. So first of all, both the capacitors, same capacitance but different voltages. So one capacitor of capacitance C, let's say the voltage is V, and this capacitor of capacitance C, but the voltage is basically 2V. The charge on this Q1 will be CV. Charge on this Q2 will be basically 2 times CV. C into 2V, which is 2CV. Correct? Now, they will both have positive, negative, positive, negative. You join positives together and negatives together. Join the positives together and the negatives together. This is also C, this is also C. This has some charge. This has some more charge, 2CV charge. The charges will get redistributed. The charges will get redistributed, but what you should know is the total charge will be always conserved. Total charge is going to be conserved, and the total charge which is there will be positive connected to positive, so they will add, it will become CV plus 2CV, which will make it 3CV. That is your total charge. That is basically your total charge. These two capacitors are technically in parallel. These two capacitors are technically in parallel combination. So you can combine them into one single capacitance. One single capacitance of C and C parallel. So it will become 2C capacitance, and the charge on it is basically 3CV. 3CV. Is that clear? 3CV is the charge. So now comes the last part. What is the final energy? It will be half Q square by C, right? Q square by 2C, half CV square. All these are different ways of writing energy formula. Half charge square, total charge square, divided by your capacitance. So charge is nothing but 3CV. So squaring it, it will become 9C square V square. Capacitance is basically 2C. Correct? So it will become 9 by 4 CV square. That is your final energy. What is your initial energy of the system? What is your initial energy of the system? When you calculate your initial energy, there will be two capacitors. So first is capacitance C to voltage V, so half CV square. Next is capacitance C to 2V voltage, so half C 2V square. Got it? Why 2V? There are two capacitors, one for voltage V, one for voltage 2V. What will this become? CV square is common, 2 square is 4, 4 plus 1 is 5. So it will become 5 CV square by 2. 5 CV square by 2, but that is not the question. The question is, what is the decrease in the energy of the system? Decrease in the energy means delta U is asked. So delta U, guys, delta U will be nothing but 5 CV square by 2, 5 CV square by 2 minus 9 CV square by 4. So it will become CV square by 4. Taking LCM, it will become 10 minus 9. So 10 minus 9 is 1. So CV square by 4, which is option A. Option A, just check it out. Yes, it is option number A. Wow. I hope this is clear. I hope this is clear. Yes, option C is not right, Sumati, but it's not in series, it is in parallel because their voltage differences are same. That is what many students think. So this capacitor is connected after this capacitor. No, no, no. Don't think of it like that. That is not correct. Their voltages are going to be the same. Potential difference is same. So charges could be different also. Because the capacitors are equal, so charges will be equal later on. But imagine this was C1, this was C2. Q1 and Q2 will not be equal after final distribution. So that is the reason why you should not consider them in series, but they will be in parallel because their voltages are same. Is that clear? Yeah. Okay, great, great, great. I hope this is understood. Shall we proceed to the next one? This is also a very, very common model of questions. Yeah. Yes, Cherry Deva, hostel facilities are there in most of the places. So the best thing to do is actually visit the center. Like in the Bangalore center that we have hostel facilities. In Chennai also, we have tie-ups. In Telangana also, we have tie-ups. So visit the center so that you can understand which area it is, how is the hostel, everything you can have a look at it. Many residential campuses are there. So you can stay over there only, you can attend the classes, and everything is at very, very nominal fees if you compare it to any other institute. That is one thing that I can tell you. Okay. So yes, hostel facilities are there. What about this? The equivalent resistance of the circuit shown below between the points A and B. Very nice question. A and B. Look at this. This is A point. This is B point. I feel there is some symmetry. And I have taught you guys one trick, and the trick goes like this. Join the line between which you want to find the resistances or capacitance. Draw a perpendicular bisector. What will you do? Draw a perpendicular bisector. That means a line which divides it into two equal parts and is perpendicular to it. Got it? Yes. Whatever lies on the perpendicular bisector, those devices will be on the same voltage, same potential. So anything between them should be neglected. So basically what I mean to say is this point and this point are at the same potential. So this device has to be completely ignored. Ignore this particular device. Ignore this particular device. This is at V1. So this will be also at V1. Forget it. So let me just draw a duplicate of the same. Yep. So what will happen is, oops, my bad. Yeah. So what will happen is, you can just forget this 4 ohm resistance. So let me just remove it right now in front of you. This is not even needed. This is a completely useless part. Got it? Now, doesn't this look a little bit easier to solve? Doesn't it look a little bit easier to solve, my dear students? How does it become easier? Can you see this resistor and this resistor is basically in series? They are basically in series. What is the combination of them? 8 ohm. Correct? Even this one and this one is in series. That is also 8 ohm and this is 16 ohm. So now what do we have? We have 8 ohm parallel to another 8 ohm parallel to this is parallel to each other between the same 2 points, parallel to 16 ohm. So what will be the equivalent combination? 1 by Rp will be 1 by 8 plus 1 by 8 plus 1 by 16. LCM is 16. So this will become 2 plus 2 plus 1 over here. So that will become 5 by 16. So Rp will become 16 by 5 ohms. 16 by 5, 5 3s are 15. So 3.2 ohms should be the answer. 16 by 5 or 3.2 ohms. Got it, my dear students? C for Captain Shreyas. Yes, Siva. Interesting question. So did you understand the trick? Whenever you see a symmetrical line and it is a perpendicular bisector, anything which lies on the perpendicular bisector, those perpendicular things, you can get rid of it. Whether it is resistor, whether it is some capacitor, inductor, doesn't matter. You can just say tata bye bye to it. Moving on to the next one. As shown in the figure, the current of 2 amperes is flowing in an equilateral triangle, the magnetic field at the center. Triangle, hexagon, square, straight lines, 2 straight lines, perpendicular lines. Standard models of question to find the magnetic field. So to do this, what you need to do is, remember, you find the magnetic field due to any one of them. So let's say you consider this particular wire, which is having a current of 2 amperes. It is at certain distance d. So find the magnetic field due to that and multiply it 3 times. So basically you will say that the total magnetic field at point O is basically 3 times the magnetic field due to any one wire. And magnetic field due to any one such wire, because it's a finite wire, the formula goes like this: mu naught into current divided by 4 pi d. Here you will have sine of alpha plus sine of beta. If you're wondering what is alpha and beta, simple guys, I'll tell you. Join the endpoints like this, join the endpoints. This is basically alpha, this is basically beta. Since this is a beautiful right angle triangle, what will happen guys? See guys, you can clearly see this total angle is nothing but 60 degree. So this is angle bisector. So that means this part will be 30 degree. If this is 30, this is 90, this would be 60, even this would be 60. So this is alpha, this is alpha. The angle subtended by the perpendicular with the ends of the wire. So this is 60 degree, even this is 60 degree. Current, we already know. Current is basically 2 amperes. This current is basically 2 amperes. Mu naught by 4 pi also, I already know it is nothing but 10 to the power minus 7. The only thing I do not know is distance, and that also I can find out. This d in this small triangle, using a little bit of trigonometry, you will get it. Use tan 30. Tan 30 is opposite by adjacent. Adjacent is half of the base. What is the base? Base is 4 root 3 is half. Side length is 4 root 3. So this will be basically 2 root 3. Did you understand why? The side length is 4 root 3. This is 4 root 3. This will be 2 root 3, 2 root 3. Got it, my dear students? This is basically 2 root 3. This base. I hope this is absolutely very clear. Tan 30 is 1 by root 3. Tan 30 is 1 by root 3. So this is d by 2 root 3. So yes, check this out. You will get d as basically 2 centimeters. 2 centimeters. So this is 2 into 10 to the power minus 3 meters. So everything you know, substitute, and next few steps, next few lines, you will get the answer. Next few lines you will get the answer. I think sine 60 is root 3. So root 3 will be there in the answer. Yep, you should get it as 3 root 3. Just check it out. If you are getting it as 3 root 3 into 10 to the power minus 5 Tesla. Minus 5 Tesla. Yep, C for Captain Shreyas. Yep, Manvita. Very good, victory. Understood. Vivek Reddy. Yes, C. Vimisha Shetty. Yes, C. Yes, online classes, GMS. Perfect. Captain Shreyas sir. Yes, Shruti. Okay. Glad, Sherry. Glad. So much. Means a lot. Yep. Okay. Cool. Let's move on. And guys, if you have still some more questions, like some advice you need to take, please put it up in the comment section after the video ends. I will definitely help you out. Okay. Okay. An object is placed at a distance of 12 centimeters in front of a plane mirror. The virtual and the erect image is formed by the mirror. Okay. Now the mirror is moved 4 centimeters towards the stationary object, the distance by which the position of the image will be shifted. So motion of the mirrors, image formation by mirrors, standard model guys. So let's draw the diagram. An object is placed at a distance of 12 centimeters from a plane mirror. Oh, this will make the job even more easier. And obviously, where will the image be formed? 12 centimeters behind. This is where your image will be formed. Now what is done is the mirror is moved by 4 centimeters. Oh, this is simple. The image will move by 2 into 4 centimeters means 8 centimeters. So directly 8 centimeters, not away, towards the mirror. So option D is correct. Remember this, if mirror moves x, image moves 2x. If object moves x, image also moves x. This is a standard thing which you should know. I mean, you would have done this also. Object goes with speed u, the image also goes with speed u. But remember, object is at rest, mirror is going with speed u, image will go with a speed of 2u. Image will go with a speed of 2u. So that is the concept used. Mirror is moving, so image will move double the amount. Image will move double the amount. I hope this is absolutely very clear. Correct. Moving on to the next question on your screen now. 𝑟𝑥𝐿, are representing resistance, inductive reactance and capacitive reactance. Which of the following is dimensionless? I want everybody to spam the answer. Dimension questions. They will give you some expression. G pi epsilon naught divided by mu naught. What is the dimension of it? Or, you know, something else only. L by C into something. What is the dimension of it? Or which of the following is dimensionless? Some other constants or variables they can use, physical quantities they can use. So you just need to think about some formula or some concept which you know with regards to those variables. Don't have to actually substitute their dimensions. Okay, so resistance, reactance, all of them are measured in ohms. Units and dimensions of resistance, XL and XC are ohms and same dimensions. So that's all. If you want a completely dimensionless entity, their units or dimensions should get cancelled. I feel here it won't, because ohm, ohm, ohm. So 1 ohm will remain. Ohm into ohm into ohm, ohm cube. This is ohm into ohm by ohm, 1 ohm will remain. This I think will get cancelled out. Ohm, 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 root ohm. So this will just become ohm by ohm, which is dimensionless. Option C. Yep, very easy. Awesome. C for Captain Shreyas. Very good, guys. Very good. Yeah. C for Capto. C for Cat. C for always Capto or Chennai. IIT Chennai. Okay, keep this in mind. All right. Moving on to the next one. The plane electromagnetic wave of frequency 35 megahertz travels in X direction. Magnetic field is asked. Electric field is given. Okay. So first of all, we know that the speed of light is electric field's magnitude by magnetic field's magnitude. So magnetic field will be electric field, which is 9.6 divided by the speed of light, which is 3 into 10 to the power 8. Is that right, everybody? So this will become 3.2 into 10 to the power minus 8 Tesla. 3.2 into 10 to the power minus 8 is there in B, C and D. Oh, which option do I choose now? So now go with this logic. Electric field cross magnetic field is parallel to the velocity of the light. Light is going in X direction, that means this is I cap. Electric field is in J cap. Now J cap cross what vector will give you I cap? J cap into which vector will give you basically I cap, guys? Think about it. Which vector will give you I cap? J cross K, right? J cross K cap will give you I cap. So I can see K cap over here, and this is also 3.2. This is I cap, wrong. Even though this was correct, this is wrong. Here this is K cap, but this magnitude is wrong. Here magnitude, direction, both are wrong. So D option is the only suitable option over here. Is that right? Correct? Understood? So remember this logic, how to find the direction of magnetic or electric field using this cross product. Electric field cross magnetic field is the direction of the velocity of the light. Okay? Right. Moving on to the next one. Match the following electromagnetic waves and wavelength. This is completely theory based. Completely theory based. Either you know it or you don't know it. So I'll directly probably show you the answer. That will be better. Right? If you can guess it before I show it, very good. Very good. Check this out. So the table is there in NCERT. Please remember the table. Applications of all the electromagnetic waves, how they are produced, a general idea. No need to know the complete experiment. If there is some phenomena or some disadvantage or advantage of those rays, like ultraviolet is harmful and gamma rays is useful for treating tumors, all those things, applications are mentioned. What are the approximate ranges? Which has more energy, which has less frequency, all those things. You should know it from the table. So please go through it. So A is going with 4, A is going with 4, B is going with 1, C is going with basically 2, and D is basically going with 3. So that is the logic over here. Yeah, that is the final answer over here. Yeah. Naruesh, where can you get the formula sheet? Just search for the formula session by Shreyas sir on YouTube. In that session, in the description box, there is a PDF link which I have attached. My handwritten complete formula sheet is there. Okay, handwritten formula sheet is there. Just search for Shreyas sir formula. 2 months or 3 months ago only I had conducted the class. What is this? The threshold frequency of a metal is F0. When the light of frequency 2F0 is incident on the metal plate, the maximum velocity of the photoelectrons is V1. When the frequency of the incident light is changed to 5F0, the maximum velocity of the photoelectrons emitted is V2. What is the ratio of V1 by V2? Interesting question. Come on guys. What do we do in this case? Again, standard model question on photoelectric effect. Do it step by step. Light's frequency is 2F0. The maximum speed is V1. How are they related to each other? See, HF is work function plus your kinetic energy, right? So I can also write HF is equal to work function, which I can write it as HF0. Kinetic energy is half mv square. Now let me apply this formula 2 times. First time it will look like this. H into initial frequency is 2F0 is equal to HF0 plus half m V1 square. Second time when I apply it, it will look like this. The frequency is 5F0. So H into 5F0 is HF0 plus half m. The new speed is V2. Okay, the new speed is basically V2. Great. Now from the first equation, I think I can find half m V1 square. Check this out. Half m V1 square. Take this HF0 over here. 2 HF0 minus HF0 is just HF0. Is that right? I've just taken this guy over here. 2 minus 1 is 1. 5 minus 1 is 4. So from this, half m V2 square is 4HF0. Obviously, what is the next step? Divide both of them. So when you divide both of them, half m cancels. So V1 by V2 whole square is 1 by 4. I think they have asked you exactly that ratio. So what would be V1 is to V2? V1 is to V2. It will be 1 is to 2 guys. 1 is to 2. Just check it out. Option A will be correct. Yes. 1 is to 2. Take the root of it. You will get option A. Very good. A for apple. Very good. Manvita, Sisant, Vinila, Abhinya. Very good. Siva Prasad. Excellent. A for amazing capto, says Krishna. Very good. Very good. Next question we have on Young's double slit experiment, and that too on intensity. Ratio of the amplitude of the light coming from the slits is 2:1. Maximum to minimum intensity of the pattern is how much? See, the maximum intensity upon minimum intensity ratio is asked. The formula for maximum intensity is root I1 plus root I2 square, standard formula. Formula for minimum intensity is root I1 minus root I2 whole square. Next step, the ratio of amplitudes of light is given to be 2:1. We know intensity is proportional to square of amplitude. So technically I1 by I2, I1 by I2 will be 2 by 1 whole square, which means it will be 4:1. 4 is to basically 1. Okay, I hope this is clear. So instead of I1 and I2, what we can do is over here. Okay, just put square over here. Let's say if I consider I2 as some x units, I2 as some x units, then I1 will be 4 times of that. So this will be basically 4x. I hope this is clear. Is that understood? I2 is 1, I1 is 4 times. So if I1 or rather I2, if I assume it as x, I1 will become 4 times of x. That will help me solve the problem very easily. How? X will cancel out. So I will be just left with root 4 plus root 1 upon root 4 minus root 1 and this square and this square. Root 4 is 2, root 1 is 1, root 4 is 2, root 1 is 1 and this square. So 2 plus 1 is 3, 2 minus 1 is 1, square it, so it will become 9:1. So 9:1 is the answer. It's a very procedural problem, but if you know the formulas correctly, when to use where, what is what, you will get it rightly, or else it leads to a lot of confusion. It's a very confusing problem when you try to actually do it on your own, and especially, you do not understand how is intensity related to amplitude, which ratio have they asked, whether this is plus, this is minus. So it can be confusing at times in the examination hall. Okay, cool. Let's move on to the next question. This question, which was asked in 2022, was also NTA's favorite question in the January attempt. That means they love certain models and they repeat also certain models directly. Okay, they are not ashamed of it. Okay, even in the January attempt, they use this problem multiple times. They were not even embarrassed about it. So what does this say? The angle of minimum deviation, refracting angle of prism, refractive index is this much. Okay. Is there a formula which relates minimum deviation, angle of prism, refractive index? I think there is. And that is mu is equal to sine of A plus delta minimum by 2 upon sine of A by 2. Refractive index is basically cot of A by 2. Cot of A by 2. This will be sine of A plus delta minimum by 2 upon sine of A by 2. Perfect. Now what is cot? Cot is nothing but cos by sine. So this will become cos of A by 2 by sine of A by 2. What will happen because of this? Can you see sine A by 2 and sine A by 2 in the denominator will get cancelled? Sine A by 2 and sine A by 2 denominator will basically get cancelled. Perfect. Now here I have cos A by 2 and here I have sine. I can't compare them. So why not write cos as sine of 90 minus theta. Sine of 90 minus theta. So it will become 90 minus A by 2. That will be in terms of sine. And on the right hand side, I will stick to this sine of A plus delta minimum by 2. Sine, I can compare the angles. So this will become pi by 2 minus A by 2 is equal to A plus delta minimum by 2. 2 cancels. Pi minus A is equal to A plus delta minimum. What have they asked? Minimum deviation. So delta minimum will be pi minus 2A in radians. So it will be 180 minus 2A in degrees. In degrees, it will be 180 minus 2A. Is that clear? How we got it? Critical steps were this: writing cot as cos by sine and cancelling it. Second was writing cos in terms of sine, because LHS has cos, RHS has sine. To compare, either convert sine to cos or cos to sine. So here I have just converted cos into sine, so I can compare the internal angles. Yeah, I hope this is very, very clear, my dear warriors. Shall we proceed to the next one? Okay, here we go. Yes. What is it? Two charged particles having same kinetic energy are allowed to pass through a uniform magnetic field which is in the perpendicular direction of the motion. The ratio of the radii of the circular paths is 6:5. The respective mass ratio is 9:4. The ratio of their charges. Okay. Same kinetic energy is allowed to pass perpendicular to the magnetic field. So circular motion happens. So radius formula happens to be mv by qb, if you remember correctly. And what we can do, mv is momentum. So momentum by qb is the formula. But momentum is the root of 2 times mass times kinetic energy divided by qb. So that is what is R. Question is ratio of the charges. So Q will be equal to, see this carefully, root 2 mk divided by R comes here and B comes over here. Now out of these things, who are variables? Charge ratio is asked, mass is different, radius is different. Mass is different, radius is different, kinetic energy is same and magnetic field is same. So therefore Q1 by Q2 will be, mass is there under the root sign, so m1 by m2. Radius is inversely proportional, so it will be just r2 by r1. Mass ratio is 9:4 perfect squares. r1 by r2 will be 6 by 5. This is r1 by r2 6 by 5, so r2 by r1 will be 5 by 6. Root 9 3, root 4 2 into 5 by 6. 3 goes with 6 2 times, so it will become 5 by 4. Option B. Yes, B for IIT Bombay. Yeah. So what did we do first? Always try to get a relationship between the asked variable, which is the charge, and the given variable, which is mass radius. Some numbers will be constants. Ignore them when you take the ratio. So charge 1 by charge 2 will be root m1 by root m2 and inversely proportional to r. So r2 by r1. Cool. So this is the standard procedure for radius problems, and this is a homework question. Make sure you solve it and post the answers in the comments. The PDF will contain the answer as well. Now it's time for mathematics. Yeah, I look different because my t-shirt is different. I usually wear my different shirt and my hair has gone haywire and I'll be going for a haircut tomorrow. Okay, so that is my plan. Just 1 second. Yes. Okay. Plus 8 without touching the pen by guessing, but this might not always work. Yeah, Abhinya, thank you. Welcome as well. Okay. Just 1 second, guys. Let me get Namrata ma'am. Just 1 second, guys. I am also getting a shock. Hello, Pradeep. Can you see Namrata ma'am? Okay, so Namrata ma'am will be joining, guys, and see you again tomorrow for the predictor paper. Okay, bye bye. Take care.
All right, Ninja Warriors. So mathematics session we are going to start. So please let me know in the chat box whether I'm perfectly audible and visible. Keep joining, keep liking the session. So we'll start right away this session without wasting any time. So you know the topic, you know the concept, the agenda of the session. From past 5 years, we are going to solve most repeated questions or questions based on most repeated concepts, right? Across the mathematics syllabus, class 11th plus 12th both, right? Yes. Good afternoon. I can see. All right. I can see Muthu. I can see Alone. I can see Stylish. Good afternoon. Welcome. All right. So we are going to start right away. Okay. So the very first question of the session is from applications of derivative. Let us quickly do that. Let us quickly get into the question. So a function fx is given to us and we are here to figure out that this function is having what type of local maxima or minima, right? How many points of local maxima or minima? Okay. All right, I guess that agenda is clear. The question is clear. So this is your fx and we are looking for how many local minima and how many local maximas are here. So for that, I need to differentiate this function fx. So first derivative test we are going to apply. So quickly f dash x will be equals to 2 plus. Now we have 3x raised to power 2 by 3. So 3 will be as it is. 2 by 3 will come in front. And x raised to power minus 1 by 3 will be there. Okay. All right. X raised to power minus 1 by 3. Now, f dash x will be equals to 3 gone. 2 if I take common, I will get 1 plus x raised to power minus 1 by 3. Now, please realize this is a little bit googly question, I would say. So, for divide or let's just make the minus 1 by 3 positive 1 by 3. How do we do that? By taking it in denominator. So now your f dash x will be equals to 2 is common, 1 plus 1 upon x raised to power 1 by 3. If I take LCM, I'm gonna have x raised to power 1 by 3, 1 plus x raised to power 1 by 3. This step is very critical, very important, because sometimes what we do is we just think that okay, only critical point is only minus 1, but we are having 2 critical points. Yes, that's why this question is asking you point of local maxima and local minima. How many points are there? So some people might think that so some people might think that only one critical point is there, but in fact actually there are 2 critical points. That's why I kept this question in this session. So it is going to be 1 plus x raised to power 1 by 3 upon x raised to power 1 by 3. This is your f dash x. So now x raised to power 1 by 3 is minus 1. That means x equals to minus 1 is one critical point. Another critical point is x equals to 0. Clearly plot these 2 critical points on the number line, right? And we are going to have positive, negative and positive. What is this? This is sign of f dash x. This is sign of f dash x by using method of intervals, right? So clearly after 0, I have an increasing function, then I have a decreasing function, then I have an increasing function. Clearly, I am having one maxima and one minima over here. So the final answer is exactly 1 point and exactly 1 point of local minima and maxima. Option C or option 3 you can say is absolutely right. Okay. All right. So good question, I would say, and the whole point of this question was this step, because some people will say, okay, only one critical point is there, x equals to minus 1, and they will either take option 1 or they will, they will either take option 1 or option 2, right? Most of the students. Okay. All right. Yes. Let us move on to the next problem, which is from the area under curve, right? So area under curve where one line and one conic is involved is very popular, is very repeated. If I talk about past 5 years, line and parabola, line and ellipse, line and hyperbola, it could be anything, right? So how to handle this, how to understand this? So first of all, this is x plus y is equals to 6. This is xy plus 4y is equals to 16. We need to plot these two curves nicely. We need to figure out the point of intersection as well. and we need to figure out the area. Okay, let's do it. So x plus 4 and we have y is equals to 16. So this is a rectangular hyperbola, right? It is similar to xy is equals to constant. Now xy is equals to constant, the graph is looking like this. The graph of xy is equals to 6 look like this. But this is not xy equals to this. This is x plus 4. So the similar thing is going to happen. But what will happen in this is, yes, so x plus 4, y is equals to 16. xy is equals to c hyperbola looks like this. This is rectangular hyperbola. And this is x plus 4. So that simply means that I have to draw an asymptote at x equals to minus 4. And similar thing I'm gonna draw over here. So this is it. Okay. And this is it. This is how my hyperbola look like. Okay. Let me just mark the point where it intersect y-axis. Y-axis means x equals to 0. So that means y is equals to 4 is that point where my hyperbola will intersect with the y-axis. Okay, all right, clear? So this is, I think this hyperbola is clear to us. What about this? X plus y is equals to 6. This is the line where both x and y intercept is 6. So this is 4. So approximately this would be 6. And this is how your straight line would be. So which area you are looking for? You are looking for this area, my dear students. Yes, you are looking for this area. This is your, so this you need to figure out x coordinate, and this you need to figure out x coordinate. Here upper curve is your line, which is nothing but 6 minus x dx. This is your upper curve. This is your lower curve. What is your lower curve? Tell me. So lower curve is 16 upon x plus 4 dx. Now we need to understand that from where to where we need to integrate. For that we need to solve this and this. Let's do that. Okay. So let's solve x plus 4 y equals to 16. So yes, x plus 4 times y equals to 16, and from here y is equals to 6 minus x. So can I put over here? Definitely. 6 minus x equals to 16. Right? Yes. Now just multiply it. Figure out the quadratic equation. X square with a negative sign. 6 4s are 24. We are getting plus 24. Then we are having minus 4x and plus 6x. So plus 2x is equals to 16. Correct? Yes. Shift everything towards the right hand side. X square and plus 2x, so minus 2x, and we are having minus 8 equals to 0. So x minus 4 and x plus 2 equals to 0. Okay, so this is minus 4x and plus 6x. So udhar jaake, हाँ, x equals to, right, 4 2s are 8, x equals to 4 and minus 2. So minus 2 would be this and x equals to 4 would be this, right? Minus 2 to 4. Clear? So minus 2 to 4 we need to integrate this. That's it. Let's do that. Okay. Minus 2 to 4 we need to integrate this. I'm not able to see the chat. Dismiss. Huh. All right. It got stuck. It got stuck. Okay, right? So minus 2 to 4 we need to integrate it. Let's integrate. So this is 6x minus x square by 2, right? 6x minus x square by 2. So 6x minus x square by 2, and we are having 16 by minus 16 log of mod of x plus 4. This is your integration, and upper limit minus 2 to 4 we are going to get minus 2 and 4. Okay. All right, the moment you force 24 and you are going to have 4 ka square, 16 by 2 minus 8 minus 16 log of 8, right? This is upper limit. Minus, what about lower limit? You have to put minus 2. So minus 12, and then we have minus 2 minus 16 log of 2, right? Okay. 24 minus 8 is what? 16. 24 minus 8 is 16. 16 plus 12 is what? 16 plus, sorry, 14. 16 plus 14 is 30. That means I'm gonna get 30 as the constant. And what is this? Tell me what is this? So this is minus, so this is 8, 2 cube. So minus 48 log 2, and we are having minus plus 16 log 2. So 48 minus 16 is what? Minus 32 log 2. That means option C is absolutely right. You do the calculation. Yes, option 3 is absolutely right, Etas. Yes, option 3 is absolutely right. Okay. All right. Clear? Cool? Okay. I guess we are done. Option 3 is absolutely right. Okay, so this was from 1st February. You see it. JEE Main 2024. So in the beginning, you will see more problems from 2024, then 2023, then we have from 2022 and 2021. Okay. All right. Now we have another question. And this question is from binomial theorem. Are we ready for this? This is my favorite topic. And this should be students' favorite as well, because this is independent topic. First of all, binomial theorem is independent topic, and 𝑬𝒙 chapter as well, high weighted chapter as well. Okay. M and N be the coefficient of 7th and 13th term respectively of this particular expansion, and we are looking for n upon m raised to power 1 by 3. Please remember this. We are looking for n upon m. That means we are looking for n by m. That means we are looking for 13th by 13th term by 7th term. Okay. Please, because people called me, students called me regarding this question. Ma'am, we done some silly mistake. I asked what kind of silly mistakes are you doing? So they said, ma'am, m and n was given, and what they did is, instead of calculating n by m, they calculated m by n, and the irony is that the answers are also according to that. That if you do it incorrect, you get incorrect answer, match completely. Okay. So this is n by m, right? That means we will look for 13th upon coefficient of 13th upon coefficient of 7th term raised to power 1 by 3. This is what we are looking for. What about 13th? So 13th term, TR plus 1, you note what is TR plus 1? That is NCR, A raised to power n minus r, B raised to power r. Okay, so for 13th term, r should be equals to 12. So this would be 18C12, correct? And we are going to have 1 by 3, right? I'm not going to write x because we are interested in coefficient. 1 by 3 raised to power n minus r. So this is 6. And you know what? 1 upon 2. 1 by 2 raised to power r. So that is your 12. Whole upon, now coefficient of 7th. So for 7th term, you have to put r equals to 6. 18C6, 1 by 3 raised to power 18 minus 6, 12. And we are going to have over here 1 by 2 raised to power 6. Can you see 18C6, 18C12 gone? And obviously we are having whole power as 1 by 3. Please do not forget this. Okay. Now can you see this is 1 by 3 raised to power 12 minus 6, that is 6. And 1 by 2 raised to power 12 minus 6, that is 6 raised to power 1 by 3. Okay. And you can say that this is 1 by 2 upon 1 by 3 raised to power 6 by 3, that is 2. And this is nothing but 3 upon 2 raised to power 2, that is 9 by 4 is absolutely right in this. Okay, yes. Oh, I'm super duper happy because so many of you have answered this question before me. Okay. Yes. Okay. And yes, that's what I was telling you, that some of the students from first attempt, they called me up and told me that, ma'am, this was a silly mistake. 4 by 9 is also there. Can you see 9 by 4 is the answer? And if by mistake you have calculated m by n, because the given condition is like that, m upon n. So 4 by 9 will match. Okay. But right now 9 by 4. So be careful. Avoid silly mistakes. Your marks will automatically get jumped. Okay. Now another question from binomial theorem. Another question from binomial theorem. And this type of problem wherein the expression you will see over here. So this is 5. Expression which you are able to see over here. Can you see the expression? This is not a binomial expansion. This is not a proper simple binomial expression, right? In such questions, before applying the binomial theorem, before applying the concepts of the binomial theorem, you have to first of all simplify it and make it in binomial form. Let's do that. Over here, this is 1 plus x, correct? The 1 minus x square is what? 1 plus x, 1 minus x. What is this? So let us just take LCM. This is x raised to power 3 and x cube plus 3x square plus 3x plus 1 whole raised to power 5. Can you see? This is a cube plus 3a square b plus 3ab square plus b cube. 1 plus x whole cube is given to you. So 1 plus x, 1 plus x, 1 minus x, and this is 1 plus x whole cube raised to power 5. So that is 15 upon x raised to power 15, right? And you know what? These two can get clubbed with this. So 1 minus x is left out. 1 plus x raised to power 17 upon x raised to power 15. Correct? Till now it is clear. Now it is very easy to solve, right? Compared to this expression and this expression, just tell me. Let me know. This is scary. This is not at all scary because we are familiar with 1 plus x raised to power 17, isn't it? What we are looking for is coefficient of x cube and x raised to power minus 13. First of all, x raised to power 3 ka coefficient. Let's look for x raised to power 3 coefficient. So coefficient of x raised to power 3 in this, in this expression E, right? In E we are looking for will be equal to coefficient of, if I multiply x raised to power 15, so will be equals to x raised to power 18 coefficient in 1 minus x, 1 plus x raised to power 17. Okay, all right. So we are looking for x raised to power what? 18 coefficient, because 15 plus 3 is 18. So x raised to power 18 coefficient. Now multiply it. 1 multiply, so this is 17 is outside. So 1 multiply, so this is 1 plus x raised to power 17 minus x times 1 plus x raised to power 17. Are you getting my point? 1 multiply this, x multiply this. Now over here, I'm not gonna get x raised to power 18 coefficient. The highest coefficient of this expression is x raised to power 17. But what about this? Here I can get, because here I can get x raised to power 17, that will get multiplied with x. So I'm gonna get a coefficient over here. So from here I am looking for x raised to power 17 coefficient. And that would be what? So minus 17C0 or 17C7 is the coefficient of this, right? So this is minus 1. So minus 1 is the coefficient of x cube. Minus 1 is the coefficient of x cube. I hope you got this. Minus 1 is the coefficient of x cube. Now we are looking for x raised to power minus 13. Understand this. We are looking for x raised to power minus 13 in this. Or what I can say is, I am looking for x square in only this part. 1 plus x raised to power 17 minus x, 1 plus x raised to power 7. Okay, this is outside. X square. So here I'll get coefficient of x square as 17C2. So the answer will be 17C2. And here I am looking for x raised to power 1 because it will get multiplied with x. It will become x square. So x raised to power 1 coefficient is 17C1. So this is the coefficient of x raised to power minus 13. 17C2 is nothing but 17 into 8. This is minus 17. Take 17 common. 17 into 7 is the coefficient of x raised to power minus 13. 7 7 is 49. 119 is the answer of this. And minus 1 is the answer of this. If you add these two, what you are going to get is 118 as the final answer. Yes? Okay. Clear? I hope that this is clear. This was asked in JEE Mains 2024. Give me a big thumbs up if you've understood this. Now we are having a question from circles. And you know what? They have, NTA has said, okay, we have deleted tangent and normal and everything. But they are continuously giving such questions year by year, and in JEE Main 2024 as well. Can you see this question was from JEE Main 2024, which is based on basic things. What they are saying, let's try to understand. Consider a circle. So we are having a circle whose center is clearly alpha comma beta, radius is √50, and now they are saying if this circle touches a line whose equation is y plus x equals to 0. Touches, that means tangent. They have not used the word tangent. Although the tangency condition you all know since your 9th and 10th class, right? And whose distance from the origin is 4√2. At the point P, whose distance from the origin, then alpha plus beta. Okay. Anyway, this is your line. This is your center. Now you have to, and this is your radius. So what you have to apply is perpendicular distance from the center of the circle will be equal to radius of the circle. This is the condition of tangency. You know how to calculate perpendicular distance from the center, right? Alpha comma beta. So alpha plus beta ka mod by √2. This will be equals to radius, which is √5. Squaring both the sides, you are going to get alpha plus beta whole square. That will be equals to 100. Ooh, very easy. Very easy. Right? Very easy. So these type of questions will be there in your 2024 examination April attempt. Can you see? 27 January shift 2. Who were there? Whose shift was there? In the chat box, if you can confirm, yes ma'am, I given the paper on this date. I saw this question and I know that I can do this question, but in the paper, in the question paper, in the JEE Main day, I was not able to do it, right? Okay. All right. So we have a question from continuity and differentiability. Very classic question, but with a little bit of twist. Okay. In this question, they have asked everything: continuity, differentiability, everything. Okay. Then what about 4√2? This information is useless to us. Vanilla, 4√2 is useless. Okay. All right. Okay. So clearly, this is your fx. F is continuous everywhere. They have given that function is continuous everywhere. Okay. So using this information, I can say that at x equals to 0 and 1, I can apply the condition of continuity so that I can get A, B and C. Let's do that. Also, what they are saying is M is nothing but number of points where it is non-differentiable. So that is a later thing. About M, we'll talk about later. First of all, let's talk about continuity and figure out A, B and C. Let's do that. Let's make a deal. Okay. Are we on the same page? Yes. So first of all, I feel that f of 1 is easier. So I'll start with 1 because 0 I feel it's a little bit trickier. So I'll start with 1. F of 1 should be equal to f of 1 minus should be equal to f of 1 plus. What is f of 1? F of 1 is, so basically c plus 3 is equals to 3. That means c is 0. C is 0. Nice. C is 0. This is gone. Let us just remove it from our vision as well. Okay. So f of 1 is sorted. Now continuity for 0. F of 0. What is f of 0? F of 0 is 2. Right? And what is f of 0 minus? I am interested in 0 minus. Is equals to f of 0 minus. F of 0 minus. For that I have to use concepts of limit. We are looking for limit of this expression extend to 0 minus. So limit of a minus b cos 2x upon x square. This is x. Okay. So this is your 2 and now we can apply the expansion. A minus b cos 2x 1 minus cos 2x. So 2x square by 2 factorial and so on, but we are going to stop over here upon x square. So this is a minus b minus minus plus b and this is 2x square. So to be 2x square upon x square. This is equals to 2. Can you see that if these two are equal, then a minus b should be equal to 0. That means clearly a and b should both be equal. A equal to b is what we are going to get from here. And can you see x square cancel, 2 cancel, that means b is equals to 1. So b is equals to 1. A, b both are 1 from this limit. So you know a you know 1 plus b you know 1 plus this is 0. Now you are just looking for m. That's it. You're looking for m. Okay, let me just define my function one more time. This is your fx. Fx is 1 minus cos 2x upon x square. This is x square plus 2. And this is 2x plus 1. And this is x less than 0. X 0 to 1. X greater than. Now f dash. We need to check differentiability at 1 and 0. First of all, let's check at 1. Let's check at 1. So 2x plus 1, this is 2. X square plus 2, so this is 2x. X greater than 1, x belongs to 0 to 1. Right? The moment you put 1, this is sorted. Matlab, at x equals to 1, I can clearly see that my function is differentiable. Now, what about x equals to 0? We can't differentiate this. Right? We can't do that. So what we can do is, we can just apply first principle to check the left hand derivative of x equals to 0. Basically, I am looking for f dash 0 minus or 0 minus h. F dash 0 minus h I am looking for, and I will match it with f dash 0 plus. By the way, f dash 0 plus clearly is 0. So this is your f of 0 minus h minus f of 0 upon minus h. This is your first principle, right? Limit h tend to 0 minus 0 plus f of 0 minus h. So this is 0 minus h, I'll use this. 1 minus cos 2h upon h square minus f of 0 is what? 2 upon minus h. So let's apply expansion over here. 1 minus 2h 2h whole square, and that's it. It will go, and h square minus 2 upon minus h. So 1 cancel, minus plus, and this is 2 factorial. So this is 2h square upon h square minus 2 upon minus h. Can you see 2 minus 2 0? So clearly it is 0. Clearly, and there will be more terms related to h. So this is your 0. That means your left hand limit is coming out as 0. Right hand limit is also 0. That means the function is differentiable at x equals to 0 as well. The function is continuous at x equals to 0 as well. Differentiable, sorry. So differentiable at x equals to 1 and differentiable at x equals to 0. So your final answer would be last option. This is 2, which is 2. Okay. Clear? All right, sorted? Yes. Okay. All right, so now we have a next question. This is from Leibniz theorem. So Leibniz theorem is something which NTA gives you every year in one form or the other. Whether they can put this Leibniz theorem concept in limits or in definite integration. So this is something about definite integration, or you can say that you have to figure out the function as well. So over here you can see this. You know what is Leibniz theorem? Let me just remind you. Suppose you are having a function f of x dx, right? And integration. So this is g of let's say this is t. Okay, f of t dt. F of t dt. Suppose you are having integration f of t dt. Upper limit is hx, lower limit is gx, right? And you have to, so this is your expression, and you have to differentiate it. You have to differentiate it. To differentiate this, you can't just differentiate it because you are differentiating something which is integral of a function. And you know that derivative and integration both are completely opposite of each other or anti of each other, right? So you just don't have to differentiate, you don't have to integrate as well. Rather, you have to apply Newton-Leibniz theorem. And Newton-Leibniz theorem means you have to follow certain rules. Let me just show you how to do that. So first of all, to differentiate this with respect to x, or what you have to do is, first of all, you have to replace this t, which is inside the function, with the upper limit. So f of t will be replaced by g of x. And after that, we will just differentiate the upper limit, that is g dash x, the way we used to do in chain rule, right? So f gx will be replaced by t and will be differentiated minus sign. Now same thing we will do with lower limit. Hx will be written in place of t and will be differentiating h dash x. That's it. This is your Leibniz theorem. That's it. That's it. Okay. Voice is low, you are saying? Okay. All right. Now we'll apply Leibniz theorem over here. So can you see that x will be replaced by t square? So f of t square plus t square. And now t square is upper limit, so I need to differentiate t square. So that will be 2t. What I am doing is I am differentiating both the side using Leibniz theorem, right? Minus sign I will be applying. I will be putting 0 over here, and then I will be differentiating 0, so it will be 0. That's why this part is 0. Okay. So left hand side I have differentiated using Leibniz theorem. But what about right hand side? Right hand side is simply 4 by 3 t cube. So 4 by 3, 3t square. 3 gone, right? So now you are having 4 f of t square, then you are having plus t square, sorry, t raised to power 4, it will be t raised to power 4, right? How? Because the moment you put x equals to t square, it will be t raised to power 4, then you have 2t, that is equals to 4t square, 2 1s are 2, 2 2s are 4, this t is gone, so f of t square you can easily calculate. F of 2t square will be equal to 2t minus t raised to power 4. This is your f of t square. From this is your f of t square. All right. Okay, now what we need to figure out? Let me know. F of pi square by 4. For that, I have to put t is equals to pi by 2 and I'll get my answer. Very easy question. F of pi square by 4. This is 2 pi by 2 minus pi by 2 raised to power 4. So pi minus pi raised to power 4 by 16. So which is the correct answer? Tell me. This is matching with this. Okay. Option 3 is absolutely right. Option 3 is absolutely right. Okay. Have a look. Yes? Clear? I hope that this is question. I think this question looks that it is difficult. It looks, it appears. So many integration, x, t, everything. But this is a very, very easy question. Trust me. Just one Leibniz theorem. You have f of t square and pi by 2. Anyone can just tell by this particular expression that to get f of pi square by 4, just put pi by 2 and you're going to get it. Okay, easy question. Now we are having a question from 2023. Yes. So this question is from 2023 and I have seen this type of question quite a few times. Okay. This is a little bit difficult question, I would say. Okay. All right. So f is a continuous function. This is your pi by 2. Let me just correct. This is pi by 2 and this is pi by 4. Right. So the question says 0 to pi by 2 f of sine 2x sine x plus alpha 0 to pi by 4 f of cos 2x cos x is equals to 0. Basically, this and this, the sum of these two is equals to 0, then we are looking for the value of alpha. Okay, so clearly if I talk about this is I1, let us say this is I1, 0 to pi by 2, f of sine 2x sin x dx. Okay, first of all, how to approach this question? Understand slowly. Can you see that if I shift this quantity towards the right hand side, these two terms will almost be equal. This integration, basically, if this is your I2, so I1 will be equals to minus alpha I2. Do you realize this? I1, I2, I1 is equals to minus alpha I2. So the approach or the mindset of this question should be that I need to make I1 close to I2. I need to make I1 close to I2 or equal to I2, or you can say that similar to I2. Okay, how do we do that? First, one difference I can clearly see that this is pi by 4 and this is pi by 2. The very first difference in both the integration I can see, this is pi by 2, this is pi by 4. The very first agenda is I need to change the limit of I1 so that I can compare it with I2. And I can still say that, yeah, yes, these two are equal. Are you getting it? So for that, I need to make 0 to pi by 2, I have to make it 0 to pi by 4. And this can be done using Queen's property. Let me just remind you what is Queen's property. So if you see 0 to 2a fx dx, you can just write 0 to a fx dx. Can you see? That's what we wanted. 0 to pi by 2, so I have to change 0 to pi by 4. So this is your Queen's property plus, again 0 to a f of 2a minus x dx. What is 2a? This is 2a. This is your Queen's property which we are going to apply over here. Okay. So I1 would be, it is not that difficult, but Queen's property we need to apply. So 0 to pi by 4 f of x dx, that means the function will remain as it is, plus again 0 to pi by 4, but this time f of 2a minus x. What is 2a? 2a is this original, that means f of pi by 2 minus x. In here in I1, pi by 2 minus x is what we need to write. So this is f of pi by 2 minus x is of f of sine 2x only, because pi by 2 minus x is sine pi minus theta sine 2x, and this is pi by 2 minus x is cos x dx. This is still your I1. Now one more step we are going to go and we will be done. What is that step? Just apply King's property in both. Applying King's property in both will give me cos 2x and cos 2x, which will be comparable in this. Okay, so I'm going to apply King's property from here to here. King's property, let's apply. So that will give me I1 is equals to 0 to pi by 4 f of, can you see, pi by 4 minus x will be replaced by pi by 4 minus x. So that will become 2 times pi by 4 minus x, pi by 2 minus 2x. Sine pi by 2 minus 2x is cos 2x. And this is sine pi by 4 minus x. Sine pi by 4 minus x is what? Sine a cos b. Sine pi by 4 cos x minus cos a sine b. This is your King's property. Plus again King's property in this 0 to pi by 4. This is gonna be f of cos 2x. And over here, pi by 4 minus x, cos pi by 4 minus x, cos a cos b plus sin a sin b. So this will be cos x by root 2 plus sin x by root 2 dx. That's it. Now can you see that cos 2x is here, minus 1 by root 2 plus 1 by root 2 will get cancelled out. This is 0 to pi by 4, 0 to pi by 4, cos x by root 2, cos x by root 2. So your I1, clearly final I1 will be 0 to pi by 4. Can you take f of cos 2x common? And you will be left with what? Cos 2x by root 2, cos x by root 2. So 2 by root 2 cos x dx. This is your I1. Now compare. Now you can compare. Now you can compare. So this is 2 by root 2, that is root 2. So this I1 is, okay, so if I write I1 will be root 2 times 0 to pi by 4 f of cos 2x and cos x. This will be equals to minus alpha of same thing. So can you see minus alpha and root 2 are equal? Alpha will be equals to minus root 2. Now everything is about comparison. Okay, yes, Savaram, absolutely right. Minus root 2, that is option 4. Okay, so in the end what we did was I1 is this, and can you see this whole thing? I1 basically is coming out as what? So this is I2 only. I1 is root 2 times I2. I1 is coming as root 2 times I2. So now compare, minus alpha and root 2 are equal. Alpha is root 2. So there are many times that many methods you can compare. Okay, you can just final answer you can give. Okay, all right. So this is your question. Okay, so one student is saying that answer is easily coming from Leibniz rule only. We cannot apply Leibniz rule in this. Leibniz rule is only applicable when your limits are variable. Are you getting my point? So this is not a question from Leibniz theorem at all. Okay, all right. Now we have a question from differential equation. So in past few years, NTA is giving you such questions where by looking at the question, you can't say that this can be done by the, this is a differential equation question. So by just looking at this, you won't be able to judge. But the moment you apply Leibniz theorem in this is the question from Leibniz theorem, you will realize this is a differential equation question. Come, we'll solve it together. So now x square fx minus x. Let's differentiate. So 2x f dash x. I am applying on the left hand side product rule. X square fx. So 2x fx plus f dash. Fx is constant. Sorry. Yes. Again, one more time. X square f dash x plus 2x f of x. Product rule. And minus 1 will be equal to, on the right hand side, I'll be applying 4 times Leibniz rule, which is x fx, that's it. Because the lower limit will be 0, the derivative. Okay, all right. So now x square f dash x. What is f dash x? dy by dx. Plus, can you see these two are like terms? I can shift everything towards the right hand side. So this is 2xy plus 1. Now can you see? This is a simple differential equation. Divide everything by x square. So dy by dx, can we shift minus 2xy upon x square is equals to 1 upon x square. This is your differential equation. Xx gone, so dy by dx minus of 2 upon xy is equals to 1 upon x square. Can you see? This is the clear-cut case of linear differential equation. You know how to solve a linear differential equation, right? So let's do that. For that, we need to first of all integrating factor. E raised to power integral of minus 2 by x dx. Right? So minus 2 will be common. So e raised to power minus 2 log of x. So minus 2 will be go. So 1 by x square is your integrating factor. What is the solution? How do you write the solution? So y by x square is equals to integral of q. Q is 1 upon x square. Multiply integrating factor is also 1 by x square dx plus c. So y upon x square is equals to integration of minus x raised to power minus 4 dx, and we are having after that constant y upon x square. Can you see? Minus 4 plus 1, so x raised to power minus 3 upon minus 3 plus constant. This is your final differential equation, right? Now initial condition is given, f of 1 is what? 2 by 3. f of 1 is 2 by 3. So y is equals to, let's multiply x square. So y is equals to minus 1 by 3x plus cx square. Now f of 1 is 2 by 3. That means 1 comma 2 by 3 will satisfy in this. So y is 2 by 3 minus 1 by 3 plus c. So c is nothing but 1. So finally what you're going to get is y is equals to minus 1 by 3x plus x square is your final y. Y can be replaced with f of x. Y can be replaced with f of x, right? So you are looking for f of 3. So y will be equals to minus 1 by 9 plus 9. So y will be equals to 9. 81 minus 1, 80 by 9. Now you are looking for what? 18 into f of 3. So 18 y will be equals to 18 into 80 by 9. 9 2s are 160 is the final answer, option 2. Right? So you might see some question wherein by looking at this, nobody could judge, okay, this is a differential equation problem, but can you see this is a differential equation problem? That you will understand once you differentiate it, and you will realize, okay, I am having f dash x and fx together, which is not likely to be solvable by just integration. So this is a definite integration problem. I hope that this is clear. Yes, let us move on to the next problem, and this is most predictable question for JEE Mains 2024, right? System of linear equation. So these are the system of linear equations you can see on your screen, which has infinite many solutions. What happens when a system of equation is having infinite many solutions? Who is going to tell me? How, when exactly the system of equations is having infinite many solution? When all delta is equals to delta x is equals to delta y is equals to delta z, everything is 0. When everything is 0, then it will have infinite many solution. Are you getting my point? Yes? Yes, Muthu, absolutely right. Yes, Hasini, absolutely right. Okay. So first of all, let me pick delta is equals to 0, 1, 1a, 2, 5, 2, 1, 2, 3. Determinant 0. Just proper calculation you have to do. 15 minus 5 3s are 15, सही लिखा है ना मैंने? 2 5 2 1 2 3 1 1 a. Yes. 5 3s are 15 minus 4. Then we have minus 1. We have 6 minus 2, 4. Then we have a times minus 1. So minus a, right? 2, 4 minus 5 is equals to 0. So can you see 15 minus 4 is 11. 11 minus 4 is what? 11 minus 4 is 7. 7 is equals to a. So value of a is coming out as 7. Right? Yes, clear? Now 3b. B we have to calculate. For that, what I have to do is I have to calculate del x. Let us say that del x is 0. Or no. Del z should be 0. Del z. What is del z? 1 2 1. 1 5 1 5 2. But this will get replaced by b6 3. Yes, del z is equals to 0 will make more sense. Right? Now 5 3s are 15 minus 6 2s are 12. So this is 3 minus 1. We are having 3 2s are 6 6 0. Oh, nice. Plus b. We are having 2 2s are 4. So minus 1 is equals to 0. Clearly that this is 0. So b is coming out as 3. So this is 14 plus 9. 14 plus 9 is what? 23. Option 3, option C is absolutely right. Right? Correctamundo? Correctamundo? Yes? All right. So this is a very good question from April 2020. I have picked a random question. Random question means there were so many problems based on system of equations. I can't even tell you. In 2023, full of system of equation, 2022 full of system of equation. So this is the most predictable topic. Okay. All right, now we have another question wherein they ask about domain. From functions, two topics are very popular. Number one is domain. It could be inverse function domain, it could be logarithm function domain, and the other is functional equation. Yes, functional equation, right? So this is your domain. Domain you have to calculate. The expression which is inside your second verse either should be greater than or equal to 1, or this should be less than or equal to 1. Greater than or equal to 1 or less than or equal to minus 1. Remember, there is an or between this. So let's just solve it. 2x upon 5x plus 3 minus 1 greater than or equals to 0. 5x plus 3, 2x minus 5x minus 3x minus 3 greater than or equals to 0. 3 I can take common, x plus 1 upon 5x plus 3 less than or equals to 0. So if I draw minus 1 and this is minus 3 by 5. So if this is 0, minus 3 by 5, right? So negative. So we are having minus 1 excluding this. This is my final answer from the first part. Okay. All right. So this is one of my answers. I have to take union of these two, right? Now let's solve it. 2x upon 5x plus 3 plus 1 less than or equals to 0. 5x plus 3, 2 plus 5, 7x plus 3 less than or equals to 0. Again, minus 3 by 5 and minus, so minus 3 by 7 will lie over here, minus 3 by 5 will lie over here. Can you see that in the number line, you go from right to left, the numerical value increases. So 3 by 7 is smaller, 3 by 5 is bigger, right? I am talking about the numerical value without sign. So that's why please keep in mind which to keep, what to keep over here, what to keep over here. Again, negative sign, that means this will get included and this will get excluded. Minus 3 by 5 is never there. Okay. So now we need to combine. Minus 1 to 3 by 5. My domain would be minus 1 included to minus 3 by 5 open. This can never be in my answer because it is in denominator of both the expressions. Union minus 3 by 5 to minus 3 by 7. Now this can be included. This is my final answer. Now we can just write the value of alpha, beta, gamma, delta. Okay. Alpha is what? Minus 1 clearly. Comma. Beta and gamma both are equal. Minus 3 by 5. And delta is minus 3 by 7. Now let us just put the value. So mod of minus 3 plus 10 beta plus gamma. So minus 6 by 5. So 10 times minus 6 by 5. This is your modulus. Plus 21 delta. So 21 delta is what? 21 into minus 3 by 7. So 5 2s are 10. 7 3s are 21. Minus 9. Minus 12. Minus 3. Minus 9, minus 12, minus 3. 12 or 12, 24 is the correct answer. 24. 24. The moment you add it, what will you get? 12 plus 12, right? 24 is the right answer. Okay, okie dokie. Good question, I would say. Not a very difficult question. It's just that you have to be very focused while doing the question, because it might happen that you do some calculation error. Don't do that. You don't have any option now. Please remember, now you don't have any room for the calculation mistake or silly mistake. Do you agree or not? Do you agree or not? In JEE main paper, which is almost within a week you are having your JEE main paper, please keep two things in mind. No calculation, no room for calculation error, no room for silly mistake. Silly mistake could be, oh, I misread, I misinterpreted, or I just, instead of A by B, I answered B by A. These are all silly mistakes, right? So there is no such room. Okay, all right. And this can be avoided if you are a little bit alert, attentive. Okay. Just be a little bit alert. Being a little bit alert and attentive will give you some positive marking, right? +4, +10, whatever. Depends. Okay, how much alertness you are looking for in your life. Yes, so now this type of question, can you see this type of question was there in 2024 as well, and I have made a YouTube shorts on this channel regarding the same problem, right? So the concept is adjoint of A, and determinant is equals to determinant of A raised to power n minus 1 raised to power k, where this adjoint is written k times. This is the concept, okay? N is the order of matrix A. This is the concept, okay? Now let's apply in this. Adjoint is written 3 times. So this is going to be determinant of 2A raised to power n minus 1. N is 3. So n minus 1 is 2. And power you are having how many times? 3. So 3 2s are... Oh. Please understand, this is n minus 1 raised to power k. So this is 2 n minus 1 raised to power. There is one mistake that anyone can do. So this is n minus 1 raised to power 3. So 2A determinant will be 2 cube is 8. Now 2 can come out. So we'll use a property, k times A determinant will be k raised to power n determinant A. So this k constant will come out of determinant by applying the power as the order. 2 will come out. So it will be 2 raised to power 3 determinant A, and let's not forget this power 8. So now, so power is what? 3, yes, and 1 2 3, and this is determinant A. Let's calculate the value of determinant A. What are we waiting for? So determinant A, where to calculate? Here. Determinant A is what? 2. 2 2s are 4 minus 3. So 2 multiply 3. Then we have minus 1. So minus 1. 3 2s are 6. Sorry, minus 1. 2 2s are 4 minus 1, 3. So 2 into 3. And we are having minus 1. So that's it, 2. So 4, determinant A is 4, that is 2 square. 2 cube, 2 square raised to power 8. So this is 3 plus 2, 5. 5 8s are 40. 2 raised to power 40 is equals to 16 raised to power n. 16 raised to power n is nothing but 2 raised to power 4n. If I compare these two, clearly 4n is equals to 40. That means n is equals to 10. Understood? We have to be very careful in this. One by one. What mistakes we can do, understand. First mistake is n minus 1 cube. So 2 cube. Sometimes we confuse by 2 power 3. So 2 3s are 6. Okay. This mistake we have to avoid. So 2A. Now 2 can come out. Sometimes what we do, we take out 2 but we forget this power 8. So 2 cube raised to power 8. Please do not forget the power. Okay, these are the common mistakes in this question. Be careful. Okay, be careful. All right. So now we have a question from 3D geometry, and I feel that shortest distance is something which the NTA is asking since so many years. Okay, shortest distance between these two lines. So we just have to apply the formula. Do you know the formula? Yes or no in the chat box. Do you know the formula? So shortest distance calculation is very easy. Okay. Pavani is saying n minus 1 cube is 3. No. N minus 1 cube. N is n minus 1 cube. So n is 3. 3 minus 1 is 2. 2 ka cube is 8. 2 ka cube is 8. Right? And now this 2 will come out of this. So 2 raised to power n by using this property wherein we apply the power as a order to the constant. So shortest distance, okay, by the determinant method. So in row number 2, first of all, let me just arrange it properly x plus 7 by minus 6, y minus 6 upon 7, z minus 0 upon 1. So row number 2 will be having minus 6, 7 and 1. Minus 6, 7 and 1. And what about the second line? So let me just rearrange x minus 7 upon minus 2. Okay. Y minus 2 by 1. Z minus 6 by 1. Minus 2, 1, 1 will be in the row number 3. And row number 1. For that, I need to calculate the point minus 7, 6, 0. And we having 7, this is 2. 7, 2 minus 6. Sorry, 7, 2 and 6. Yes. Correct? Correct. 7, 2 and 6, minus 7, 6 and 0. Yes. Now, x2 minus x1. x2 minus x. 7 minus minus 7, 14. Then we are having minus 4 and 6. Upon, we are having a cross product. I, j, k, just copy paste row number 2 and 3. Minus 6, 7, 1. Minus 2, 1, 1. And just solve it right away. Solve it right away. Ma'am, it's plus 2. Plus 2. Plus 2. No. So this is, I have flipped it, na? X minus 7 upon minus 2. Yeah. Yes. This is 2. Correct. Now solve it. 14 times we are having 6. Plus 4 times we are having minus 6. Plus 2, that is minus 4. Plus 6 times square. Right? Okay. If you solve it, how to solve it? Let me just make it a little bit easy for you. Can you just take 2 square common from the denominator? If you take 2 square common from the denominator, so this is 36. So you take 4 common, it will become 2. 36 divided by 4 is 9. So the final answer, let me just write it over here. So this is square root of. The moment you take 4 common, no, it will become 2 outside. And it will be 36 by 4 is 9. 16 by 4 is 4. And 8 ka square. So this is 64 by 4 is 16. And from the numerator, take 4 common. So this is 7 into 3, 21, because you have taken 4 common. 1 4 is gone, so minus 4. And then plus you are having 6 2s are 12. So 21 plus 12 is 33. 33 minus 4 is 29. Can you see? So 2 into 29 upon root 29 is your answer, which is 2 root 29, option A. So many people are already saying option A, option A, option A. Absolutely right. B option, who is saying B option 1 is absolutely wrong. No, no, no. 29 by root 29 is root 29 into 2. Okay, Shyam. I hope that you've done the correct the correct calculations. Okay. All right. Now we are having this question. Okay. So this is this type of questions. These type of questions. Okay, somebody is saying physics session went missing. No, it is not missing. So it's just that when we do multiple streamings, we are in different studios. When we do multiple streamings, what happens is when I am live, sir's session is not visible, and if we end the live session after 1 or 1.5 hour, the complete session will be visible. Okay, please don't worry, don't panic. So once the stream is ended, so it will end up by maybe 8 o'clock, 7:30. So you can check after 8:30 p.m. it will be visible. Okay, all right. Okay, so let us do this question, which is from series. Okay, so question from series. First of all, in such questions wherein product of two factors is given in the denominator, how do we tackle such problems? So first of all, just figure out 4n plus 3 minus 4n minus 1. So you must be wondering, ma'am, what are you doing? Are you just subtracting? So the agenda is to create the subtraction of these two factors in the numerator. Yes, agenda is to create subtraction of these two factors in numerator. Okay, let's do that. So this is 4n gone. 4 should be in the numerator, right? So I'll be multiplying 4 over here and dividing by 4, because this 4 will be replaced by, now 3 by 4 we can just take out common. Sigma n equals to 1 to 21 is there, and this 4 will be replaced by, so this is 4n plus 3 minus 4n minus 1. This 4 will be replaced by this, and we have 4n minus 1, 4n plus 3, correct? So 3 by 4 is here, and we are having 4n plus 3 gone. So 1 upon 4n minus 1 minus 1 upon 4n plus 3. And of course, n is equals to 1 to 21. Now we have to just put n is equals to 1 in this. So 3 by 4. The moment I put n is equals to 1, so this is 1 by 3 minus, the moment I put 1 by 7. The moment I put n is equals to 2, 1 by 7 minus 4 2 is 8, 9, 10, 11. And all the way up to last, we are going to put what? 21. So 4 into 21. 84 minus 1. 83 minus 1 upon. So this is 4 into 21 plus 3. 4 2 is 8. 84 plus 3 is 87. So we are having 87. The moment I put n is equals to 27, and this is n equals to 1. Sorry, 21, right? Now can you see this? These terms are getting cancelled out. So we are left with 1 by 3 and 1 by 87. So final answer will be 3 by 4, 1 by 3 minus 1 by 87, right? So 3 by 4, 3 into 87, 87 minus 3. You know 87 minus 3 is what? 84. So this is 3 into 84, 3 into 87, and we are having 4, 3 cancel, 4 ones are 4. So 21 upon 87. 3 ones are 3, 3 sevens are 21, 3 twos are 6, and 3 nines are 27 upon 29 is the correct answer. 7 upon 29, option B. Can I see in the chat box? All right, all right. 7 upon 20. Yes, 21 upon 87 is what? 7 upon 29. Yes, Hasini, absolutely right. 7 upon 87, people are saying wrong. Option B is right, clearly. Hai na? Okay, so be careful, because in such questions, similar answers are there. Even if you do all the process, just the last step, if you do some calculation error, it will match with the wrong answer, and you are going to get a -1. Remember, a -1 is not -1. A -1 is -5. Right? So if you have done that question correct, you would be getting +5 than the current situation. So it's not just -1. Please remember, it is -5. Okay. All right. So we are having last few questions now. Okay, 2-3 more questions and we are done for mathematics. And Durgesh ma'am will be taking the session. Okay, so these type of questions are quite popular in JEE Main. This is from Newton's formula, and I have made a short video to explain you what is a Newton's formula, right? So if you're not aware about the Newton's formula, you can go and check out that short small video, like 5-minute, 7-minute video in which I have explained the complete Newton's formula, and I have solved 2 questions from 2024 as well, right? So this is from Newton's formula, and this is it, right? So Newton's formula says that clearly x square minus x minus 4 is equals to 0. So Newton formula says that for this equation, you can just write Pn minus Pn minus 1 minus 4 times Pn minus 2 is equals to 0. So the basic idea of Newton's formula is basic idea of Newton formula is that x square will be replaced by Pn. X will be replaced by Pn minus 1. And this constant 4 into constant 1, that 1 will be replaced by n minus 2. So 3 successive Pn will be there, and Pn is nothing but alpha raised to power n minus beta raised to power n. So now understand this. P1516 minus P1416. Can I take P16 common from these two? If I take P16 common, it will be P15 minus P14. Minus, can you see? P15 can be taken common. So this is P15 minus P14. Now P15 minus P14. So this is numerator. 15 minus 14. So 15 minus 14. If I put n is equals to 15, what do I get? Tell me. P15 minus P14 is equals to 4 times P13. So this can be replaced by P16, 4P13 minus P15, 4P13. Right? Upon we are having P13 and P14. Okay, P13 can be taken out common and cancelled out. 4 also can come out. So we are left with 4. P16 minus P15. Now P16 minus P15. 16 minus 15 will be 4P14. Yes. So this will be 1 4 is already there. 4P14. Very easy question. Upon we are having 1 4 P14 left. P14 P4 4 4 is 16. So with the help of Newton's formula, this question can done in a jiffy. I can see that people who know Newton formula, who are aware about this formula, are giving me answer before me. So I am super duper happy. When you do such problems now, I am so very happy. Super duper charged up, super duper pepped up. Okay. All right. Okay. All right. Now this type of question is also popular from ITF. They give such question where they give you series problem of tan inverse. Series problem of tan inverse, right? So for series problem, set algorithm is there, that I don't know how, by hook or by crook, just create tan inverse A minus B whole upon 1 plus AB, because that will give you tan inverse A minus tan inverse B, and that will convert this whole question in telescopic series. So you have to solve the question with the help of telescopic series. Okay. All right. So this is it. Now what you need to do is, all right. So you have to just create 1 plus AB. You have to create 1 in the denominator. How do you do that? Just take this term common. So this will be tan inverse. So if you take it common, what do you get? 6 raised to power r. From numerator and denominator, take 2 raised to power 2r plus 1 common. So you are going to get 2 raised to power 2r plus 1. And this will be 1 upon 3 by 2, 2r plus 1 inside the tan inverse. Trust the process, trust the process. Trust the process. This is very good question. So what I did is, I have taken 2 raised to power 2r plus 1 common from numerator and denominator, and it got cancelled out. Right? So this will be 1. And if it is not having 2 raised to power 2r plus 1, we have to divide. And again 6 raised to power r upon 2 upon 2. Okay. So this is tan inverse. Now simplify this. Simplify this. How? 6 raised to power r is this. This is what? 2 raised to power r, 2 raised to power r, 2 raised to power 1. Correct? This is your numerator. Upon, we have denominator as well. Right? So we have 1 plus 3 by 2 raised to power r and 3 by 2 raised to power r plus 1. Clear? Trust the process. You will be able to create it. Trust the process. Do not give up. In such questions, we feel that, okay, I'm not getting it. Maybe I'm doing wrong. No, no, no. You're doing absolutely right. Okay. And yeah. So this is tan inverse. Let me just write it over here. Tan inverse. And we are having 3 by 2. So 1 by 2 will be left out. Can you see 1 by 2 is separate? And this is 3 by 2 raised to power r. Correct? Upon 1 plus is already there. and we are having 3 by 2 raised to power r plus 1. So 3 by 2 raised to power r plus 1 and 3 by 2 raised to power r. So if this is your A, this is your B, this is your A, this is your B, tell me what is the value of A minus B. So A minus B will be equals to 3 by 2 R or 3 by 2. This is your A, right? R plus 1 minus 3 by 2 R. So this is your B. Take common. 3 by 2 R can be taken common. So it will be left with 3 by 2 minus 1. So can you see now? Can you see? Can you see? This is exactly numerator. Can you see? If this is your A, this is your B, this is A minus B automatically, right? That means this is tan inverse. A minus B is what? 3 by 2 raised to power R plus 1 minus 3 by 2 raised to power R. This is tan inverse A minus B whole upon 1 plus AB. I am able to create it. Now I can write it as tan inverse 3 by 2 raised to power R plus 1 minus tan inverse 3 by 2 raised to power R. Right? Yes. What is the question? R is equals to 1 to K. Okay. So just start T1. What is T1? Tell me. What is T1? T1 is tan inverse 3 by 2 ka square. Tan inverse 3 by 2 square minus tan inverse 3 by 2. What about T2? Tan inverse 3 by 2 cube minus tan inverse 3 by 2. And last step, Tk. Tan inverse 3 by 2 raised to power k plus 1 minus tan inverse 3 by 2 raised to power k. So like this, it will get cancelled out. So we are left with this and this. So final value Sk. Sk is what? Tell me. K tend to infinity, this term minus this term. This term minus this term. So Sk is coming out as tan inverse 3 by 2 raised to power k plus 1 minus tan inverse 3 by 2. That's it. The moment you put k infinity, it will become 3 by 2 raised to power infinity. 3 by 2 raised to power infinity is infinity. So this is pi by 2 minus tan inverse 3 by 2. Pi by 2 minus tan inverse 3 by 2 is nothing but cot inverse 3 by 2. Yes or no? Yes or no? All right. Clear? That's how you do it. Okay. So only one thing. You have to just build a 1 over here and trust the process till you get tan inverse A minus B whole upon 1 plus AB. And I have seen that many people just give up right after 1 or 2 steps. They feel that I'm not getting that form. But you are getting. You're not trying. You're getting it. You're just not trying. You're giving up too early. Right? Don't give up in such questions very early because it will be there. Okay? Alright. So next question is from the vectors. Okay? From the vectors, we are having next question. A vector, B vector and C vector is given to us. And this type of equation is given. I have told you this multiple times. When we were having sessions for first attempt, for January attempt now, I have showed you this equation multiple number of times. Right? So NTA's favorite vector equation is this. Wherein they give R cross A is equals to C cross A. How to solve it? How to solve it? So R vector cross A vector. Shift everything towards the left hand side. Because A is common. So I can write R minus C cross A. And what happens? I have told you this. What happens when two vectors cross product is 0? Cross product of two vectors is 0 when they are parallel vectors. Remember or not, these two are parallel vectors. Yes, you are going to get the complete session PDF together, physics, chemistry, maths combined. Do not worry. So this is R vector is equals to, so these two are parallel, right? So R minus C vector will be equals to lambda A vector. That's how we write two parallel vectors. When two vectors are parallel, A and B are parallel, A is equals to lambda B. If these two are parallel, R minus C is equals to lambda A. So R vector is coming out as lambda A plus c, this is your r vector. You know a vector, you know b vector, and one information more I need to get the value of lambda. Take dot with b, both the sides. So r dot b is equals to lambda a dot b plus c dot b. R dot b given as 0, lambda a dot b plus c dot b. So lambda times a dot b, who is going to tell me a dot b? Let me just check. So 1 minus 2, minus 1 is this, that's it. C dot b, who is going to tell me? So 1 plus 1, 2. So plus 2 is equals to 0. Clearly lambda is coming out as 2. The moment you see lambda is 2, that means r vector you will be calculating 2a plus c vector. Correct? This is your r vector. Now you are sorted. Now you can just easily calculate whatever they want to. So you have to calculate r dot a. To calculate r dot a, just take dot with a. So 2a square plus a dot c. That's it. Okay. So a square, who is going to tell me a square? 4, 5, 6. So this is 12. Correct? A square. 4, 5, 6. A square is 6. 6 2s are 12. Plus c dot a. Now c dot a is 1 minus 2, 1. So 1 minus 2 plus 1. So this is 0. So final value is nothing but 12. Okay. Clear? Clear? Yes. All right. And we have skipped one question. This is also from JEE Mains previous year question. So today's session is all about previous year questions. But tomorrow's session is non-PYQ session. Okay. So this is your homework question. This is your homework question. Please take this question as the homework question. It will be there in your PDF. Right. And now we are done. And yes. Oh, sorry. One more question we are having. Yes. This is the last question. This is the last question. Last question, and after that Durgesh ma'am will be there. Okay. All right. Now look at this question. This is 5 raised to power x. 5 raised to power x plus 5. All right. Function fx is given. Fx is what? Tell me. 5 raised to power x. This type of question are quite popular, wherein what you have to do is you have to understand the pattern. F of 1 by 20, 2 by 20, 3 by 20, 39 by 20. So you have to understand the relation between 1 by 20 and 39 by 20. What is the relation? If so 1 by 20 and 39 by 20, if I add, what do I get? No, Hasini. Yes. Hasini, please understand this question. I have kept it for you only. You are doing wrong. Why 1 by x? Why 1 by x? So usually in such questions, you put 1 by x, but this is a little bit difficult. I will show you why we will put 1 by x. So this is 1 by 20, 39 by 20. If you add these two things, you are going to get 40 by 20. Sum is not 1. 40 by 20. What is 40 by 20? Who is going to tell me? 40 by 20. That means 2. You are getting 2. So if this is your x, this is your 2 minus x. So what you are looking for is f of x plus f of 2 minus x. That's what you are looking for. So that you can pair them up and you can figure out the final value. Similarly, 2 by 20 and 38 by 20. It will give you 2, right? X, 2 minus x. So replace not 1 by x. You have to replace it by 2 minus x. Okay. F of x is this. Let us put the value. F of 2 minus x. So 5 2 minus x, 5 2 minus x plus 5. So this is 5 raised to power x, 5 raised to power x plus 5, and this is 5 ka square upon 5 raised to power x upon 5 ka square upon 5 raised to power x plus 5. Can you see 1 5 1 5 1 5 is gone. So this will be 5 raised to power x upon 5 raised to power x plus 5. Plus, can you now see this is 5 upon 5 raised to power x. So this is 5 upon, take LCM, 5 plus 5 raised to power x. If you add, what do you get? You get a 1. You get a 1. Are you getting my point? The moment you add f of x, f of 2 minus x, you simplify, keep on simplifying, you are getting a 1. That means this plus this is 1. First and last. Second and second last will give you 1. Third and third last will give you 1. But how many times is the question? We need to be very careful in such questions. First of all, count the number of terms. 39 terms is there. And we are combining two terms. That means number of terms are odd. 39 is an odd number. So one term will be left out, right? So 38 terms plus one term will be left out. Those 38 terms will be paired up. So we are going to get 19 pairs. So 1 plus 1 plus 1, how many times? 19 times. But one term will be left out. That will be the middle term. And the middle term will be f of 20 by 20. Yes. I will be left out with f of 20 by 20, that is f of 1. So 19 plus f of 1 will be the correct answer. F of 1 you can easily calculate. F of 1 is clearly half. So this is 19 plus half is the correct answer of this question. So 38 plus 1, 39 by 2 or 19.5, whatever you want to say. All right, I guess this is the last question. One question. Homework, yes, Naga Nasri, absolutely right. You are absolutely correct about the one term will be left out. That will be 20 by 20, middle term. 20 by 20 is f of 1. Okay, all right, yes. So now I'm done. Mathematics part is done. PDF will be combined, PDF will be shared with you all. And I'm going to call Durgesh ma'am right away. Okay. See you. Bye-bye.
Hello students, let me just log in into my account. We will begin in just a minute, Hi everybody. Okay, let me open the chat box first. Let me open the chat box. Okay. Hi everybody. So right now, as you've completed two of the things with you, right? We can begin in just a while. Like, see, I have to prepare so much in just to do this thing, right? Chalo. Can everybody see me? Hi, bacha. Hi, everybody. So now it's time for organic chemistry. Again, once again, we left off yesterday night. So let's begin from the very basics right now. What we're discussing right now are the most repeated pattern of questions. So what I've done, I've made types of questions as list. And we're going to look at each and every type of questions that are, those questions are asked so many times. They have the highest probability of getting asked. Okay? So let us begin without wasting any time. Type number 1 on your screen is hybridization. Can everybody see this? Hybridization questions are extremely common. Try to answer this question for me. in this compound the hybridization of carbon 1, 2, 3 and 4? Try to answer this question for me. What do you think? First answer by Harshit Jaldu as A. A answer I have received. Okay, do anyone else want to answer this question? Try to answer this question. Okay? Let me open the chat box in my phone. Okay? Also, let me know how is your preparation going on. How excited are you? How nervous is everybody? Right? And what are the questions running in your head right now? In which field do you need the most help? Are you facing the most difficulty at this point of time, right? Because right now we know what our preparation is. In one day we cannot achieve so much. So what we're trying to do here is just making you revise all the concepts so that you are thorough with every kind of questions that are going to be asked. I mean 110% these type of questions are going to come in your JEE exam, right? So right now, what is the purpose? To revise every topic, right? I cannot make you learn something new today. I can, but can be just a few concepts where you were struggling with, right? So this is a very good lecture to understand those concepts which will be definitely asked first of all, and second of all those concepts where you just find a little bit of doubts in them. Okay? So we're going to focus on such mechanics of learning in this session. A answer I have received. Okay, let us begin to solve this question. So here can everybody see? Can everybody see? This CH2 over here is sp2 hybridized. Right, this CH2 is sp2 hybridized, this is sp hybridized, this is once again sp2 hybridized and sp3 hybridized. So the correct answer is A. Everybody is absolutely right. The correct answer is A. I'm moving on to the second type is IUPAC name. For sure IUPAC name is going to be there in your exam. IUPAC naming in some or the other way. Try to name this compound. The correct IUPAC name of the following compound is. Try to name this compound. Everybody. Beta, I cannot tell you how many questions will be easy and moderate in the 9th shift. I cannot. I didn't make your paper. So how would I know that, right? We can just prepare for the day. Just remember one thing. On the very initial days, like the 4th and the 5th, would be the easier shifts. And then afterwards, you know what will happen? The questions will get repeated in the shifts of 6th, 7th, 8th, right? So you need to focus on what kind of questions are asked on the 4th and 5th, because on the shifts on the oncoming days, then those questions or the type of questions. So please follow the channel, because we will be discussing the questions on 4th, on 5th and 6th as well, so that could help you on your 9th and 10th shifts, 8th and 9th shifts, right? Okay, so I've received so many answers here. First of all, identify the primary functional group, which will be the principal functional group. Can everybody see? The aldehyde group will be the principal. Then the rest of the groups will be what? Will be considered as a substituent, right? So let's now start counting the number of carbons. So we will count, because this is a principal functional group, we will count from here. 1 carbon, 2 carbon, 3, 4, 5, 6 and 7. Can you see a 7 carbon chain is formed? Right? Now tell me the answer. Can you see that on the 4th position there is a methyl? On the 3rd position there is a oxo group, right? And on the 6th position there is a nitro group. So the correct answer is C. 4 methyl, 6 nitro, 3 oxo, hept 4. On the 4th position there is a double bond, enol. So the correct answer is C. 4 methyl, 6 nitro, 3 oxo. This group is called oxo group when used as a substituent. Hept 4 enol. So bacha, IUPAC naming is extremely important. Such questions will definitely be there. Okay, I'm moving on to the next question now. Next question is structural isomerism. Again, very important category of questions will be there most definitely. Try to answer this question. The compound C4H10O can show what kind of isomerism? What do you think? Look at this compound. What do you think? What kind of isomerism can C4H10O show? Try to answer this question. First answer I've received is D. D. Very, very good, Hasini. Very, very good, Harshit. Okay. I've started receiving answers. Muthu has also answered D. Let me try to form the compound C4H10. So C4H10O can be written as an alcohol like CH3, CH2, CH2 and CH2OH. Okay? This is the first kind, which is an alcohol for this. I can even form an ether out of it, right? I can form like CH3, CH2. Here I can write O. Here I can write CH2, CH3. Okay? So these both have the same molecular formula, but the functional group is different. Can everybody see? So this is definitely showing functional isomerism, right? Now let us see if it can show positional isomerism. Yes, very well. So here the OH is on the carbon number 1. Similarly, I can write it as CH3, CHOH, CH2, CH3, right? So this is what I formed. Now the OH is on the second carbon. So now these two bacha are your positional isomer. Can you see I've changed the position of the alcohol group? Here, hence it is also showing positional isomerism. Now number three, let's check for metamerism. What is metamerism? So this is one kind of ether. Now this is the functional group of ether, the oxygen in the middle. Now I can change the position of the alkyl along the oxygen, isn't it? I can also write it as CH3, CH2, CH2O, CH3. Can I write this as, okay? This, both of them again have the same molecular formula, but the position of the ether group has changed. So when such a position of the alkyl groups change around the functional group, right? Here what was happening? I was changing the position of the functional group, hence it is called positional isomerism. But in the below case, what am I doing? I am changing the number of alkyl groups around my functional group, which is ether. So this is called, bacha, this kind of isomerism is called metamerism. So this is showing all three kinds of isomerism, which is positional, functional and metamerism. Is this thing clear to everybody? Is this thing clear? Now I'm moving to the next question. The next is the total number of possible stereoisomers of dimethyl cyclopentane is. See, this is a kind of numerical based question. Very, very common. Numerical based question, and this is such an easy question. You can definitely answer this if you are not very afraid of such questions. So first try to draw the structure of dimethyl cyclopentane, right? How can I draw the structure? So cyclopentane looks like this, right? This is the structure of cyclopentane. Now I have to attach two methyl groups. So I can attach two methyl groups on the same carbon, isn't it? So this is one of the structure of dimethyl cyclopentane. Will they show any kind of stereoisomerism? No, because this has no chiral carbon. No chiral carbon, therefore no stereoisomerism. No stereoisomerism. So this will not show any stereoisomerism. Now let us make another isomer of cyclopentane dimethyl. So another isomer can look like this and this. This is also dimethyl cyclopentane, isn't it? Now this can show stereoisomer. Why? Because this carbon and these carbon are what, bacha? Chiral carbons, isn't it? Both of these carbons are chiral. Now what can I do? I can make two stereoisomers out of it. For example, like this. I can attach both the methyl groups on the front position, or I can attach both the methyl groups on the back position, like this. Okay? Now both of them are what, bacha? Both of them are called identical isomers. Identical, right? Whether I attach both from the back or both from the front, both are identical. So these will be considered as just one isomer. Just one stereoisomer. Understand this thing. Okay, whatever I'm explaining to you is very, very essential. Next thing is what? Again, I'm drawing the cyclopentane structure. Now I can do one thing. I can attach one methyl in the front, the other methyl in the back, right? Now this has, bacha, this can make a enantiomer out of it. Can you see here? One enantiomer, here is the second enantiomer. Isn't it? Isn't it? Can you see now I've made a pair of enantiomers, right? So this is showing 2 number of isomers. So total now how many isomers are there? 2 plus 1 is equals to 3, right? Now let us form another kind of isomer of same compound, right? So this 3 is okay with you guys. Now I'm rubbing this, okay? Now I am rubbing this thing because this is not showing any stereoisomer, so I don't require this in my life. I'm rubbing you from my life now. So the next thing will be, bacha, next thing, what can be the other kind of isomer? The other kind of cyclopentane dimethyl can look like this, isn't it? This is also dimethyl cyclopentane isomer. What can be the next case? Next case, again, this can show stereoisomers, like one can happen, both the CH3 are on the front side, or both the CH3 are on the back side, right? So this is again considered as identical isomers. Hence the total number of isomer this gives is again 1, right? These are not enantiomers. These are once again identical pairs. So these will be considered as just one stereoisomer. Once again, what can happen? What can happen? Here the CH3 is at the back, here the CH3s are the front, one kind of isomer. The other can be once again, here the CH3 is at the front, here the CH3 is the back. So this is once again giving me a pair of enantiomer. That is a mirror image of each other. Hence, this will be considered as again 2 stereoisomers. So can you count? 2 plus 1, 3, and here was also 2 plus 1, 3. Hence, total stereoisomers possible is, total stereoisomers possible is number 6. Understood this thing, everybody? So the identical ones will be considered as just one stereoisomer, and if it's forming enantiomers pair, they will be considered as 2 stereoisomers. Is this thing clear to everybody? Is this thing clear? The answer is 6. Very, very good. I'm moving forward. So this is the solution given here. Next question on your screen, again from isomerism, right? Very important question. The total number of structures or compounds having or possesses asymmetric carbon atoms are. So you have to tell me, asymmetric means what? Where are the chiral carbons present? Out of these molecules, how many molecules have chiral centers in them? That is the question. Try to answer this. Try to answer this. Tell me the number, ma'am. Only 1, only 2, only 3. Tell me the number. What should be the number of the compounds? How many compounds here have chiral centers in them? Tell me the number. 4, I have received answer by Harshit as 4. Sai Sirisha is giving me answer as 2. Madhu has given me the correct answer is 3. And Sudha has given me 5. Madhu is 3. Akshit 3. Very good. Madhu and Akshit are extremely right in this case. Now let's see. Now let's look at each of the carbons over here. Can you see this compound? This carbon over here is chiral. Chiral means what? That a carbon can form maximum 4 bonds. So first of all, the carbon for a compound to be chiral. For a compound to be chiral, first of all, it should be sp3 hybridized, which means it should have 4 atoms attached to it, and all the 4 atoms must be different from each other, right? So that is the chiral carbon. So here, this one is the chiral carbon, isn't it? Okay. Similarly, let's look at this carbon over here. Is any carbon here a chiral? No, I do not see any chiral carbon in this structure. Right. Now let us look at this compound. Here once again, can you see this carbon over here is attached to 1, 2, 3 and the other is hydrogen. So this is again becoming a chiral carbon, isn't it? All the 4 atoms attached are different. This is once again a chiral carbon. Now let us look over here. Here all the carbons are sp2 hybridized, hence cannot show the chirality nature. Now let's look at the compound over here. How many chiral centers does it have? Can you see this carbon over here? This carbon has 1 atom, 2 atom, 3 and 4th is the hydrogen. 1 chiral carbon. Next chiral carbon is over here, isn't it? 1, 2, 3 and next is the hydrogen. All the 4 groups attached are different. So here only 3 compounds are showing chirality or asymmetric carbon, which is first, third and your last, right? Only these 3 are showing, rest are not showing chiral centers. Is this thing clear to everybody? Is this thing clear to everybody? Yes, 1, 3, 5. 1, 3, 5. Yes, correct. Chalo, this is the solution. Now let's move on to the next question. This is my favorite question. I've discussed it before also in some lecture. I don't remember. Okay? Now try to answer this. Statement 1. What do you learn from this question? That RS nomenclature will definitely come in your exam. This is based on the RS nomenclature which I taught you yesterday. Right? If you haven't watched that video, please go watch it. Statement 1. The compound, this is optically active. Try to answer this question for me. Is this compound optically active? What is the criteria for optical activity? Number first, that the carbon should have a chiral center, and number second, there should be no symmetry present, isn't it? This is the criteria for your optical activity. Try to answer whether statement 1 is true or false, and statement 2 is this compound is the mirror image of compound A. Mirror image means what? Enantiomer, which means if the above compound is, for example, R, then the below compound should have the S nomenclature, right? Then only they are enantiomers of each other, right? Right? 1 correct, 2 wrong. Very good, Sudha. Very, very good, Sudha. Sudha and Madhu. Madhu is also very right. Very good. So, bacha, here what will happen? Let us look at this compound once again. Okay, here can you see this carbon over here is optically active. Why? Because all the groups attached are different. Now you'll argue, ma'am, this group and this group looks the same to me. How are you saying they are different? Beta, bacha, can you see? They are different. They are different because, 1 second, they are different. I will take green pen. Okay? They are different because can you see here the attachment is trans. Can you see trans means what? Trans means that the 2 groups are attached at the trans position. So this attachment is trans over here, right? And here can you see both the methyl groups around the double bond are at the same position. Around the double bond they are at the same position. Hence this is the cis form. Cis form, right? And cis and trans, when the same compound is present as different geometrical isomer like cis and trans, then they will be considered as different entities, right? So this is definitely a chiral carbon. Now how will you see if it is a R configuration or S configuration? So what is the first criteria? Then you have to first, number 1, start giving it priorities. The number first priority is given to that atom which has the most atomic number or the atomic weight. So here nitrogen has the most atomic number, so this will get carbon priority number 1. Then between these two, and we know hydrogen has the least atomic number, so it always gets the last priority, which is 4th. Okay? Now between cis and trans, bacha, the cis gets the higher priority. Always understand this. Cis isomer gets more priority over trans isomer when we are doing the RS nomenclature. So here this will get more priority. This is the compound number 2 and this will become the priority number 3. Now what you have to do? Now you have to do nothing. You just have to move your pen from 1 to 2, right? From 1, this is 1. And I have to move my pen from 1 to 2 and I'm seeing what? From 1, 2, 3 and I'm seeing that the direction that it is moving is actually A anti-clockwise or a clockwise direction? This is the anti-clockwise direction, right? So this gets the S configuration. Understood this thing? Now let us check the other molecule. So the first statement is true, that this is a optically active molecule, true, and we've also determined that this is a S configuration. Now let us see the configuration. Is this a mirror image of compound A? For it to be a mirror image, this should have the R configuration. Let us check its configuration. Once again, this is the trans isomer. This is the trans over here, and this is the cis isomer over here. Okay, don't get confused. In cis, what is happening? Along the double bond, both the alkyl groups are at the same position, where here the two alkyl groups are trans to each other along the double bond. Look at it very, very closely. Now what is happening? Give the priority number. Number 1, number 4. Cis will get higher priority to number 2 and number 3. Understood? Now let us start moving the arrow. The arrow moves from 1 to 2 to 3. Now once again, the direction remains S only. Right? Now the direction is once again S. Right? Anti-clockwise, which means configuration is S. Hence, is this a mirror image of compound A? No. So this is a false statement, while that one was a true statement, because both are coming as S. They are identical. They are identical isomers, not enantiomers, not mirror images of each other. Understood this thing? Both are coming out as S. Okay? Understood? Now let's move on to the next question. Again, the another kind of type number 5 is rotamers or conformational isomers. One question will definitely be there from this part, right? These are extremely easy part of the questions, right? These are called rotamers. One question will definitely be there. Arrange the following conformational isomers of normal butane in order of their increasing potential energy. Okay? Potential energy means what? More the energy, which means less stable will be the compound, isn't it? More energy means less stability. Less stability. Okay? So you have to arrange these compounds in such a manner. Let us look at this thing. Can you see compound number A? Both the methyl groups are at 180-degree angle to each other, which means this is the most stable compound. This is the most staggered. This is the anti-conformation, the most stable staggered conformation. So first is the highest stable compound. Now let's compare the other compounds. Can you see now this compound number 3? The compound number 3 over here, the CH3 groups are 60 degrees apart. Right? 60 degrees apart, which means this is once again the staggered conformation. This is a staggered conformation. Right? So here, then third will come in the process of stability I'm talking about, not energy. This is the order for stability. Now next, can you see over here? The CH3 and the H over here are just right behind each other, which means the angle between them is 0 degree around, which means this is the eclipsed position, right? This is the eclipsed position. Then comes the fourth in number of stability, and second is the least stable. Why? Because 2CH3, two big molecules are right behind each other, causing so much steric hindrance. Hence comes the second option over here. So 1, 3, 4, 2 should be the stability order. Stability order. So what should be the energy order? It would be reverse. This is how they are stable. So therefore, second will have the highest energy, then fourth, then third, and then first will have the lowest energy. So this is the energy order. Understood this thing? Energy and stability are inversely proportional to each other. Yes. ठीक है? Shall I move forward? The next is hyperconjugation. Again, so many questions each year are asked from this topic. Try to answer this. Hyperconjugation involves overlap of the following orbitals. Who can answer this question for me? I'm looking at the chat box. Once again, Madhu has answered B, and Pentakota has answered B. Madhu B, Very good. Vemi Shetty, hi bachcha. B. Whoever has answered B is extremely correct. ठीक है? This is the only kind of effect where there is a relation, where there is a sigma and pi overlap, right? So in hyperconjugation, I've also told you in one of the shots that you need to go to the basic definitions for all these effects, which is what kind of overlap is there in inductive effect, in hyperconjugation effect, in your resonance effect, right? All these are very important questions asked every year. From these basics are asked every year in your JEE exam. So please go through the basics. Number 7th type is resonance. Again, a very important type. Try to answer this. Which of the following compounds does not exhibit resonance? Which of these will not exhibit resonance? Try to answer. I'm again looking at the chat box. Try to answer. First answer received by Sudha A. Raj Mohan has answered D. And Kasa Blair has answered D. Sai Krishna has answered D. So whoever has answered D is extremely right. ठीक है? So what is the condition for resonance, bachcha? Can you see the option number A? In option number A, what is happening? To the carbon where the double bond is present, right next to that carbon there is an atom with a lone pair of electrons. So whenever it happens, like for example, the carbon to which the double bond is present and right next to that there is an atom with a lone pair of electron, they will definitely show bachcha resonance. So resonance is definitely present in number A option. Let us look at number 2 option. The same thing is there in number 2. Can you see? To the carbon which has the double bond, right? Right next to that carbon, the oxygen is present. So this will again show resonance here. So again in this also, resonance is definitely present. Now look at this option over here. Now can you see over here? This is the CONH2 group. CONH2 group, which means what? It looks like this. CONH2, where nitrogen has lone pair of electrons, right? Now here once again, to the carbon where the double bond is present, right next to that carbon, lone pairs are there. Hence this will definitely undergo resonance. So it is also present over here. But here such a case is absent, right? The lone pairs are very far apart from the double bond. The double bond is here, the lone pairs are here, hence they are not able to show resonance. So the condition for resonance is to the carbon where the double bond is present, right next to that carbon, there should be the presence of either lone pair of electrons or positive charge or a free radical or a negative charge, right? These are the 4 criteria. ठीक है? Right next to the double bond, either of these 4 things are present, then they will definitely show resonance and become stable structures. Understood? Okay, I'm moving on to the next question. Next question on your screen, you have to tell me the stability order. The correct stability order of the following resonance structures is 4 things are given to you. Tell me the trend, like 1, 2, 3, 4, 4, 3, 2, 1. What should be the stability trend? Try to answer this question. Again, very important type of questions asked every year in your exam, JEE exam. Try to answer this. I'm looking at the chat box once again. Very easy question once again. 4, 1, 2, 3, 1, 3, 2, 4. Okay, 2 kind of answers I've received. 2, 1, 3, 4. Okay, 3 kinds of answer by 3 different people. Chalo, let us answer this question. Let us try to answer this question. So, bacha, here can you see that there is, okay, I will tell you how to answer this. First of all, to check the resonating structure stability, first thing that you have to check is neutral compounds are more stable. Neutral compounds are more stable. Understand this thing. Which means if the compound has a positive or a negative charge, it will automatically be less stable than a neutral compound. Neutral compounds, more stable. Then comes your charged compound. So in charged compounds, there are so many criteria to look at. First criteria which is available in this option is you have to count the number of covalent bonds. ठीक है? Count the number of number of covalent bonds. Covalent bonds. More the number of covalent bonds, more stable will be the structure. Let us count the number of covalent bonds. Can you see in option number 1, around the nitrogen there are 4 covalent bonds, isn't it? 4 covalent bonds. Similarly here there are just 3 covalent bonds. 1, 2, 3, right? Around this central nitrogen I'm counting. That is it. Here also 4 covalent bonds. Here also 3 covalent bonds, right? So more stable structures with either be the 1 or the 3. So between these two, now I have to decide which is more stable, because first of all I counted the number of covalent bonds. Both of them have more covalent bonds, hence these will be more stable than these two. Okay, I just know that. Now I have to consider between these two which one is more stable, right? So here, bacha, which one will be more stable? Can you see here the negative charge is on the more electronegative nitrogen, while here the negative charge is on the less electronegative carbon. So the negative charge will be more stable on in the first position, isn't it? Because the positive charge is same on both the atoms. So here first will be more stable because the negative charge is on more electronegative nitrogen. Okay? Then will come your third option will be lesser stable than that. Now I have to compare between 2 and 4 because both have the same number of covalent bonds, right? Here what will be the case? Here can you see, bacha? Here once again on this nitrogen there is a negative charge, right? Whether here the negative charge is on carbon. So here once again negative charge will be more stable on more electronegative atom, which is the nitrogen over here. So here then comes the second number and then at last fourth. So whoever gave this order is absolutely right. First will be the most stable, then third, then 2 and then 4. Did you understand the concept? Does everyone understood the concept? 1, 3, 2, 4. Yes. Everybody understood this beautiful concept, right? See, again, next question. Okay, this is a solution for that. Next question is here. Which of the following resonating structures of 1-methoxy-1,3-butadiene is least stable? Try to answer this question for me. Which is the least stable they have asked, right? Here, what is the first thing that you need to do? I just explained it to you that here another concept will be applied. The other concept that is applied is those structures are, bacha, more stable where the octet of every atom is complete. What? Octet is complete. Octet is complete, right? Octet of every atom must be complete. Then that automatically becomes the most stable resonating structure. Here what can happen? Look at, if I'm scanning the options over here, then I'm seeing that in the C option, can you see? In the C option, this carbon has some kind of incomplete octet. How many electrons this carbon has? 1 electron, 2 electron, 3, 4, right? 3, 4. This with this hydrogen it has 6 electrons, right? So in total it just has 6 electrons, right? Its octet is not complete. Hence this becomes the least stable resonating structure. You can check for the octet in all the other options. In all the other options, octet of every atom is complete. Check for this oxygen over here. The oxygen always has a lone pair of electrons. Remember that, right? Now count the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, octet complete, right? Similarly, count for this carbon over here. Here also its octet is complete, right? You can see for every option, scan for every option, but here just by looking at the option I could see that here this carbon looks 6 electron species, hence least stable resonating structures. So we have done on so many criteria the resonating structures stability depends, and you have to keep all those criteria in your mind, right? Understood? Another criteria is the octet should be complete. If the octet is not complete, automatically least stable resonating structure. Understood? Understood? Shall I move on to the next thing? Yes, Madhu is absolutely right. Next is the inductive effect. Again, most asked question. from the inductive effect. Which of the following acids has the smallest dissociation constant, right? How do you determine that? Which will have the smallest dissociation constant? What is meant by dissociation? To break, right? If it is a strong acid and I put it in water, it will break very easily. It will break so much with a large dissociation constant because it is a strong acid. Whereas the weak acid is something which has a smaller dissociation constant. That's why it's a weak acid, because it cannot dissociate in water. So smallest dissociation constant means weaker acid, weakest acid, right? That is what you have to look for. Which of these here is the weakest acid? Now tell me in the option below. Okay, I have received the answer. Raj, Mohan, Madhu, C. Mohita is D. Sudha is D. Okay. C and D have been receiving the answers. Now let us look at over here. So can you see how do we determine the acidity? I have told you n number of times when the H plus will leave in all of these cases. What will happen? Acidity means giving out the H plus ion. So what will be left behind? The negative charge. The anion, in this case the acetate ion, will be left behind, right? Now we have to look for the stability of this negative charge. Can you see here the fluorine is attached, right? Here the fluorine is attached and fluorine is a very, very good -I group, right? Because it is a very, very good what? Electronegative element. So it is taking away electrons due through -I effect, hence increasing the stability. So A is the most acidic compound. Now let us look at B over here. B, here again fluorine is attached over here, right? Okay, here let us look at C. Bromine is attached, and in D option the bromine is attached right next to this position, right? So as we know, bachcha, ki bromine has a lesser electronegative power, right? So hence here bromine is showing the least -I effect out of these two. Hence C option will be the correct option. It is the weakest acid, right? It is the weakest acid because it is not able to stabilize this negative charge. And also bachcha, I inductive effect depends on the distance also. It depends upon the distance. Here the distance with bromine is less, hence it is able to pull electrons more effectively. Here the distance with bromine and the negative charge is more, hence it is able to pull the electrons less effectively. Hence the correct answer is C. Whoever gave C as the answer is absolutely right. Yes, everybody is right who gave the C answer. Next is aromaticity. Very simple question. I want you to revise this concept. Aromatic compounds, definitely 110% will come in your exam. Answer this. Which of the following compounds is non-aromatic? Try to answer this. Which of these is non-aromatic? Very, very easy question. Very, very easy question. A. Very, very good. The correct answer is A. Why? Because here a sp3 hybridized carbon is there. So definitely a non-aromatic compound. Here this compound is what? This compound is 2 pi electron, hence aromatic, right? Here once again this is a anthracene compound. Once again this is 1, 2, 3, 4, 5, 6, 7. 7 is 14 pi electron. Once again aromatic compound. Here what kind of compound is this? This is once again a 6 pi electron system. This is once again a aromatic compound. Only that one is non-aromatic. Now answer this. Which will have the highest enol content? Try to answer this question for me. Which one will have the highest enol content? Right? Try to answer this question for me. Which will have the enol means what? Try to read the name en and all, which means a double bond. Right next to the double bond there is a OH group. This is called the enol compound. When right on the carbon which contains the double bond has a OH group, is called the enol compound. Right? Right? And bachcha, there is a kind of tautomerism which is shown by enol compound. For example, here the oxygen has what? Lone pair of electrons, right? What is the purpose of lone pair of electrons? It can go into resonance with this double bond, right? So when it shows resonance, what actually happens? it becomes a ketone compound. This electron gets converted into a double bond, right? And this carbon gets the hydrogen over here. This hydrogen comes over here. So this is showing the keto-enol tautomerism. Keto-enol tautomerism. Very, very important concept. What is happening? The lone pair on oxygen is getting converted into a double bond character. Hence, the enol form is getting converted into the keto form. Right? Right? So here, this kind of isomerism happens. So here, which one will show the highest enol content? Who can answer this question for me? I have received A, C, B, various answers for this. Let me try to make you understand. Let us try to convert A option into keto-enol. So in A option, what is given to you? Double bond O, 2 double bond O, which I will convert into OH and a double bond, right? The double bond O gets converted into the OH and it will also get a double bond, right? Similarly, here the keto group will get converted into the OH and a double bond, right? So this kind of structure I will get as a keto, as a enol form of this keto form, isn't it? This is the enol form of A. Now let us write the enol form of B. B, what can happen? B, again I'm writing it here. Again I'm writing it here. This keto will change into OH group and a double bond. Similarly, this will change into the OH group and a double bond, right? So this is once again your same kind of enol form of B. Now let us write the enol form of C. Now you will see the magic happening. Okay, here this double bond O gets converted into the OH and a double bond. Once again, this double bond O gets converted into the OH with a double bond. Similarly, this double bond O gets converted into a OH with a double bond. Understood? Now what is happening to this compound? Can all of you see that this is now getting converted into a 6 pi electron system, which means this is converting into the aromatic system, isn't it? Isn't it? This gets converted into the aromatic system, which means it is gaining stability. So when this keto form in the C option gets converted into the enol form, it is gaining the aromatic stability. So why would it not want to do that? I want to become more stable in my life, so I will not remain as a keto form. Instead, I will convert myself into the enol form, because that way I'm getting the stable aromatic character. Hence, the correct answer is C. C will show the highest enol content. It will remain in this kind of isomerism because due to that it is gaining extra aromatic stability. Understood this concept, everybody? Understood this concept, everybody? Yes. Now let us move on to the next question. This is my favorite question. That's why I have to keep on including this question, because this kind of questions are asked every year, right? Which among the following is the strongest acid? Once again, acid means what? Something which gives away H plus easily, right? Which will give away H plus easily when the anion that is left behind is more stable, right? Similarly, look at the C option over here. C option, if I take away H plus from here, what will be left behind? The anion. Okay? This anion will make this system a 4 pi electron system, which means this system becomes anti-aromatic. And we know that anti-aromatic system are the least stable system, or these are unstable system to say. So this will never be the strongest acid. Instead, look at the D compound. When H plus go away from here, what will happen? A negative charge will be left behind. Hence, this becomes 2 pi bonds plus lone pair of electron becomes 6 pi electron system, which means this becomes the aromatic system, which means it gains stability. Understand? This gains stability. Right? So as soon as I'm giving away my H plus, I'm becoming a very stable compound. Why would I not want to do that? I will readily give you H plus. Hence, I'm the most acidic compound because I'm very easily giving you H plus ions. Understood? So the correct answer is D. Right? Understood? Again, due to the aromatic character. So whenever the compounds can convert. So what did you learn from this? You have to take the learnings from here, just not do the questions. Learning is whenever the compound has the ability to convert into the aromatic structure, it will definitely do that, because after that it is gaining so much more stability. Understood? It will do everything. It will convert it into enol form. It will lose the H plus easily. It will do everything to convert into a aromatic compound. Okay? Next question on your screen. The correct, now we're talking about the stability of species. The correct stability order for the following species is, try to answer this. The correct stability order. Very good question, extremely beautiful question once again. Here what would be the stability order? What would be the stability order? Yes, now stability, you have to tell me the order, bacha. Like 1, 2, 3, 4, 4, 3, 2, 1. Don't write A. Okay, what will be the stability order? So here, can you see a positive charge is there on each carbon, right? And we will check each and every molecule over here. Can you see that this oxygen over here with a lone pair of electrons and the carbon next to that has a positive charge? You have to keep one thing in mind. Whenever such a system is present in front of you, what is that system? That there is a lone pair of electrons and right next to that there is a positive charge. Then that system is extremely stable due to resonance. So this will be the most stable species. Understood? Lone pair of electrons and right next to that carbon there is a positive charge. Very, very stable species. I will show you so many examples based on this simple concept asked many times in your JEE exams. We are going to do that just now. So this you understood? So first will be the most stable, right? Now let's look at all the other options. Right? Here this species also looks the same. This is also the same, isn't it? This is also the lone pair are present over here and a positive charge is here. Once again, a very stable species. But can you see, this was actually a tertiary carbocation while this one is a secondary carbocation. So now which one is more stable? This is definitely more stable, and then the secondary carbocation is much more stable than that, right? So becomes, after first comes the third option. Now we have to choose between these two. This is very easy once again. This is a secondary carbocation while this is a primary carbocation. So obviously secondary carbocations are more stable, and we have learned that through so many things, which is the hyperconjugation effect or the plus I effect, right? Inductive effect. Due to both of these effects, secondary carbocations will always be more stable than second and then your fourth. So this is the final answer. Understood this thing? This is the final answer. 1, 3, 2, 4. So whoever answered this extremely right. Understood this part? Now moving to the next question. We have already done that. Next question is this. Arrange the following carbocations in decreasing order. See, once again, based on the same concept, the question is asked in your JEE 2022. So same concepts keeps on repeating, whether in such questions or even when they are giving you reagents in example, right? I will also show you that. Even when you are doing the, even when you're making the carbocations, and if you have to choose which carbocation is more stable, then once again you have to look for what? For example, here, this oxygen with a lone pair of electrons and a positive charge is right next to it. What did I tell you? When such a species is present, due to resonance, this will be the most stable species. That's what is asked, right? So the B will be the most stable species, right? Now we have to compare between A and C. Right? Now between A and C, what will happen? Here can you see oxygen? Now we will talk about other effects of oxygen. This thing you kept in mind, right? Whenever a positive charge is right next to the lone pair, maximum stability given without any thinking. Next one between these two. Now here oxygen will behave as a minus I effect. Okay, oxygen is more electronegative compound. Therefore, it has a tendency to pull electrons towards itself. So I am already positive and you're taking away electrons from me. Then you're making me much more unstable. So C will be the least stable, right? So then comes the A species. So this is the order BAC. BAC, which is the option number A. Right? Understood? A is definitely more stable. Then your C is the least stable because oxygen here will behave as a minus I effect, right? And then becomes the A. Understood? Now moving to the next question here. Now you will answer this question for me. The correct stability order of the following diazonium salt is. So you've been given a diazonium salt. Try to answer this question for me. Try to answer this question for me. Yes, diazonium salt. What is the property of diazonium salt over here? Can you see this nitrogen here gets a positive charge, gets a positive charge, gets a positive charge, gets a positive charge. Okay? So the atom directly attached to the benzene ring has a positive charge on it. Now you have to focus on stabilizing this positive charge, right? So what will be the stability order? So here OCH3 at the para position will show the resonance effect, isn't it? So this is showing you plus R effect. Therefore, increasing the stability of positive charge, isn't it? So A will be the most stable species. Why? Because nitrogen over here has a positive charge. I need to stabilize it. So I need to give it electrons. OCH3 gives the maximum electrons, right? Now here NO2 as well as CN both are electron withdrawing groups. Electron withdrawing group, electron withdrawing group. So I'm already positive and you're taking away more electrons from me. You're making me unstable, right? And if you have to compare the ability between NO2 and CN, which is the better electron withdrawing group, then it is the NO2 group, right? So these are electron withdrawing, hence A will be more stable than your C, then your D, and then your B. This is the order because nitro group has the highest capacity to pull electrons. Therefore, this will be the least stable species, then D, then C, then A. Understood this thing? Everybody understood? This is the order ACDB. Whoever's answer ACDB is absolutely right. I'm moving on to the next question. Arrange in order of increasing acidic strength. Who can answer this question for me? Arrange in order of increasing acidic strength, right? So now once again, look at this question. So you have three kind of protons, X, Y and Z. So as I told you last night, right? Last night I was there with you. I was teaching you. Here I told you this is a carboxylic acid. What is the function of acid? To easily give away H+. So obviously, here the H+ will be taken out most easily because this is the acidic functional group, right? So here X will be the most acidic. Now we have to compare between Z and Y. So here can you see I'm again making the molecule over here. The molecule looks like this. This is NH3 plus. Here is the C. Okay, here is a C double bond O, OH group present, right? This is the molecule given, right? Right? So, bacha, what is happening over here? Can you see this is once again a electron withdrawing group. Any multiple bond you see is an electron withdrawing group. Just that you have to keep in mind. It is withdrawing the electrons. Now, if I take H plus from here, what will be left behind? A negative charge. After taking away H plus from here, a negative charge will be. So, I need to stabilize this negative charge. So, right next to that negative charge is the electron withdrawing group. I'm already negative and you're withdrawing electrons from me. Hence, you're making me more stable. Isn't it? So, next will be the Z and next will be your Y. Okay? Because here the negative charge is stabilized by the electron withdrawing groups. I'm negative, you're taking away electrons, you're making me stable. So the correct hai X, Z, Y, that is the sequence. X will be the more acidic, then Z, then Y. Why? Because acidity depends upon the stability of the anion form. So this is more stable anion than that one. Understood this thing? Everybody understood this concept? Okay? I'm moving on to the next question. Assertion reason, very easy question once again. Order of acidic nature of the following compounds is A is more than B is more than C. Is this a true statement or a false statement? Tell me that first of all. So A, B and C are given to you, right? Here all are phenols, alcohols, right? And to the alcohols, what is attached? Chlorine, which shows minus I effect. Fluorine, minus I effect. Here CH3 shows plus I effect, which means it is increasing the electron density. And acidic nature means what? When the H plus goes away from here, then we have to look for the stability of the anion form. So where is the anion most stable? That will be the order of acidic nature. So can you see here, C option will be the least stable because CH3 is giving electrons to a already negative species. So we are making it unstable. So C is the least stable molecule, right? Right. Next comes, which one will be the most stable? Can you see chlorine over here? So bacha, this inductive effect, keep it in mind. Inductive effect is a distance dependent effect. So as the distance is increasing, inductive effect decreases, right? So can you see chlorine is very near to the oxygen over here. So this will have a more electron withdrawing effect, even though fluorine has a higher electron negativity on it, right? If we compare the minus I effect trend, then what happens? The minus I effect trend is fluorine shows the highest minus I effect, then chlorine, then bromine, and then iodine. This is the order followed. But inductive effect also depends upon the distance. So because it depends upon the distance, what is happening? This anion will be more stable. So here your A will be the more stable, then your B, and then your C. Understood this thing? Even though fluorine is what, bacha? Even though fluorine is more electronegative compound, it has more ability to show higher inductive effect, but because inductive effect is dependent on distance, so as the distance increases, its ability to pull away electrons decreases. Hence, this is the acidity order followed. So this is a extremely true statement. Now let us look at the reason. Fluoro is a stronger electron withdrawing group than chloro group. This is also a true statement. I just told you. Fluorine is a more powerful electron withdrawing group than the chlorine group, right? So both statements are true. But is the reason correct explanation of the assertion? No. The reason is not correct explanation. Why is that the case? Why is that the case? Because the correct explanation is that inductive effect is distance dependent, and that is why your chlorophenol or the chlorocyclohexanol is more acidic than your parafluorocyclohexanol. Understood this thing? Okay? The correct explanation, it is not the correct explanation. Okay? Understood? I'm moving on to the next question. Number of electrophilic centers in the given compound is. Electrophilic centers, you have to tell me. Centers means what? Electrophiles are what? First of all, tell me that. Electrophilic centers are what? Which have a delta positive charge on them. Isn't it? They are called electrophiles because they are electron loving. A positive charge is electron loving, isn't it? So wherever the positive charge is more, then it would be a electrophilic center. Right? Now tell me, how many electrophilic centers do you see? Now let us see this compound over here, the carbonyl group. So we know the oxygen has a more delta negative charge, isn't it? It has a more delta negative charge, which means this carbon automatically gets a delta positive charge, and because it is positive species, it is a very good electrophile. Okay? It is electrophilic, means electron loving. Okay? So this is a very good electrophilic center. This is the electrophilic center. Electrophilic centers are positive. Keep that in mind. Make a note of it. So first electrophilic center is this. Next electrophilic centers, can you see a CN molecule here? CN molecule looks like this. C triple bond N. Here nitrogen is more electronegative than carbon. So nitrogen gets a delta negative charge. Then obviously carbon gets a delta positive charge because dipoles exit together. A positive and negative will always be together. So therefore, once again, this is the second positive charge, second electrophilic center. Now let's look at the third electrophilic center. Can you see this double bond over here? Okay? This double bond over here can again undergo resonance with this structure, isn't it? Okay? This double bond can undergo resonance with this structure, and when it is doing that, it is creating a delta positive charge on this carbon, isn't it? due to the resonance. So here once again, this is the third electrophilic center. So everybody understood? So this has 3 electrophilic centers. This is your JEE Main 2022 questions. So you have to focus on the wordings. Electrophilic center, which means I should be positive in order to be a electrophilic, electron loving center. Okay? Understood this thing, everybody? 3. The correct answer is 3, bachcha. The correct answer is 3. Everybody understood? Understood. I'm moving forward. Okay? Okay, next is the product. Now we are back to another kind. This is a very important kind. See, nobody will teach you this, but certain kind of questions are very, very common in your JEE exams. Number first kind is the 1-4 addition based questions, right? So can you see the major product formed in the following reaction is? So you've been given a 1,3-butadiene, like a version of 1,3-butadiene, right? And you're reacting it with HBr. So what would be the major product, right? How to approach these questions? So I am once again telling you, keep this in your head, very, very fixed in your head. See, whenever such a alkene is given to you, the alkene is a 1,3-butadiene or its variation. There's just a methyl group attached to it, right? So I will attach the methyl group. But the basically, mota baat is, it is 1,3-butadiene. In such a structure, what will happen? What kind of additions happen? That addition is called 1,4. Okay, what is that? I will explain to you. So you understood this alkene? Now I'm adding HBr. So what is the function of HBr? This gets broken into H plus and Br minus ion, right? So H plus will do what? H plus will attack this carbon over here, or this, sorry. 1 second. 1 second. Yeah, the attack always happens from the alkene to the H plus. Do not draw wrong arrows. Okay, I drew the wrong arrow, that's why I rubbed it. The right arrow is the alkene attacks. The electron rich alkene attacks the positive over here. Okay, now what will happen? After the alkene attacks, what will happen? This is a structure 1, 2, 3. Here is that. So hydrogen will get attached on this carbon, right? Because it is forming a positive, a tertiary carbocation over here. So that will definitely be formed, right? And here will come another double bond. Is this thing clear to everybody? Now, bacha, what can happen? Now this double bond can go over here through resonance, isn't it? So now resonance of this double bond happens, and what will happen? 1, 2, 3, right? And the double bond comes over here, the carbon was over here. So the positive charge comes on the primary carbon over here. This becomes a primary carbocation. Now, bacha, understand one thing. Whenever such a reaction is happening under normal temperature or high temperature, okay? Normal or high, which means what? Either room temperature or high temperature, then 1,4 product will be formed. Now if I attack the bromine minus, then this product will be formed. 1, 2, 3. Here is the negative charge, here's the bromine. So what happened? The hydrogen got attached over here, the bromine got attached over here. This is the 1, 2, 3, 4. So that's why it's called 1,4 product, right? So at higher temperatures or at room temperature, whenever such a 1,3-butadiene is given to you or any version of it, you have to make a 1,4 product. You don't have to show me all these steps. I just explained it to you. In your head, you know, just look for the option. What is the 1,4 product? That is the correct option, right? Understood this thing? Understood this thing? Okay? And once again, when the temperature is very low, like the temperature is minus 80 degrees Celsius. If the temperature is this low, then you will make the 1,2 product. 1,2 product means what? Then somewhere here the bromine will attach and here the H was there, right? So this product will form only when the temperature is really low. Okay? This is called the difference between the kinetic and the thermodynamic product. So here, because no temperature is given to you, which means it is happening at the normal temperature. So therefore the answer will be the 1,4 product, which is the option number A. So option number A is the correct answer. Everybody understood this? Everybody understood this, right? Okay? Beta, if temperature is not given, na, then you have to consider it room temperature. I just told you. Even at normal temperature, you will do 1,4 addition in this 1,3-butadiene of compounds. Okay, always mark this in your head. Okay, 1,4, 1,2 additions are very, very common. Okay, I am moving on to the next question. Next is this. The major product for the following reaction is. So yesterday we approached this question in a different way, but actually this question has to be approached in a very different manner. I will teach you how. So here what is happening, bacha? Can you see the compound given to you is double bond C and here is the C triple bond N, right? This is the compound given to you. Now you have to decide between the double bond and the triple bond characteristics. So understand one more thing, that double bonds are much more reactive than triple bonds. Understand this thing. Okay? Double bonds, write it in your notebook. Double bonds are more reactive than triple bonds. Okay? Now what will happen? Once again, the same thing which I taught you yesterday. Here is the OH is there. Okay? Here is the 1, 2, 3. SH is there. Right? Both of them have lone pair of electrons. Right? Both of them have lone pair of electrons. Now, where will this lone pair of electrons actually attack? So, what can happen over here? This double bond can go into resonance with this structure, isn't it? Okay? If it is going into resonance, what it can form? It can form a double bond here, a positive charge over here, a C here, right? Double bond N, and here is this kind of structure is formed. Now, what will happen? Because sulfur is less electronegative atom. Between oxygen and sulfur, we have to select which will donate electrons, right? Which will donate electrons in this case. Can you see once again, this is kind of forming the 1,2-butadiene system. This is once again a similar system like this. One double bond is here and one triple bond is here. This is once again the similar kind of system we saw a B, right? Butadiene system. So here once again what happens? This kind of movement will happen definitely, which happened in the last question as well. So can you see such questions are very, very common. Need understand how to approach them. Only how can you understand? Only after you draw it in your notebook. Whenever you see organic question in your exam, try to draw it with hand on the paper. Do not do the calculations in your head. You will be wrong, entirely wrong. Until and unless you draw and you see the picture in front of you, your answer will definitely be wrong. Okay? There are so much chances of you getting it wrong. Okay? Understood? Now, bacha, what will happen? Now, because sulfur is less electronegative than oxygen, which means oxygen will hold electrons very dearly to itself, while sulfur will easily give away electrons. So, what will happen? The sulfur electrons now attack this positive over here. Okay? So now I can form S. Here is the 1, 2, 1, 1, 2 and 3 OH, right? Here is the SH and here is the once again 1, 2, double bond C, triple bond N. Double bond N and here dot, right? Okay? Now, bacha, what will happen? What can happen once again? The double bonds can transfer once again. What can happen? This hydrogen can go over here and once again what can happen? The final structure would be this double bond goes over here. Oh, sorry. Try to move the arrows like this. Okay, what will happen? This electron pair again moves over here. This again moves over here. So when it moves over here, this hydrogen actually leaves. Okay? So this is becoming the lone pair of electrons on S actually. So the correct answer is 1, 2, 3 OH and here become 1, 2, 3 and here's the CN compound. So this is the final answer, which is your B option. Everybody understood the B option? B option. Okay? Understood everybody? Now I'm moving on to the next question, which is this. Product X formed in the above reaction is. Product X formed in the above reaction is. Try to answer this question for me. Yes, again a very, very easy question. Very, very easy. Then we will call Nabamita ma'am. Nabamita ma'am we will call. ठीक है? Product X. What is happening over here? First reagent is NaI in the presence of H3PO4. Can you see here in the presence of acid what will happen? You have a alcohol with you. CH3, CH2, CH, and here is the CH3. In the presence of acid, what will happen? It will give away H plus, right? And this H plus will be attacked by the lone pair of electrons on this oxygen. So this OH2 will leave, leaving behind a positive charge on here. Now what will happen? Through this NaI, I minus will be given out. This I minus will now attack here. So the product formed will be CH3, CH2, CHI, and here is the CH3, right? Next is Mg diether, which means we are forming a Grignard reagent now. So what will happen after Mg diether? Here nothing, MgI will be formed. What will be formed? MgI. That is it. So here I formed a Grignard reagent. Next is D2O. In the presence of D2O, that is a deuterium water. What will happen? This will leave, and hence the final product that you're going to get is a normal alkane. CH3, CH2, CH2, CH3. So a normal alkane, but here D will be attached because you are using deuterium water. So D will come over here. So the correct answer is C. Okay? Water in the presence of Grignard reagent, what happens? Any molecule which can give away H plus easily gives away H plus due to the very, very reactive Grignard reagent. So Grignard reagent abstracts proton from the water. Understood this thing? Correct answer is C. Yes. Yes. Next question. Arrange the following compounds in increasing order of rate of aromatic electrophilic substitution reaction. Try to answer this question for me. Arrange the following compounds in increasing order of rate of electrophilic aromatic substitution. Very important kind of question once again. So what are electrophilic substitution? Who will show electrophilic? Electrophile means something which is electron loving. Electrophilic substitution, for example, which shows electrophilic aromatic substitution? Benzene rings, right? Benzene ring shows electrophilic aromatic substitution. Why? Because these are electron rich. So electron rich species show electrophilic aromatic substitution reaction. So which means what? More electron rich the benzene ring is, more EAS reactions it will show. So this benzene ring needs to be more electron rich. Now let us look at our options over here. First of all, let us look at D over here. In D, what is happening? This oxygen is increasing the electron density in this ring, isn't it? So this is increasing electron density, making the aromatic ring electron rich. Similarly, the oxygen over here, this is directly attached to the double bond. Hence, this will also show its plus R character. Plus R, this is also showing plus R, right? So this D will be, this benzene ring will be the most electron rich. Hence, it will show the maximum EAS reactions. So the first option is D. D will show the maximum. Now let us look at the option number B. Here once again, B, what is happening? This is once again taking part in resonance plus R. So the next is B. B is doing what? Again, increasing electrons in the benzene ring, and we want that. We want the benzene ring to be electron rich in order to show EAS reactions. Okay? Next is B. Next, can you see here also OH is there, right? Here, so here somewhat what is happening? Somewhat this OH will help in your EAS reactions in electron donation species. Then will come your A option. Then at the last, because this is a electron withdrawing group straight away electron withdrawing group, right? So this is decreasing electron density in the ring. Hence at last will be C. So this is the final order. DBAC is the final order. Everybody understood? Everybody understood? Yes, DBAC. I'm moving on to the next question here. So can I give you this as your homework question? ठीक है? ठीक है? Or do you want to do more? or do you want to do more organic? If you want to do more organic, we can do it today. Chalo. Next is, try to answer this question. Again, a very easy question. Try to answer this question right here, right now. I'm not giving us homework. You do it right now. Do it right now, bacha. More. Okay, we're doing more. Definitely doing more. Okay, tell me the answer to this question. First reagent is zinc amalgam in HCl. What is the name of this reagent? What kind of reduction is this? What is zinc amalgam and HCl called? Zinc amalgam and HCl called. Yes, bacha, we're doing more. For sure, we're doing more. Yes, bacha, we are doing, obviously. So I've already received the feedback. Do more organic. Doing more organic for you people. Chalo. ठीक है, Clemmensen reduction. I've already received the answer. Very good. Very good. Try to solve this question for me. Clemmensen reduction. What will happen in the first step? Clemmensen reduction reduces your carbonyl group, isn't it? It will reduce this carbonyl group into CH2 group. 1, 2, 3, 4, 5. Sorry. 1. ठीक है. Here is your double bond O, which get after zinc amalgam and HCl, what will happen? This will get converted into CH2 group, isn't it? This will get converted into CH2 group, right? Next is CrO3. What kind of reagent is that? What kind of reaction does it show? It shows aromatization reactions. Remember such reagents. Reagents for aromatization, reagent for isomerization, which happens with AlCl3. Understand these things, okay? All these reagents you have to keep in mind. This is a very good reagent for aromatization. Now what will happen? Can you count the number of carbons? It is a 1, 2, 3, 4, 5, 6. 6 carbon chain. 6 carbon chain can convert it into a benzene. So I've converted into a benzene, and this methyl group will attach as it is over here. So this is the final product, which seems to me the A option. Correct? So first of all, I did Clemmensen reduction with zinc amalgam, and then what I did with Cr2O3, I did aromatization reaction. Understood this thing, everybody? Yes. Next is again a very easy question. It will be asked, it has been asked in every JEE Mains question. Very favorite reagent of your examiner. You have been given 2 alkenes and you are trying to oxidize first with KMnO4 with heat. KMnO4 when it is hot, heated. Can you see delta is for heat? Next, KMnO4 you have taken at room temperature or at the cold species. So with these 2 different things, what 2 different kind of oxidized products will you get? Try to answer this. I'm looking at the chat box. I am looking at the chat box. Such questions are again very popular. Have been asked, I don't know, 3, 4, 5 times in your JEE exams. ठीक है? Answer, Madhu has given me answer C. Compound A is a diol and compound B is a dicarboxylic acid. Okay, try to see. Very good, Madhu. So here in A, when we are heating it, which means it is a very strong. Heated means what? That the reactivity has increased 10 times. Heating does that to the reactivity. Reactivity increases. So in A product, what will be the product? This double bond will break from here, and the final product that you're going to get will look like this. 1, 2, 3, 4, and here the carboxylic acid will be formed. Here once again carboxylic acid will be formed. So it is what? It is a dicarboxylic acid that you're getting as the A product. A is a dicarboxylic acid. Now look at B product, bachcha. B product. ठीक है? Beta, answer is D. In B, bachcha, what will happen at normal temperature? It will get converted into a diol product. Diol product. ठीक है? This will get converted into a diol product. Yes. ठीक है? Understood? Diol product. Here what will happen? This double bond gets converted into the diol product. ठीक है? With the cold, what is happening? Converted into a diol product, and with the hot, it is converting into a acidic product. So the answer is D, not C. ठीक है? Compound A is dicarboxylic acid. Compound B is a diol. ठीक है? Now next question on your screen. See, once again, this might look a difficult question, but I will tell you with two examples how this reagent, which is AlCl3, is very favorite of your examiner. They have asked this reagent so many times. So I will teach you how to approach AlCl3 as a reagent. First of all, understand what is AlCl3. AlCl3 is a Lewis acid. Okay? They have given you two compounds here. Okay? AlCl3, two equivalents of that. What is the significance of two? I will also let you know that. We have to look at everything that is given in the question. Okay? It is not a difficult question, not at all. So first of all, what will happen? The oxygen over here has lone pair of electrons, right? So what can happen, bacha? This oxygen can undergo resonance like this, and this can go over like this. And what will happen in such a case? This bond will break. Okay? If this bond breaks, which means what? The electrons are going to this oxygen, right? So what is happening in the case number 1? I have formed a product like this. This is the O with a negative charge over here, right? Here comes the double bond O, right? Here is the double bond O that was already present, and here I will get a positive charge. This carbon will get a positive charge. Is this thing clear to everybody? So here what has happened, due to resonance, this oxygen can give its lone pair here, and this will go over here. So here will come the double bond, this becomes a double bond, and that oxygen gets a single bond with a negative charge on it, right? And this carbon over here in turn will get a positive charge. Now you are trying to react it with AlCl3. AlCl3, which is a Lewis acid, which means it is deficient of electrons. It has less electrons in it. So therefore it is attracted to electrons. So these electrons will attract this AlCl3 species over here, because this is a Lewis acid. So next step, what will be? The next step is simple once again. Once again, what will happen? The AlCl3 will move over there. 1, 2, 3, 1, 2. Here is the positive charge. Here is the O, AlCl3. Okay, O minus AlCl3 plus. Here will come the double bond O. Is this thing clear to everybody? And you are reacting it with a benzene ring. You are reacting this with a benzene ring, right? And what is the nature of benzene ring? Benzene ring is electron rich species. It has so many pi bonds, right? So many double bonds are there, which means this is a electron rich species, right? Electron rich, which means what? It will attack this positive charge over here, isn't it? Because this is electron rich. But always remember, the aromatic benzene which is there can only and only show reaction in presence of some Lewis acid, that is AlCl3. That's why we have taken two equivalents. One equivalent joined over here. The other equivalent will now help in doing this electrophilic aromatic substitution reaction. So the final answer is to this benzene ring. Here the positive charge will attack with a double bond over here. So here 1, 2, 3, 1, 2, 3, and here is the O, AlCl3, and here is the double bond O, right? So this is the final product. This is the final product, right? So the first product form is this. First product is OH. So this AlCl3 can go away. Then you are reacting it with zinc amalgam and HCl. Okay? You are reacting it with, this is the first product, which is double bond O, OH. Here will come the AlCl3 will go away. This will convert into OH. Double bond O, OH, this, double bond O. So the A product is this one, right? This one is the A product. Could be A, could be C. Now next is zinc amalgam and HCl will do what? Zinc amalgam and HCl will convert this into normal, right? Zinc amalgam and HCl does Clemmensen reduction. So this keto group will be reduced by it. So the final answer that you're going to get is the C answer, right? The C answer. This will get reduced into CH2 group. CH2 group. The Clemmensen reduction is taking place. Is this thing clear with everybody? ठीक है? ठीक है, understood? The correct answer is C. Now I will show you another. Okay, we've already done this. Sorry. ठीक है. Now I'm showing you another way where anhydrous AlCl3 is used as a reagent. That question is clear to everybody. First, AlCl3 was used to attack the oxygen. Next, to conduct the electrophilic aromatic substitution reaction. Another to form the B product. It was the normal Clemmensen reduction. ठीक है, easy questions. Do not get very difficulty, but do not get afraid of it. Not difficult questions. Now again, anhydrous AlCl3. I'm showing you how popular this reagent is. JEE Main 2023. Again, questions from anhydrous AlCl3. So you need to know how to conduct reactions. Again, what is the purpose of AlCl3? It is a Lewis acid. So therefore, it will abstract this chlorine from here. This Cl minus, it will abstract from here. So what will be formed? A positive charge will be formed on this carbon, isn't it? Now let us count the number of carbon here. I will form this product here. 1, 2, 3, a benzene ring with a OCH3 group over here and a NO2 group over here and 1, 2, 3, 4, 5 positive charge. Right, this is the product. After giving away chlorine, after an AlCl3 takes away chlorine, a positive charge is. Now let's count the number of carbon. 1 carbon, 2 carbon, 3, 4, 5 and 6. Can you see 6 carbons are present? Hence it can form a 6-membered ring. So let us form the 6-membered ring. The 6-membered ring formed will look something. Here is the OCH3. Here is the NO2. A 6-membered ring, right? And a methyl group at the 6th carbon, which is this. Understood? So this is the final product. Where do you think the final product is written? On the D option, right? So D is the correct answer. D is the correct answer. Very easy. Very easy. AlCl3 just takes away chlorine and then what you get is a ring product. Understood everybody? ठीक है? ठीक है? Next is this question on the screen. Consider the above reaction. Identify the product B. Extremely, this is once again a very favorite reagent of your examiners. H3PO4 and heat. And heat, understand. Acid and heat. Acid and heat. So what will acid do first? First of all, the lone pair of electrons on oxygen will attack this acid. Then what will happen? Then this OH2 will leave, leaving behind a positive charge on this carbon, isn't it? Now, what should be the next thing that should happen? The positive charge carbocation that is formed, this carbocation is primary. I can form a secondary carbocation. Then what will I do? I will do 1,2 hydride shift, right? And I will form a secondary carbocation over here, a tertiary actually. I can also form a tertiary. Now it is forming a tertiary carbocation. ठीक है? Now this tertiary carbocation, because heat is given. In heat, what happens? We always make a alkene. And what alkene? Major substituted alkene. So after the heat is given, this will convert into a alkene product, that to a stable alkene like this. ठीक है? Now you have to cause hydroboration oxidation. Hydroboration oxidation. Here the addition of OH occurs through anti-Markovnikov rule, isn't it? So what will happen? On this alkene, after hydroboration oxidation, according to anti-Markovnikov rule, OH will get attached over here. So this is the final answer. The final answer is this, which is your B option. B option. Everybody understood? Very easy question. Don't get intimidated by reagents. First, with acid, what happens? H plus is released. Then the electron pair will grab the H plus. Then it will leave as OH2 plus, leaving behind the carbocation. Now the carbocation, whenever it is formed, it can rearrange itself. Then it's rearranging itself, right? Then the next thing, what is happening? After the rearrangement, what happens? Then your alkene is formed because heat is given. Heat is given. After alkene, hydroboration oxidation, which means anti-addition of the OH. So the OH attaches on the least substituted carbon atom. Understood this thing, everybody? ठीक है? ठीक है? Next is this question. Now once again, as I told you, such questions are very, very common. Now we did KMNO4 as hot and cold.
That's a very important type of question. Another is acid, strong acid like H2SO4 as hot and cold. What will be the products? Very important kind of question once again. So what is happening? Now we're not starting with the alcohol like we did last time. Last time you will say, ma'am, you took the acid with heat and then you made an alkali because you were starting with the alcohol. That's when we start with the alcohol, we get an alkene on heating. But when we are already starting with the alkene in this case, then what will be the product when we are heating it and when we are using it in a cold format, right? So, bacha, with cold, normal reaction happens. Normal, I'm talking you about the A product. In A, what will happen with cold reagent? Simple H plus will come. H2SO4 will simply give away H plus here, right? And this double bond, the double bond is electron rich. It will attack this H plus over here. Then, bacha, what will happen? CH3, C, here is the CH3, right? And here is the CH2, and here the H will attack, here the plus charge will come, right? Now, because you are using H2SO4, that is it. So, what will happen? H2SO4, what kind of anion H2SO4 has? It has the OSO3 minus anion, isn't it? OSO3 minus anion, which will now attach over here. OSO3H minus anion, okay? Which will attack over here. So with the cold product you're getting is CH3, CH3, here is the OSO3H, and here is the CH3 product. So this is the A product that you're getting in the cold condition. What will happen in the hot? Hot means what? The reactivity is increased so much. Understand one thing, hot means very much reactive. So again with hot, what would happen? This H plus, H2SO4 will again give out H plus. This alkene will attack on this H plus once again. So we're talking about the B product now. So when this attack, what will happen? CH3, here is the C, here is the CH3, here is the CH, and here the hydrogen will attack, and here the positive charge will come. Isn't it? This first step remains the same. What is the second step now? Because the reaction, because it is very high temperature, which means it is very reactive now. Very reactive, which means what? The other molecule which is this double bond, this, and this is the CH2 here, this is the CH2 over here, right? This is the molecule that we're talking about. I've made this same compound over here. I've taken another molecule of the same compound, right? Now here what is present? Again an alkene, and we know alkenes are electron rich species. So what can happen in this case? This electron rich species can again attack the positive charge over here, isn't it? Now what can happen? Now just CH3, CH3, right? And here this alkene attacked. So here the CH3 will come. And because here the alkene attacked, here the CH2, here is the CH2, here is the CH1, 2, 3, 4. CH, CH3 and CH3. Okay? So this is the product formed in the last. In the last, this product is formed. Right? Right? So what is this product, bacha? What is this product? I think the correct answer is D. Correct answer is D. If you form D as the correct answer, you are right. D is the correct answer in this situation. Understood? Understood, everybody? Okay? Next is, bacha, this decreasing order of dehydration. Again, a very favorite question. Dehydration of the following alcohols is decreasing order of dehydration. Dehydration means what? Removal of water molecule. Minus H2O. Minus H2O. When will happen? When will happen? So, bacha, again in dehydration, what actually happens? The acid will attack. When the acid attack, this OH will leave, leaving behind a positive charge on here. So whenever the carbocation formed is more stable, that will show the maximum stability of dehydration. Very simple. So when OH will leave, the carbocation here is phenyl, least stable. When this OH leaves, the carbocation formed is this. When this OH leaves, carbocation formed is this. When this OH leaves, carbocation formed is this. Now let us see the stability of these carbocations. Can you see this carbocation is in resonance? Okay? So this is somewhat stable.
Now this carbocation is even more in resonance. Okay? So B seems to be the most stable. Then is your D. Okay? Then between A and C. In C there is no resonance present, right? But still it is a secondary carbocation, so it will be more stable. Then C, and your A is forming a phenyl carbocation, which are least stable. This is a very, very unstable species, will never be formed, right? So it will show the least stability. So this is the order. This is the order. Sorry, BDCA. BDCA. Okay, BDCA is the order. Everybody understood this? BDCA is the order. Okay. Next question. But2ine is reacted separately with 1 mole of hydrogen as shown below. Identify the incorrect statements from the options below. So this I am giving you as homework. Now we have done enough organic chemistry. I think I've discussed so many reagents and all the topics that are going to come, like your aromaticity, like what are the effects, like how will you see the acidity order, how will you see the electrophilicity order, nucleophilicity order, stability of the species, stability of the resonating structures, and what are the different various kinds of reagents that are asked, like what will happen when H plus is given to you, right? So we discussed KMNO4 in cold, hot, H2SO4 in cold and hot, right? We discussed even AlCl3. So these are the important reagents which nobody discusses. So I made sure to keep that in your head, right? Right? Okay? Try to answer this question. I will give you a certain hint. The certain hint is with sodium and liquid ammonia, transhydrogenation happens. And with palladium and carbon, cis hydrogenation happens, right? And another thing is the cis isomer has higher dipole, while the trans isomer has the zero dipole. And on the dipole, the boiling point matters, but the melting point matters only on the symmetry of the crystal structure. So these are some pointers that I have given you. This is a very important question to think upon, extremely beautiful question once again, but I'm giving you as homework. Let me know in the chat box, and if you don't find the answer, if you have any doubts related to organic chemistry until your exam, no matter when is your exam, you can personally connect with me on my Telegram channel, Nandini JEE, where I'll be replying to your questions. You can send me screenshots of your question, your doubts, whatever you have, ask me anytime. Right now, what I will do, I will stay awake with you guys. If you are awake, I'll be awake answering questions on your Telegram till your exams, just to help you out, especially with organic, especially. But if you have doubts in any other question, you can ask me as well. But organic, because it is what I'm teaching you right now, because we are familiar with each other. So you can contact me with Nandini JEE on my Telegram channel. That's my personal Telegram, to ask me personal questions directly to help out in your JEE April attempt. That's what I'm going to tell you. Now let us invite Napamita ma'am for taking your physical and inorganic chemistry, which is also very essential. TK, you can join me on my Telegram. That's all I have to say. Let me call her. Bye.
Hi guys. Oh wait. Where can we see? 1 second. Can we not see it anymore?
It's switched off for some reason.
Acha, the live stream is still on.
Yeah, that's still on.
Okay, cool. Sorry. In class. It's okay.
I'll open this.
It's okay. Hello, hello. Where is teacher studio?
I think Namrata ma'am's is open.
Really?
You can send to Namrata ma'am.
Teacher studio कहीं पे नहीं है क्या? I want to open it. Yeah. 2 minutes, people. 2 minutes. So I have not come to the studio for a very long time and I have actually forgotten how it works. Extremely sorry. Alright, how are you guys doing? How is the preparation? How is everything? Hi, Elil, Ezil, yes. Although I did forget how to pronounce your name though, bacha. All right, so hello everybody. As I always say, namaskara everyone. Andariki namaskaram, ellargu swagatam, and a very warm welcome to Vedantu JEE English channel. This is me, your master teacher 𝑬𝒐𝒑𝒏𝒂𝒏𝒅𝒊𝒔𝒆, and right now we're going to solve some physical chemistry and inorganic chemistry questions. All right? Yes, everybody, are you all with me? By the way, stick till the end because I'm also going to tell you the most important topics that you have to revise before your exam so that you can score better, everyone. Yes? All right, everybody, are we all with me? Are you all with me? Yes, yes. All right, so I'm gonna keep my phone here. So now, do you understand why I had to, postpone the 12:30 session today? I could not do the 12:30 session because, my internet was not working and I had to run to the office. Now everything got sorted. After this session, I'm going to run to my home again, and then at 9 o'clock, I'll be taking the session, guys. So please be there. We're going to do some physical chemistry direct formula based questions, everyone, which are going to be very easy, and also I'll be giving you the formula sheet at the end of that session. So be for both the sessions, everybody, okay? Do I know Tamil? Not at all, everybody. All right, guys, let us begin with our first question, and the first question is 1 gram of HCl and 1 gram of MnO2. Heated together, the maximum weight of Cl2 gas evolved will be MnO2 plus 4HCl gives you MnCl2 plus Cl2 plus 2H2O. So now here we can clearly see that this is a concept from the mole concept and stoichiometry question, isn't it? I mean, from that chapter, this question has been taken. So this is one of the most repeated topic, everybody. See, I can't give you exactly the repeated question because there is no repeated question as such, but the topics with a little bit of data change, they definitely ask you. So please pay attention, everybody, and let us try and solve it. Everybody, are we all there? Oh yeah, absolutely, absolutely. We will try to solve it. What is the time now? Yes, it is 7:37, isn't it? So I think by 8:15, 20, we will be solving it because I don't have so much question. Nandini ma'am and I, both of us are doing it together, right? So I have around 15 to 20 questions, everybody, okay? Yes, so shall we solve it, guys? Now, first of all, how do we approach this? The first thing that we are going to do is tell me what is going to be the molecular weight of HCl. Bachos, I'm pretty sure you can tell me. All you have to do is 1 plus 35.5, which will be 36.5. Isn't it, everybody? Yes, guys. Yes. All right. Yes. Apart from that, now here you can see in the reaction they have written that it is 4HCl. That means what do we have to do? 4 multiplied with 36.5. If you do, how much will you be getting, guys? How much will you be getting? Can I quickly get the answer? Hey, it's Bharat, 38.5, bro. Don't make such mistakes. 36.5, no? Yes, come on, tell me. Anybody? It's going to be 4 into 36.5. Great. Chalo, you know what? Let's not calculate this. Hai na? Now you can clearly see that 4 moles of HCl, right? 4 moles of HCl is going to give you here, see, 2Cl2, correct? So that means we can write here that it will be giving us 2 moles of Cl2. Am I right, everybody? Yes. Yes, everybody. Guys, very good. 146.5, but you know what? Let's not even calculate that. Hai na? So from here, we can understand that 4 multiplied with 36.5 is basically going to give us 2 multiplied with 35.5 because that's the molar mass of Cl, isn't it? Yes. Yes, everybody. Correct. Very good. Okay. Now, from here, let us find out. So, 1 gram is equal to how much? Let us call this as X, everybody. If we call this as X, right? If we call this as X, now can you calculate X from here, everyone? Absolutely. Why not? So, it will be X is equal to 2 multiplied with 35.5 divided by how much? Come on. Yes, you guys told me the answer. Divided by 4 multiplied with 36.5. And if you calculate this, what is the answer that you guys are getting? What is the answer that you guys are getting? Come on, everybody. What is the answer that you guys are getting here? Tell me, tell me, tell me, tell me, tell me. Yes. Tell me. I am guessing, okay, because 2 and 2. So this will be 2 2s are 4. And if I consider both of them same, they get cancelled. So 1 by 2 is basically equal to 0.5, isn't it? So which is the number that's closest to 0.5? I guess this, I think it should be option C. You tell me if this is the correct answer, guys. Yes, is this the correct answer? It should be closer to 50, isn't it? 0.5. Yes, thank you so much. Raj Mohan, Shyam, Atomic, Lokesh, very good. You guys are absolutely right. Sorry. Yes. Alrighty. Shall we go to the next question, everyone? Next question. Next question. So guys, you know what happened? I have switched off that screen. So I'm not going to look at this side. That screen, and I do not know how to switch it on. Like I said, I've forgotten how to work around in the studio. So I'm looking at my phone today for your chats, and I'm keeping it here, okay? This is right here in front of me. Yes? All right. Always right. Na re. Na, 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 na. Okay. Chalo guys, moving on to the next question here. The next question is, which of the following solutions will oxidize 25 milliliter of an acid solution of 0.1 molar Fe in +2 state and oxalate, everybody? Okay. In this question, there is one thing that you have to be very careful. See, when you say that Fe and oxalate here, iron will go from +2 oxidation state to +3 oxidation state, as well as your oxalate ion from C2O4, it will go to CO2. So there as well, the oxidation state will change. That means we will have to calculate it for both, everybody. Shall we do it, guys? Shall we do it? Yes. So initially, let us write the equation here. We all know that Fe from +2 oxidation state, it will be going to Fe +3. And here, the give and take relationship between +2 to +3 is just 1 electron. Am I right? Am I right? Very good. Absolutely. Yes. Okay. Chalo. Next, what do you have? Next, you have here C2O4. Hai na? C2O4 will getting converted into CO2. Am I right, everybody? Yes. And can anybody tell me what is the oxidation state, everybody? What is the oxidation state, guys? Yes. Here it is +3 and here it is +4. All right. Yes. Okay, guys. Yes. But here, okay. But here, what will happen is, check it out. Is this correct? Is this correct? Yeah. And here, we will be requiring 2 electrons. So that means together there is 3 electrons that we are requiring. Okay. All right. Next, what do we have? We have, see, in each of the options, we have KMNO4, KMNO4, KMNO4. What happens to KMNO4? So this was your oxidation. This was your oxidation, correct? This was oxidation. Here you have reduction now. All right, in case of reduction, we see that MnO4 minus, where it is in +7 oxidation state, it will go to Mn+2, right? And in this case, what happens? There is a give and take relationship of 5 electrons, isn't it? Yes. So there are 5 electrons here. That means the N factor becomes 5 electron, correct? But here we see that in one case, there is 3 electron. In this case, you have 5 electron. Am I right, everybody? Yes or no, guys? Yes or no? Yes. Very good. Okay, so here, let's write 5 electron. Now what we can do is we have to do we have to even write the net equation? I don't think so, because we can clearly use the concept of M1V1 is equal to M2V2. Am I right? Can we not use this concept, everybody? Directly, can we use this? Directly, can we use this? Absolutely, we can use this, correct? Yes. So that means that M1V1, here there are 5 electrons. So let us write 5 electron here. M2V2, here we have used 3 electrons. So let's write 3 electrons here. Yes. Can we do this? Absolutely, we can do this. Now see what we have to do is, now what do we have to do, guys? What do we have to do? Come on. Come on, everybody. What do we have to do now? Can't understand. What is it that you can't understand, Raja Mohan? What is it that you cannot understand? Please tell me. What is it that you can't understand? Yes, Raja Mohan, what is it that you cannot understand? See what they said. Which of the following solutions will exactly oxidize 25 milliliter of an acid solution of 0.1 molar Fe2 oxalate? That means this is getting oxidized and KMnO4 is going to go through reduction. So that's what I have just written, right? Now you have the concept of M1V1 is equal to M2V2, isn't it? So that's what we are applying. That's what we are applying. Yes. How 5 electron release? Very good. Okay, see, +7, and here what is the oxidation state? +2. So from +7 to go to +2 oxidation state, what is the difference? 7 minus 2 is 5 electron, but hey. Elementary method. Come on, elementary mathematics, isn't it? It is elementary mathematics, but do not make a mistake there. All right, so now dividing the screen. Everybody else, did you all understand? Yes, everybody else, did you all understand? Correct? Clear? Okay. All right, so now we can write as M2V2 divided by 3 is equal to M1. See, what do we have? We have 0.1 molar multiplied with 25 milliliter is the volume, right? Divided by 5. Here, if I calculate it, 5 5s are 25. 5 into 0.1 is 0.5. Now, what do we have to do is, we need 0.5. That means, for each of these, if you solve M2V2 divided by 3, you must get 0.5, okay? Let me show you for option number A, okay? Let's do this. For option number A, see, M2V2 divided by 3, isn't it? That means what we can do is, see, 0.1 multiplied with 25 divided by 3. Will this be equal to 0.5? Not at all. Right? Will this be equal to 0.5? Correct? No, not at all. This won't be. This will be around, I think, 3 into 25, right? So 3 7s is 27, 7 3s are 21, and then it is 27. So I think it will be around 0.8 something. So this is not equal, correct? That's wrong. Now if you go to option B is what? See, option B is 0.2 multiplied with 25 divided by 3. If we do this, then once again, this 0.8 multiplied with 0.2. Correct? What will be this option? Will this be equal? No, I think this will be around 1.6 if I'm not wrong. Correct? Option C, let's check it out. You have 0.6 multiplied with 25 divided by 3. Will this be? This is again 0.8 multiplied with 0.6. 8 6 are 24. So I think this will again be 2 point something. Yes? 2 point something or no. I do not know. This cannot be equal. Now let's check out option D. Option D is, guys, 0.1 multiplied with 15 divided by 3. 3 5s are 15 and this is equal to 0.5. So option D is your correct answer. Once again, this is an important concept and questions like this from this chapter has always come. Pay attention to this and make sure that you practice this. Okay? Why dividing by 5 and 3? Bachu, 3 electrons were released here, 5 electrons were released here. During oxidation, there was a give and take relationship of 3 electrons. During reduction, there was a give and take relationship of 5 electrons, right? Now, if you remember, it was N1, M1, V1 is equal to N2, M2, V2. That means that M1, V1 divided by M1, V1 divided by N2, M2, V2 divided by N1. So that is the concept that we have used. Do you remember? Yes, the equivalent concept that we had? Exactly. Yes. Shinchan, I hope did you understand? I hope you have understood. I hope you have understood. Yes? Cool? Clearly understood? Great, 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 great. Great. Okay. Okay. All right, let's move on to the next question then. Let's move on to the next question, okay? The next question, I'm guessing, is, the next question is, let 𝛎1 be the frequency of the series limit of the Lyman series, 𝛎2 be the frequency of the first line of the Lyman series, and 𝛎3 be the frequency of the series limit of the Balmer series. So guys, first of all here, do you all know what is series limit and do you all know what is the first line, everybody? Series limit is basically the last line, that is from infinity to the ground state when it is coming. That is going to be your series limit, the last line whatsoever. The first line is basically the first excited state. From there to the ground state, that will be your first line, everybody. So in this, everybody, yes, in this, what are they saying? In this, they are telling that 𝛎1 is the frequency of the series limit of the Lyman series. Series limit as in the last line of the Lyman series, okay? Then they are saying that 𝛎2 be the frequency of the first line of the Lyman series. So that is the first line. That means from the first excited state to the ground state, it is coming down. And then they are saying that 𝛎3 is the frequency of the series limit of the Balmer series. In the Balmer series, the last line of the Balmer series. Now they are saying that what is going to be the relationship between this frequencies, everyone? Okay, so chalo, let us solve it. First of all, tell me, everybody, do you all know that 𝛎 is equal to C by lambda? Do you all know about this? Yes? Yes, guys? Yes? And we also know that 1 by lambda is equal to R, yes, multiplied with, come on, guys, come on. Yes, R multiplied with Z square, and here you have 1 by N1 square minus 1 by N2 square. Correct? This is our formula. Everybody, yes? That means that, bachos, can I say that 𝛎 is equal to, from these two formulas, what is the relationship that you can figure it out? What is the relation that you can figure? Come on, everybody. Let me know. Let me know. From here, what can you calculate, guys? We can understand that 𝛎 is equal to C multiplied with 1 by N1 square minus 1 by N2 square. Am I right? Am I right, everybody? Yes. Now, according to this question, see what is going to be 𝛎1. It says that it is the series limit of the Lyman series. That means that your N1 is going to be equal to, for this, your N1 is going to be equal to 1 and your N2 is going to be equal to infinity. Put this value here. Put this value here. You will be able to calculate 𝛎1. 𝛎1 will be equal to, let's say, C, and here you have 1 by 1 square minus 1 by infinity square. Anything by infinity will be nothing, correct? Anything by infinity is going to be nothing, am I right? Yes, everybody? Correct? Correct? So 𝛎1 is equal to just C. Clear? All right, now moving this side, everybody, let us figure out nu2. Nu2, for nu2, your n1 is going to be equal to 1, n2 is going to be equal to 2, correct? So that means we can multiply C with 1 divided by 1 square minus 1 divided by 2 square. So that means that it is C multiplied with 1 by 1 minus 1 by 4, है ना? So 4 will go here, minus 1, that is 3C divided by 4. Am I right? Yes? Is this what you are getting? Is this what you are getting? Very good. Last but not the least, your nu3 is what? It's the series limit of the Balmer series, guys. What is it? Is the series limit of the Balmer series. That means, everybody, that your n1 is going to be equal to 1 by 2 square minus, for Balmer series, your ground state is 2, right? Your n1 is equal to 2. So here 1 by 2 square minus 1 by infinity square. So this, my dear student, is going to be 1 by 4. So this is going to be nothing. So C divided by 4. Now you can see that your nu3, or let's not write nu3, wait. Let's not write nu3. Let us write, acha, C by 4 is equal to nu2, 3C by 4 minus, right? 3C divided by 4 minus C if I do. So this will be 4C. Acha, sorry. 1 second, guys. Sorry. 1 second. Let's do one thing. Let's keep it as this nu1 plus nu2 if I do. Yeah. So C plus 3C divided by 4. Will I get it then? Will I get this? Will I get this? No. Which is the C, which is the this thing? Wait a second. I'm not able to calculate it. Wow. I was just scolding you that elementary method and then I have forgotten. Which is the correct answer, guys? Which is the correct answer? Yes. Is it? Acha, C. Oh, wow. Is it option A? C minus 3C by 4. C minus 3C by 4 if I do. 4C minus 3C. C by 4. I think option A. Who told me it's option A? Who had told me option A? Yes, Sai. Very good. Sai is absolutely correct. Shruti is correct. Atomic is correct. Yes, it is option number 8. That is your correct answer. Shall we move on? Okay. Now, once again, guys, please pay attention here. This spectrum-related question 1 will definitely be there. Hydrogen spectrum-related question, either they can ask you about Balmer series, either they can ask you about spectral lines, either they can ask you about, you know, what happens from this, if the electron transitions from this level to that level, then what is it going to be? So they will ask you something related to this. So please do study this question very well. Okay? At least this concept you must study very well. Okay? All right, guys, moving on to the next question, everybody. The next question is, in Bohr's model of the hydrogen atom, the ratio between the period of revolution of an electron in the orbit of n is equal to 1 to the period of the revolution of electron in the period of the electron in the orbit n is equal to 2 is. This is very simple and very easy, everybody. Yes, this is very simple and very easy, everyone. So here you have T is directly proportional to n to the power cube, correct? That means what are we going to do? We want to find out the ratio, isn't it? So T1 divided by T2 is equal to n is equal to 1. So 1 cube divided by 2 cube. That means it is 1 divided by 8, or we can write it as 1:8. So option D. Once again, everybody, related to Bohr's model of atom, there will be one question. This is a very important concept, everybody, okay? This is a very, very, very important question. So very important topic, very important concept, everybody. So make sure that you are not going to be skipping this. Okay? Shall we move on to the next question? Yes? Yes? Chalo. Yep. Okay. Okay, next question is 1 mole of an ideal gas at 25 degrees Celsius is subjected to expand reversibly 10 times of its initial volume. The change in entropy is due to expansion is. What is the concept that we have to use, everybody? Chalo, first of all, what is given to you? Let us write it out. See, N is equal to 1 mole, hai na? N is equal to 1 mole, so that means N is equal to 1. Now, what have they written? They have written that initial volume. So, V1 is equal to V, let's consider. And let us consider V2 is equal to what? 10 times of its initial volume. So, V2 will be equal to 10V. Let's just consider it to be like that. Henna. And we all know that capital R, that is the universal gas constant, it is 8.314. Am I right? Absolutely. Temperature here, my dear students, is 25 degrees Celsius. So 25 plus 273 Kelvin will be 298 Kelvin. Okay. Now what are they saying? It expands reversibly. Acha. And we want to find out entropy. So that means it is delta S is equal to, we know that it is Q reversible divided by T. है ना? So now what do we have to do? So we know that it is going to be equal to nRT log V2 by V1 divided by T. So T and T gets cancelled. That means it will be 8.314 multiplied with 1 multiplied with Acha, no, it is nRT ln of V2. So that means here we have to multiply. 1 second, guys, sorry. Here we will have to multiply nRT into 2.303 log V2 by V1. So here we will write 2.303 log, see, V1 and V2. So it will be 10V divided by V. V and V gets cancelled. Now if you calculate this, how much are you getting, guys? 8 into 2 is 16. 16 into 16 into 16. Is this right, guys? Yes? 2.303 into 8. 16 it cannot be because there are more decimal. It has to be more than 16. More than 16. I think it should be option A. Are you guys getting option A? Calculate and tell me the answer, guys. Calculate and tell me the answer. Are you guys getting option A or what are you guys getting? Yes, are you guys getting Shruti? Option A. Ezil is also getting 19.5 or 19.15. Yes. Alrighty, great everybody. Chalo, let us move on to the next question, shall we? Everybody is getting A. Everyone is getting A. Okay, everybody is getting A. Awesome, awesome. Yes, so as I told you, this. Okay, now guys, let me tell you, there are two concepts that are absolutely important from thermodynamics: reversible process, adiabatic process, isothermal. Isothermal and adiabatic reversible process, look at the graph, look at the numericals, very important. Apart from that, what else is important is from thermodynamics. You know what, I'm going to tell you this at the end, so stick till the end of the session, everybody. I have forgotten it right now. Yes, I have forgotten it right now, but I'm going to let you know about it, okay, at the end of the session. Chalo guys, moving on to the next question, everyone. The solubility product MgOH2 in water at 25 degrees Celsius is 8.9 into 10 to the power minus 13 mole dm to the power minus 3 cube. Okay. While that of AlOH3 is 5 into 10 to the power minus 33. If S1 and S2 are the solubilities of MgOH2 and AlOH3 in water in mole dm to the power minus 3 at 25 degrees Celsius, what is the order of magnitude of the ratio S1 by S2? Ready, everybody? This is going to be a lengthy question, everyone. Yes, this is going to be a lengthy question, everybody. So, chalo, let us solve it, guys. First of all, what do you have? You have MgOH2, right? MgOH2, and this, my dear student, will be giving you, what will this be giving you, guys? What will this be giving you? Come on. Yes, what will this be giving you? What will this be giving you? So we have Mg2 plus here plus 2OH minus. And they have also given you the Ksp. Solubility product is nothing but Ksp. Am I right? Yes? Solubility product is nothing but your Ksp. Am I right, guys? Come on, yes or no? Yes. Okay. So Mg2 plus, see, it is S1, right? So this one will be S1. This will be 2S1. है ना? है कि नहीं? Yes. Now, here what they have given you is they have given you Ksp. So Ksp is equal to 8.9 into 10 to the power minus 13 is equal to, we know that it is concentration of Mg2 plus multiplied with concentration of OH minus raised to the power 2. That means S1 multiplied with 2S1 raised to the power square. So it will be S1 cube and 2 2s are 4. So 4S1 cube. Now, if we want to find out S1, S1 will be equal to 8.9 into 10 to the power minus 13 divided by 4. And this, there will be cube root. Everybody, can you calculate this and tell me what is the result that you are getting? What is the result that you are getting? We are using the solubility product concept, bachu. The solubility product concept, that's what we are using here, okay? Solubility product, bacha, solubility product, that's the concept. Bharat, Vishnu, yes, that's the concept, ठीक है? Okay, so come on. I think since it is 8.9, that means that 2.2 if we do cube, how much will it be? 2.2 into 2.2 will be how much? 2.2 into 2.2 will be how much? 4.4. No, how much? Will it be around? Guys, tell me the answer, everybody, come on. If this is 13, then I think your answer should be around 10 to the power 12. 12 into 3. So this will be around 10 to the power minus 4 here. 10 to the power minus 4 here. And since this is 8.9, 4 and 4, it will be 2 point something. 4 2s are 8, right? Then 2, if we do cube root, then 2, if we divide it into 3 parts, it will be around 0.6 plus 0.6 plus 0.6 if we do, almost closer to 1.8. Will it be around 0.6? Yes? 0.6? Chalo, I'm writing here 0.6, but you calculate and tell me, ठीक है? Okay, so this is your S1. This is your S1 value, है ना? Now we have AlOH3, guys. For AlOH3, how is the, what are you going to get this side, everybody? Tell me. Is it going to be Al3 plus 3OH minus? Al3 plus 3OH minus? That means you will have S2 and here you will have what? 3S2 cube. Yes, so your Ksp here is given as 5 into 10 to the power minus 33. This is equal to 4. Is it 4? Is it going to be 4, everybody? No, what is it going to be? 3S2 cube. So 3 3s are 9, 9 3s are 27. Not 4. It will be 27. Sorry. This here, right here will be Ksp is concentration multiplication, right? Product of the concentration. So 3 3s are 9, 9 3s are 27. 27. S2 to the power 4, correct? S2 to the power 4, is that what we will be getting? Is that what we will be getting? S2 to the power 4, isn't it? Yes, S2 to the power 4. Now, what do we have to do? 5 into 10 to the power minus 33 divided by 27 is going to give us S2 to the power 4. So, Here what will we be getting? Guys, come on, calculate this. This I won't be able to calculate verbally. Sorry. I'm not Einstein's granddaughter. So quickly calculate and let me know, guys, what is the answer here? What is the answer here, guys? 3.7. Is that what we're getting? S2 value is how much? 3.7. 3.7 into 33. So around minus 12, 13. No. We are not doing minus 33, 4, right? So 30 divided by 4 will be around 4 5s are 30. 4 5s are 20. 4 9s are almost 36. So 3.7 minus 10 to the power 9. We can do this? Correct. Now what do we need? We need S1 divided by S2. So that means how much are you going to get? You will be getting 0.6 into 10 to the power minus 4 divided by 3.7 into 10 to the power minus 9. If you calculate this, then minus 4 and minus 9. So this will go up. Whatever this is, 0.6 and this is 3.7. So 6 5s are 30. 1 divided by 5 will be 0.2 or something. But this answer will be 10 to the power 5 only, right? Oopsie, what just happened? Why is this not working? So this will be 10 to the power 5, correct? Minus 9, minus 4. So option A. Option A is the correct answer, am I right? Option A is the correct answer? Yes? Yes. Okay. All righty. So option A is your correct answer. Okay. All righty. Next question, everybody. This is wrong. This is wrong, guys. This is wrong. This is your correct answer. Okay. 10 to the power 5 is the correct answer. Chalo. Next is equivalent mass of the ferrous oxalate in its titration. With KMnO4 is 48. This is because ferrous oxalate is triprotic acid. No. Oxidation number of carbon changes from 2.5 to 4, not at all. We have just done that question. Do you remember? C2O4 plus 3 to plus 4 it goes. So this is not, definitely wrong. No, not at all. Total charge on cation as well as anion is 3, not at all. We just saw it, right? Just before some time back only we have done this, right? Fe, C2O4 and KMnO4, that 3 electron and 5 electron thing, that 3 electron and 5 electron question we have done, right? So there also we saw that this is not the correct answer. Oxidation of Fe plus 2 to Fe plus 3 as well as oxalate ion to CO2. Hence equivalent mass becomes 1/3 of molecular. 1/3 of molecular. This will be 1/3 of molecular mass. Okay, what is FeC2O4? What is the molecular mass, guys? Molecular mass of FeC2O4 is, if you calculate it, is around 144. And if we do 144 multiplied with 1 by 3, what will we be getting? 3 5s are 15. So it's not that. 3 4s are 12, 24. 3 8s are 24, 48. Absolutely, option D is your correct answer. Option D is your correct answer, right? Yes? Yes, option D will be the correct answer. Okay? All right, Bharat, you can do it. However you can come to the, however you can, derive the answer, absolutely works for us. Works for us. Definitely it works for us. Okay? Yes, maths is completed, bacha. Maths is completed. Chalo, are we done with this, guys? Let us go to the next question, shall we? Let us go to the next question. Yes, the next question, everybody, is decomposition of X exhibits a rate constant of 0.06 microgram. How many years are required for the decomposition of 5 gram of X into 2 gram? You know what? This should not be 2 gram. This should actually be 2.5 gram, because this is the question that is relating it to half-life, okay? This is a question that uses the concept of half-life, everybody, and that is a very important concept from the perspective of your JEE question. So this will be 2.5 microgram, ठीक है? Now, do we guys know the answer, everyone? Yes, do we guys know the answer? How do we calculate it? We can calculate it as T half is equal to, we know that it is A naught divided by K. What is A naught? A naught is your initial concentration. है ना? K is your rate constant. What do we have to figure it out? How many years are required for decomposition of 5 gram of X, everybody? How do you calculate it, bacha? How do we calculate it? We will be calculating it as T half is equal to, what is A naught? A naught is for the decomposition of 5 gram of X into 2.5 gram and exhibits a rate constant of this. Rate constant is given to you. Yes, and the initial concentration, everybody, is 5 micrograms. So this will be 5 divided by 0.06. है ना? And what do you need to figure it out? 2.5. Correct? Yes, but it will not be 2.5 here. 2.5, it has to decompose, right? Decomposition of X exhibits a rate constant of 0.06. So rate constant is this, K. Here we have to multiply 2. It will be 2. How many years are required for the decomposition of 5 gram of X into 2.5? So this is it. This is it. Okay, so 2 into 5, if we do, it will be 2 2s are 4, 4.2 2s are 4, and then 1 will be left, so it will be 2.5. 2.5 divided by 0.06. Guys, calculate how much is it? How much is it? How much is it, everybody? Yes? Option C? Hey, how is it option C? How is it option C? I don't think it is option D. Option C? Not at all. Not possible. 5 gram divided by 0.06 into 21. It should be around 40. I think option D is correct. But please, can you check the answer once? Calculate this and find out, everybody. Calculate this and find out once. Is it option D, guys? Is it option D? Yes? Bharat, is it option D? All right, I'm gonna listen to Bharat. Yes, option D is the correct answer. Yes, option D is your correct answer. Chalo, guys, let us move on to the next question, everyone. Option D. Yes, option D is the correct answer. Which of the following is not an amphoteric oxide? PbO, definitely yes. Al2O3, yes, definitely. SNO. Guys, do you remember the mnemonic that I taught you? The mnemonic was what? Mnemonic was what? Alia and Zoya. What was it? Alia and Zoya sang Punjabi song, but Aishwarya fetched crores. Okay, these elements, they are going to have amphoteric oxide, everybody. Okay, they are going to have amphoteric oxide, everybody. And Si here, guys, this is a non-metal. Non-metallic oxides are acidic in nature. So this is your correct answer. Yes, this is your correct answer. Easy peasy biryani tasty, wasn't it? Easy peasy biryani tasty, everybody. Yes or no? Yes, SiO2. Very good, Krishna. Chalo, guys. Moving on to the next question, everyone. The next question is the KSP AgCl is equal to 10 to the power minus 10. The minimum volume in liter of water required to dissolve 14.35 mg of AgCl is. Come on, guys. Let us solve it, everybody. Yes. So what is our AgCl? AgCl will dissociate and form Ag plus Cl minus. That means our KSP is going to be equal to S square. Right? And that S square is equal to 10 to the power minus 10. That means that from here, S is equal to what, guys? What will be your S, everybody? What will be S? 10 to the power minus 10. Simple. Yes, it will be 10 to the power minus 5. Right? Yes. Isn't it going to be 10 to the power minus 5? Absolutely. Okay. Now, what is going to be the molecular weight of AgCl? Anybody? Anybody? What is going to be the molecular weight of AgCl, guys? It's around 144, 140, 35.5, right? 35.5. So it will be around 143.5. Am I right? Yes, 143.5. Correct? Okay. Now see, it is going to be very easy. All you have to do is, so here you have 10 to the power minus 5. This is equal to, how do you calculate this? Yes, this is going to be equal to, see, 14.35, 14.35, right? Yes, multiplied with, since this is milligram, so we will do 10 to the power minus 3 divided by 143.5 multiplied with 1000 divided by, what do we need? We need the volume. Yes, we need the volume. Now if we calculate this, minus 3, this cancel, minus 2 will be left, 14.35, 143.5, this will all go, it will be only 10 to the power minus 1, this is equal to 1000 divided by V. So if V goes there, that means this will be 10,000 milliliter. Yes, and that means that it will be equal to 10,000 milliliter. What is the answer, guys? It will be equal to 10 liters, right? 10 liters. So option B is our correct answer. Done, 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 everybody. Come on, guys, let's see your chats. Yes, guys. Done, done. Option B, very good, Shruti, very good, very good, very good. Yes. Yes. 10 liter, Punita, very good. Ashok, very good. Yes, it is option B. It is option B. Well done. Chalo, guys, moving on to the next question. Shall we? Shall we? Okay. Next question, everybody, is the electronic configuration of divalent Yb+2 and trivalent gadolinium +3R. Atomic number are given to you. Xenon is 54. Cerium is 58. Yes. Ytterbium is 70. Gadolinium is 64. Acha. Yb is 70, right? If 70, that means that Yb+2 will have how many electrons? 70 minus 2 will be 68, right? So for 68, for Yb+2, the electronic configuration is going to be xenon. So 54 is done. After 54, how many electrons are there? 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 67, 68. 67, 68. So 4F14. है ना? Okay. Next is, what do you have next? What do you have here? Gadolinium +3. So gadolinium has how much? 64. If it is +3, that means it will have 61 electrons. If it is 61, so for gadolinium +3, how can we write it? We can write it as xenon here. Xenon is 54, 54, 55, 56, 57, 58, 59, 60, 61, 7. So 4F7. That means option A. Okay, option A is your correct answer. So guys, again, another important point. From D and F block, there are three concepts that are very important. First of all, preparation and properties of potassium dichromate. Secondly, preparation and properties of potassium permanganate. And third of all, electronic configuration of the F block elements, especially the exceptions such as cerium, europium, terbium, gadolinium. Maximum, if they want to make it a little tough, it will be samarium, lutetium, and obviously lanthanum. All right. So these are the few elements. Note it down, whatever I said, if you want. But these are the few elements that are very, very, very absolutely important. They may ask you, especially they can ask you that if this is a good reducing agent, is this a good oxidizing agent for terbium and cerium and europium? They can ask you such questions, everybody. So please, before you go to the exam hall, make a note in your mind that you know the electronic configuration of these elements that I have just told you. In fact, let me tell you once again, guys, it is going to be cerium. It is going to be Yb, definitely. They're going to ask you about terbium. They're going to ask you about europium. Max to max, if they want to make it very tough, then they will ask you about samarium. All right. Lutetium definitely, and lanthanum definitely. So these are the few elements that you have to make a note of electronic configuration from the F block. Yes. All righty, guys. All righty. Hey Krishna, don't study everything from D block. Before you go to the exam hall, make sure that you know each and every reaction from potassium dichromate, potassium permanganate. I promise you, D and F block, you will be getting at least 4 to 8 marks, and that you will be able to get it free of cost marks, guys. Do not miss out on it. Okay? Do not miss out on it. Chalo. Moving on to the next question, everyone. Let's go, let's go, let's go. The next question, everybody, is which of the following order is incorrect? O2 minus will have a lesser increasing Z effective. Okay. Mg2 plus will definitely have more Z effective charge, then Na plus, then F minus, then O2 minus. This is absolutely correct. Okay. Option number 2. Mg2 plus increasing size. Yes, Mg2 plus will have a lesser size than Na plus. Absolutely. O2 minus F minus. This is where the mistake is, right? O2 minus will have a bigger size than F minus. So this is your incorrect option. Increasing ionization enthalpy, absolutely. Once you have taken away 2 electron, after that ionization enthalpy is definitely increasing. Increase in electron affinity, yeah, that is also making sense. Option B is your correct answer, guys. Yes, option B is your correct answer. Cool. Chalo. Cool. Next question, everybody, is okay. PT glycinate Cl Br+1 has n number of geometrical isomers. Okay, let us draw the structure here. So you have PT. This is a bidentate ligand, everybody. Bidentate ligand. So we can write here gly here, connect it here. So we will have Cl here, we will have Br here. This, consider this to be, if this is cis, then we will have another where we will have this and we will have trans. So there are 2 geometrical isomers, right? There are 2 geometrical isomers, and that 2 is equal to n. Now, then the spin only magnetic moment and crystal field stabilization energy, CFSC, of NiNH3 plus N. That means what they're saying is that NiNH3 here, NiNH3 here they have written plus N, right? So that means this will be in +2 position. Acha. Now everyone, we all know that nickel has an atomic number of what? 28, am I right? Yes. Nick's cousin. Zinc is 30, copper is 29, this is 28. If it is 28, that means it will be 3D8,4S2. Everybody clear? Okay. Now, Ni in +2 oxidation state, guys, Ni in +2 oxidation state will have 3D8, everybody. Yes. Here, okay, NH3 is not a very weak fill ligand, no doubt about it, okay? NH3 is not a very weak fill ligand. In the spectrochemical series, you find that NH3 is almost in the middle. That means it does act like a, it does act like a strong fill ligand. However, the moment you have 3D8, everybody, that means if we draw it, so we will have 1, 2, 3, 4, 5, 6, 7, 8. Even if I try that NH3 acts like a strong fill ligand, the pairing up will not make sense because only one d orbital will be empty. So the hybridization will definitely become sp3 hybridization, right? 1s and 3p, correct? No, octahedral, right? So sp3d2 hybridization, 2 unpaired electrons. So your magnetic moment mu is supposed to be equal to 2 point something something. Mostly if it is 0.75 more, so it will be around 2.8. Okay. Now, how do you calculate CFSC? How do you calculate CFSC? CFSC, how do you calculate, guys? How do you calculate CFSC? You calculate it as first, what is there? What do you have? You have T2G first. T2G is first, which is -2/5 because it's at the bottom. Now, sp3d2. So these 3 will be in T2G. these two will be in Eg. There are T2G 6. So minus 2 by 5 multiplied with 6 plus Eg has gone up by how much energy? 3 by 5. So this will be 3 by 5 multiplied with 2. 2 6 are 12 and it is divided by 5. So it will be minus 2.4 plus 3 2s are 9. 9 divided by 5. 9 divided by 5. 5 1s the 5 and 5 1s are 5. After that, what will happen? 5 2s are 10, isn't it? Yes. So I think it's 1.2. So that means that it will be minus 1.2. So which is the correct option? Minus 1.2 delta octahedral splitting. So option C is your correct answer. And this is a replica of a question that has actually come exactly, a ditto question like this has come in our past or previous year question. Okay, ditto question like this has come in the previous year, everybody. Okay, all right, everybody. So guys, is this great? Guys, are we clear with our concept? Everyone? Yes? Is this clear with our concept? Very good. Option C is your correct answer. Alrighty then. Moving on. Oh, we're done, guys. We're done. Acha, so here are your most important concepts, everybody. As you all see, periodic properties. Yes, from the chapter periodic properties. This is from inorganic chemistry. You have atomic radius, ionization energy, electron affinity, electronegativity, and bond dissociation energy. This I don't think you will find, but I have seen in a couple of paper that I checked out. Okay, I have not just checked couple of paper. Let me tell you that I have checked 2020, 2021, 2022, 2023, yes, and 2024. Out of all of these past 5-year question, I have noticed, everybody, yes, I have noticed that they have asked you certain questions related to Cl-Cl bond dissociation energy. If Cl2 bond dissociation energy is this much, then what do you expect it to be for fluorine? What do you expect it to be for iodine? They have asked you such questions. So bond dissociation energy, please do read it once. Okay? All right. Please promise me that you will read it once, because if you read it, you can come back and tell me that, yes, ma'am, it worked, guys. Please do let your friends know as well. Okay. Moving on, in P block, nature of oxide, amphoteric, acidic, basic, what is this? They will definitely ask you. Physical properties of P block, and definitely one question for anomalous properties. Okay, I don't think they will be asking about carbon, but there's just a feeling that they may ask you something about nitrogen, maybe. Just a gut feeling that tells me that, you know, they will ask you about some properties of nitrogen in one of the shift, everybody. So please make sure that you study this. Okay? From coordination compound, Werner's theory, everybody, do study it. Do study it. Just the first page of coordination compound. Mark my words, guys. You guys can do a great job here. Okay? You guys can do a great job here. Then you have valence bond theory, isomers, and magnetic moment. One question may come. From DNF block, guys, once again telling you preparation and properties of potassium dichromate and potassium permanganate. Physical properties, it's not that important, but they have asked, certain times they have asked you about the DNF block physical properties. And last but not the least, do not forget to check out electronic configuration of F block elements. I have also told you which elements are not to be missed at all. From chemical bonding, molecular orbital theory, they will ask you that use molecular orbital theory to find out what is the order of, you know, O2 minus, O2 2 minus, O2 plus, or O2. They will ask you such questions, right? What is the geometry, what is hybridization and shape? They will ask you about this. From mole concept, concentration terms, stoichiometry and limiting reagent, structure of atom C, Bohr's model, de Broglie equation, quantum numbers. Quantum numbers, they may ask you that which of the quantum numbers are allowed. If this is the if this is the magnetic quantum number, then what can be the azimuthal quantum number? Such questions may be asked. And Heisenberg's uncertainty principle can be asked. From chemical equilibrium, KEQ, that is equilibrium constant, Le Chatelier's principle, especially take a look at common ion effect and, you know, such properties that we have studied about in Le Chatelier's principle where we use it. Yes, okay. Then, ionic equilibrium, salt hydrolysis, solubility product, the pakka, guys. Solubility product is a pakka. If they ask you anything from ionic equilibrium, mostly it is going to be solubility product and pH of buffer. Thermodynamics, thermochemistry, work done, adiabatic and isothermal reversible processes, Hess law of combination and internal energy, DH, etc. Redox titration of KMNO4, K2Cr2O7. So guys, do you see that KMNO4, potassium dichromate, potassium permanganate, is an absolutely done question, guys. This is there in 2 chapters, so they can combine redox and they can combine DNF block, and they can ask you each and every reaction that is related with potassium permanganate and dichromate. It's a must, absolute must. And last, iodometry. Okay, then again from electrochemistry, Nernst equation and Faraday's law. I mean, that's given, kind of, that's given, right? Oh, one more. Electrochemical series and maybe preferential discharge theory also. Okay, here let's mention PDC, that is PDT, sorry, preferential discharge theory, and electrochemical series. So ES I'm writing. Okay, chemical kinetics, first order question, mostly first order question. Half-life numericals and Arrhenius equation, graph studied how to plot the graph, what is the relation between log k 1 by t, ln k 1 by t, graph as well as numerical, and how to find activation energy. Okay, they may give you 2-3 activation energy, then they ask you that this is the relation. That can be a question. Or they can ask you that minus EA by RT is equal to this much. Now find out what is the activation energy. These type of questions may come, so please take a look at it. Okay, and if by chance they want to deviate a little bit, then maybe they can ask you about what was this question that they used to ask. There was this one particular concept that if at all they want to deviate a little bit, if they don't want to follow this, then they may ask you, why have I forgotten it right now? Oh my God, why have I forgotten it right now? Effective collision. Yes, if they want to deviate a little bit, then they may ask you about effective collision. Okay, only then. Otherwise, these are the important ones. So this is your effective collision. Chemical equilibrium is already done. Solution, colligative properties, done, absolutely, and Van 't Hoff factor. So these are the predictable concepts from where they can ask you the question, everybody. And last but not the least, this is your Vedantu JEE English channel, guys. Do not forget to like, share and subscribe. And I'm going to give you one question for homework. Thank you so much for being here. One question, just this one question, everybody. I need you all to do this so that you are absolutely focused and you know that you have attended ma'am's session. You know that you have attended the whole mock test paper, everybody. After this, now I'm gonna go home and I'll see you in the physical chemistry session, everybody. With this note, tara bye-bye and good night. Tara bye-bye and good night, everybody. Okay, yes, tomorrow there will be YouTube live up, absolutely. I've told you, Tanush Kumar, don't worry about it. I'll be sending you the PDF, okay? All right, I'll be sending you the PDF, guys. I'll be sending you the PDF. Don't worry about it. I'll let you know. Okay? 𝑯𝑨𝑽𝑬, VIT EEE, we will do it in some time. First, we have to make sure that we are done with our JEE, isn't it? Okay. Alrighty, guys. Bye-bye. Good night. But where do I stop it? Oh. Okay, I cannot see anybody. And I don't know how to stop it. How do we do this? Okay, you know what? I'm gonna go downstairs and then stop it. Yeah?